build, 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 build. Go, go, build, build, build. Go, 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 build. Go build, 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 go build. There is no compression algorithm for experience. Def and test, def and test, def and test are the most important workloads. Dance like nobody's watching. 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 Encrypt like everyone is. There has never been a better time to build. 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 There has never been a better time to build. You build it. You run it. 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 You build. You run. You build. You run it. You build. You run. Go build.
Hello everyone, a very good morning. I'm Sukanya Mandal, Community Leader, AWS User Group Mumbai.
Hi everyone, I am Dipali Gulshrestha, Community Leader for AWS User Group Delhi NCR.
A very good morning everybody, this is Sridevi from AWS User Group Chennai.
We welcome you to AWS Community Day India 2020 Virtual Edition. AWS Community Day is the flagship annual developer or technical event of AWS communities and user groups globally. User group comprises of a set of people who have similar interests, goals, or concerns. The members have regular meetings where they can share their ideas. Ideally, the members of a user group live in the same geographic area so that they can get together in person. A user group may be dedicated to a technology or corporation. As this is a community event, the main priority is to make this event inclusive and harassment-free. Hence, this community day will be conducted by strictly following the code of conduct. I welcome Dipali to introduce you to AWS communities and user groups.
Thank you, Sukanya. Let me introduce AWS communities to all of you. There are more than 400 AWS-focused user groups and communities globally. The common objectives of AWS communities and user groups is to have peer-to-peer learning, share the best practices, pitfalls, upcoming features, troubleshooting, and to discuss innovative use cases. These user group communities are not only limited to working professionals, but it also welcomes all like-minded people who are interested to learn and share knowledge about AWS. We have audiences from different age group and backgrounds, catering university students, undergraduates, job seekers, organizations working for potential employees, developers, DevOps professionals, solution architects, evangelists, technical architects, co-founders, business analysts, and all CXOs like CEOs, CTOs, CIOs, CFOs, and COOs. We have audience from a different scale of business, from stealth mode startups to bootstrap and funded startups, plus small and medium business and enterprises. AWS User Group and Community in India started in January 2011, where very first user group was formed in Bengaluru with 100 plus members during the initial days. Now, AWS User Group Bangalore has over 8,000 members hosting regular monthly meetups. Other cities in India like Delhi NCR, Chennai, Mumbai, Kochi, Pune, Ahmedabad, and Surat started emerging rapidly and growing the member base. Fortunately, there is no impact on meetups due to pandemic. Earlier, these in-person meetups were limited to just one city, But now people are leveraging virtual meetups worldwide. Apart from our regular monthly meetups, we do organize other events as well. For example, we recently conducted AWS Women in Tech Day for the first time. It was an online event with more than 2,200 registrations where precisely 1,174 participants attended the event with 14 women speakers from AWS and AWS community across India. Another advantage of being the part of AWS community is that you get exclusive training offers. The APN training partner, Trainocate Cloud Academy, offering 50% off on AWS trainings, 1,000 rupees Amazon gift voucher for first 500 registrations, 3 complimentary practice tests with each registration, and additional 10% discount for referrals. To find out a meetup group near you, you can visit meetup.com and search for AWS User Group. AWS community leaders, members, and heroes get to meet people from other cities and countries. They interact with them, share, and learn from their experiences. As mentioned earlier, apart from our regular monthly meetups, we also host several other events. And most important one for all the user group is AWS Community Day. AWS Community Day, commonly referred as ACD, it is the flagship annual developer and technical event for AWS communities and user groups globally. The format of ACD is proposed by AWS to encourage local user groups to host 1 or 2-day events apart from regular meetups. ACD gained huge attention very recently globally. Multiple cities and countries are coming together to host ACDs locally. In India, very first ACD was hosted in Bengaluru in 2017 with 250 attendees. As AWS always encouraged to raise the bar. In 2018, Bengaluru hosted second edition of ACD with 400 plus attendees with multiple tracks and sessions. And 2019 was the year of community days for all of us. Bengaluru recorded 900 plus attendees with 4 tracks and 30 plus sessions and workshops. Ahmedabad, Chennai, Mumbai, Kochi, and Pune hosted the first community day with multiple tracks, session, and 400 attendees last year. By the way, ACDs are run by user groups and communities. All the speaker sessions are handpicked and curated by community leaders and members. First time ever, all the 18 cities of India have come together to host Pan-India AWS Community Day as one nation and one community. Hey Sridevi, since you are AWS Community Hero, would you like to shed some light on this AWS Hero program, please?
Sure, Dipali. Thank you, Sukanya and Dipali, for a great start. Let me spend a couple of minutes talking about AWS Hero Program. So AWS Hero Program recognizes vibrant AWS experts whose enthusiasm for knowledge sharing has a real impact within the community. So the knowledge sharing can be in different forms. I've listed a few of them below, but there is still a lot of ways you can share your knowledge with the community. So you can write technical blogs, you can contribute to open source projects, participation in online forums, speaking in engagements like community day, meetups, reInvent, and you can also provide mentorship to college students, freshers, and people beginning with cloud, and conducting workshops and hackathons. We have displayed all the community heroes of India as of today. So we have Ankit from Kolkata User Group, Bhuvneshwari, Satya, and Jeevan from Bangalore User Group, Gaurav from Mumbai User Group, Nilesh is from Ahmedabad User Group, and Partha from Chennai User Group. Apart from community heroes, AWS also recognizes individuals contributing to a specific stream of technology as category heroes. As of today, we have 5 category heroes in India. Prashant is our first serverless hero. Jayesh is our first ML hero. Dawal is another serverless hero in India. Sandeep is our first container hero, and I'm the first data hero of India. Let me take a minute to talk about Jayesh, who is the youngest AWS hero within India. He is just finishing his college this year, yet he is an ML hero because of his immense contribution to the community. He is the organizer of AWS User Group Pune and has hosted multiple community events, including AWS Community Day 2019. To become a hero, there is no age bar, no eligibility conditions. It is absolutely dependent on your passion to learn and share your knowledge within the community and create an impact within the community. With the communities growing very fast, we hope to see a lot more heroes in the upcoming years. That being said, hey Sukanya, you received a scholarship to attend reInvent last year. Why don't you share some of your experience?
Sure, Sridevi. Thank you. So yes, as a part of as a qualifying candidate of the scholarship, I got to attend the 2019 December AWS reInvent held at Las Vegas. It was indeed a splendid experience for me with loads of learning opportunities. Alongside learning opportunities, one of the best experience was getting to meet Dr. Werner Vogels at the Heroes Dinner. I also got the opportunity to present a talk on machine learning at the IoT Edge in the DevChat area. Other notable experiences of attending AWS reInvent included priority sitting opportunities at all the keynote sessions, and also getting to meet and collaborate with various other community leaders across the globe. It was indeed a very good experience for me. That being said, this year reInvent is going online. We encourage all of you to be a part of it. Now, coming back to this community day, this virtual edition of this community day, community events are made possible only by volunteers. At this community day, all the user group leaders from Pan India have come together towards planning and execution of this event. Also, an event of this scale cannot only be possible with just a few volunteers. Along with volunteers, we have many student ambassadors from different regions across India who are playing a crucial role towards the execution of this event. So, what's in store for you today? Dipali will walk you through the agenda of the day. Over to you, Dipali.
Sure, Sukanya. So it's time to unfold the agenda, which has been crafted beautifully to ensure that this event proved to be a well-invested time for each one of you, and you get ample opportunities to explore and enrich your expertise on AWS offerings. We will start this ride on a very inspiring keynote with none other than our own Jeff Barr. Then, from 10 a.m. onwards, we have 12 sessions lined up in 2 parallel tracks to dive you deep into the AWS ocean. Track 1 will give you more insights on Aurora Global Databases, serverless, infrastructure as code, Ansible, and security with Lambda. While in track 2, we have real-time streaming, cloud governance, AI/ML, CI/CD, and much more. We also have few workshops lined up for tomorrow where you can get your hands dirty with us on containers, serverless, and AI/ML. Apart from these sessions and workshops, we also have very interesting quizzes and games planned throughout the day. Sridevi, would you like to share some details around quiz and games, please?
Yeah, sure, Dipali. So we have 2 exciting contests lined up for today. There are 2 quizzes that will be run in 2 different slots. The top 10 in the leaderboard will win Amazon vouchers. The first quiz is already live. It is between 9 and 9:25 a.m. today. Please find the link in the description of the YouTube channel. The second quiz will be available between 1:30 and 2 p.m. Also, we have our social media team monitoring for the best tweets, and the best 10 tweets will win Amazon vouchers. All the winners will be announced during our closing note today, so please stay tuned. This is the QR code for the quiz 1. You can use your scanner to participate in the quiz. Before we close our welcome note, I would like to share a few housekeeping rules. So all the sessions are recorded. Links to all the slides, recorded sessions, and learning resources will be shared after the event via email and updated on the website. There will be Q&A sessions after every talk. Speakers will try to answer 3 to 5 questions after the session from the stream. Rest of the questions will be answered offline. So if you have any question, please drop them in the comment section. The live chat is meant only for technical questions and discussions relevant to the sessions. Please refrain from any unnecessary messages. Thank you, and looking forward for an exciting event today, and hope everybody will enjoy and have a lot of learning experience. We'll keep the quiz open until 9:25, and please use the QR code here to participate in the quiz and stand a chance to win Amazon vouchers. Thank you. All right. We'll keep the quiz open for some more time. So please feel free to play the game until the end of day today. I now invite Jeevan, AWS Hero, to introduce our keynote speaker, Jeff Barr. Over to you, Jeevan.
Thank you, Sridevi, for the warm welcome. Good morning, all, and welcome to AWS Community Day India Virtual Edition 2020. It is said that great stories happen to those who tell them. Truly so, it is an honor to have one of the best storytellers of our times as our keynote speaker today, Mr. Jeff Barr. He has been the face of AWS for the past 18 years, sharing his accurate insights, informative experiences, and holistic view through blogs, videos, social media, and most importantly, his talks. Today, he will be speaking about rethink, reinvent, and rebuild. Jeff, it is pleasure to have you today, and welcome to AWS Community Day India Virtual Edition 2020. Jeff, over to you.
Thanks for having me. I'm super happy to be here. Thank you for the great introduction. I'm coming to you live from Seattle, Washington. It's a little bit before 9 o'clock in the evening. It's been a long day, but a good day. And I have to say, I've been looking forward to this presentation all day, maybe even all week. I actually super enjoy this opportunity to create content and to share it online. In the first days of quarantine, it was a little bit weird to not have audiences, but I'm starting to actually find it a really wonderful way to create and to share. I actually presented earlier this week in Dublin. Don't think I could really manage Seattle, Dublin to India in the course of a single week. So here we are, live and online and virtual. Thank you so much all for attending and for all the wonderful tweets I've seen so far. I know the expectation's been building up, and I'm super thrilled about all those tweets, and I sure hope I can actually live up to all of the wonderful expectations that everyone has set. My presentation today, I call it Rethink, Reinvent, and Rebuild. I put this together just a few days ago, actually, and I know that there's a lot of keynotes where they say, well, here's the cloud, and let's talk about the latest and greatest features, and it's somewhat self-contained within the cloud space. I tried to think a little bit broader for this presentation. I think we're in a really unique spot within the world right now, and I tried to capture a little bit of where we are and a little bit of the uniqueness and the strangeness, and then a lot of thoughts, ideas, suggestions about maybe how we can not just get through it, but how we can maybe innovate past it and take this as an interesting time to do something new and exciting and perhaps even amazing. So here we go. First off, I would love to congratulate all of our heroes and our student ambassadors. Love the fact that you're all part of this amazing AWS community in India. Tens of thousands of the number I've heard, which is super awesome and super amazing. These things don't just magically happen. They happen because a lot of really dedicated people just decide that they're going to put their personal energy into actually making something happen, and never take for granted the energy, the requirements, the personal time investment that all the wonderful people have invested into this event today. I know that there's a lot of thinking of a show as simply a lot of infrastructure behind the scenes and things just kind of happen. The reality is it happens because a lot of people go above and beyond and make that happen. So once again, thank you for everyone who organized and for our heroes and our student ambassadors. I always like to start with just a tiny bit of background. I'm kind of old for being in the tech business. I was born in 1960. When I was a teenager in 1976, I was lucky enough to get to work in one of the first computer stores in the world, right here in Seattle. And my official job was simply take all the books and magazines out of boxes and put them up on the shelves. But I decided I'm going to go a little bit beyond that. Every time I'd get something new, I'd open it up and read it, and I'd study all of the new tech, the hardware, the software, the industry. And as a result, what happened very quickly is, despite the fact that I was by far the youngest store employee, when customers would walk in, they would always be directed to me as the person who actually understood what was going on, because I understood the tech and I really, really enjoyed explaining it. The totally bizarre thing is that I think 43 years later, I'm effectively still doing the same job, studying tech in detail and then just doing my absolute best to understand it and to explain it. I learned along the way that your age doesn't matter, your background doesn't matter. It's simply knowing the facts and being energetic and willing to share those with anyone who's ready to listen. Early in my career, I spent time as a developer. I was VP of engineering at a couple of startups, spent some time doing consulting. Joined Microsoft in 1997, spent some time working on Visual Basic and Visual Studio and the very, very early parts of .NET, very specifically web services parts, and then joined Amazon in early 2002 when I saw that web services was just on the verge of happening at Amazon. Earned a degree in computer science back in the 1980s, went back to school in 2010 while I was working to earn a Master of Communication in Digital Media at the University of Washington, just a couple miles from where I am just right now. Highly advised, late mid-career, go back to school, learn something new, pick up some new skills, perhaps get a little bit of a fresh perspective on who you are and what you'd like to do. By the time I was 21, I'd actually used all of these different pieces of what are now ancient history. I could tell you amazing stories about all of this, but the really important lesson I learned is every one of these things is just a point in time. There's got its good points, its bad points. Whatever you touch, take it, use it to the utmost, but always look forward to the next thing that's about to be launched and learn from the current generation, take what you learn and apply it to the next generation. Do that over and over and over again through the course of your career. A couple things I want to talk about today. First, because we're at a community-powered user group, I for sure want to spend a little bit of time talking about the role of community. But then my three main topics: rethinking, where are we? Reinvent, how can we go about solving some challenges in a new way? And then rebuild. How are you as attendees at this amazing AWS Community Day? How are you going to take what you've learned through today and tomorrow, take all of that and put it to use in perhaps some brand new ways? Okay, so where are we? Get this sense from thinking about the world right now. It kind of feels like everything suddenly changed the first couple months of 2020. For a while, we had this kind of great stability, and now we've got, it feels like the ground itself is kind of loose. We're not quite sure of what is a constant, what is a variable, to kind of think of things in a tech space. If our lives were something of a machine right now, kind of feels like all of the nuts and bolts are just a little bit loose and all the parts are just a little bit wiggly right now. Little bit scary, a little bit challenging at times, but I also think, I really strongly think that first of all, we just need to get through this, okay? Baseline, we need to keep ourselves healthy. We need to survive. Let's just take that as, okay, that can be hard enough. We just got to do that part. If we're doing okay there, and then the bonus, we've got this privileged position. Perhaps as technologists, we can start looking at all these great opportunities. Now that we've got these constants that have become variables, we've got things that are in a kind of a process of change. The good part of that, I think, people are actually very open and very receptive to new ways of doing things when perhaps they weren't receptive just a year or so before. The way I see it, innovation is needed, and people are ready for it. That's the great thing. Because people have been so broken loose from the old ways of doing and living and thinking, they're saying, well, we're ready for some change. Changes are happening. Let's go into the future and actually embrace it a bit. So I really think we're at a really interesting point in time and in history where we've got some just really cool opportunities. I think in a lot of fields, especially in the privileged space that we occupy and in the technology field, we've known that being able to be online and connected and having a lot of choice of working environments and working locations and working times, we always kind of said, that's a really interesting benefit of this special privileged position that we have. And we always thought, well, sometime toward the future, we're going to be even better at taking advantage of that. My sense this year, we actually got into this time machine and we accelerated ourselves into the future. We've had to, just out of absolute total necessity, we had to make some very, very quick changes in the way we work and the way we live. But I don't think some of this is temporary. I think we've conducted a lot of really interesting experiments over the course of the last 6, 8, 10 months. We have found, okay, some of the things that we did before, we need to continue doing those. That's fine. But we now have some better ideas for the future and for moving forward. So let's again take advantage of this. You as I'm assuming that you out there, many of you are either developers or entrepreneurs. Maybe some of you are kind of more focused on the business side. This is the time to take your skills, take your ideas, be bold, be aggressive, lead with those ideas, lead with those skills. The event you're attending today going to give you all kinds of really great new skills, knowledge of the latest cloud services, knowledge of development practices, lots and lots of great skills that you should be able to take. And then maybe tonight, maybe over the weekend, maybe next week, use those at your job, use them in your personal time, solve some amazing problems, bring us into the future. My talk today, as you can probably figure out, I want to inspire you to think about some of these great ideas. All right, now, I don't know if all of you are familiar with this ancient American TV show called Mission Impossible. When I was young, there was this TV show, and the main character, he would get his directives through this little tape recorder. And perhaps some of you are thinking, what is a tape recorder? Well, it's this mechanical recording device. He would get his directives from this tape recording, and the tagline of the show, it should say, "Your mission, should you choose to accept it." Then it would give him this big, interesting challenge. So your mission as developers and entrepreneurs, you now get to think some really big thoughts, dream some really big dreams. Look at the challenges that you face, your family faces, your colleagues face, your country, the world, whatever sphere you want to look within. Look at some of these things and say, based on who I am, what I know, and what I can do, how can I actually make that sphere a little bit better? How can I address these challenges? I think it's really an interesting time. We often hear about this phrase, disruptive change. It didn't mean a whole lot, I think, before 2020. We always talk about, oh, the next amazing app or the next tool or the next language or the next toolkit. That's disruptive. And we kind of as tech enthusiasts maybe got a little bit carried away with ourselves. This truly, I think, is our time to disrupt everything and to really hopefully change the world for the better as we do so. We've got a lot of amazing tools. I think we're in this really neat window of opportunity. As I was saying earlier, people are now open, they're understanding, they're saying, you know what? A lot of things I used to do are now about to change. And by and large, as I talk to people, sure, it's tough. Sure, it's really, really challenging. But people are also saying, maybe this is a really great opportunity to try something new, do some things a little bit different, be a little bit more flexible in my approach to what I like, what I do, how I go about my day. As developers, code is our tool of choice. And I think this is absolutely our time to use it to the utmost. Whenever I get something new, a piece of hardware, a piece of software, I got this cool little IoT board just a couple of days ago. Don't know if you can actually see that right there. Take something brand new and you want to explore it. Well, I think of this as really pushing all the different buttons. Pictured there is an ancient device called a teletype Model 33. I remember exploring this when I was, 12, 13 years old. I made sure I knew what every last one of those buttons and levers on the keyboard actually did so I could use that device to its full potential. These days, we've got really good documentation for lots of things. Read the manual and try everything you find in that manual. Now, one secret, let me share with you a secret. After you learn something, don't keep it yourself. Take that knowledge you've gained and figure out within whatever sphere you're comfortable, share it. Tell your your work colleagues, share it within your user group, share it at a community day event like this, record a podcast, record a video, write a blog post, write a book. So that way you're actually going to get a double value from whatever it is you do. You're going to invest that time to learn, but as you actually decide to communicate and to share it, that knowledge is actually going to become a lot more firmly embedded in your brain. It's going to be a little bit more, you're going to have a deeper understanding. You're going to think, well, I need to explain this. So I'd really just better make sure I fully understand what it actually is that I am talking about. So I always encourage people to get this double value from what they do and to actually go and explain after they've gone and done some learning. There's always room for some additional content in the world. That is absolutely 100% for sure. Okay, now here's a subject I've put a lot of thought into lately. We were all in the US. We were asked in late February, early March, we were all asked to start working from home. We actually were legitimately actually said, don't come to the office. We don't want you here in the office. For a little while, we were then told, well, we can't do things as well from home. We could make various kinds of excuses. I don't have the right connectivity. I don't have the right working space. I don't have the right technology. And we kind of made some excuses for the fact that, oh, gee, I'm working from home. That's okay. We all had to adjust. We had to adapt. We had to just kind of say, this is the best I can do. Now, as things get a little bit more settled down, the new model that I'm trying to adapt is saying, well, because of all this great tech that I have, and because I'm able to get really deeply familiar with it, I think I can do even better than before, thanks to all this tech. We often use a phrase at Amazon, we call it raising the bar. I've heard bar jokes probably about 10, maybe even 15,000 times in my career at Amazon. But raising the bar at Amazon, what we mean is you do something at a certain level, but you never get actually satisfied with the cost, the speed, the performance, whatever metrics you choose to value and to measure. And you always say, how can you raise the bar? And how can I do this? What's the next increment up to make it faster, more durable, more available? Can I make this service run 10 times faster? And can I reduce the cost by 50%? So we're always thinking at any part of our job, any part of our services, we're always thinking and using this precise phrase, raising the bar. So I would challenge you, for whatever it is that you're working on, think about this raising the bar model. As a personal example, I have become really excited by this whole idea of content creation and video streaming from home. It used to be that I would record my weekly AWS What's New videos. I would go to the AWS studio. There was a big, expensive studio. There was sound and lights and camera and a teleprompter, all this really complicated equipment. Certainly helped to make good videos by doing that. Started working from home, didn't have the ability to go to the studio, didn't have that equipment, but I really actually missed making these What's New videos. And my audience actually started to say, hey, Jeff, we sure would like to see your videos again. So I went to my video team and they said, okay, we'll set you up with some lights and some cameras, and we'll teach you how to do all these different skills involved in doing video creation and especially video streaming. What I learned, lots and lots of really interesting skills to be had here. Now, I would say that as technologists, it's wonderful that we are deeply immersed in code and in systems and in architectures and bits and bytes and networks and so forth. All well and good and all fundamental skills for what it is that we like to do. But the better that we are at summarizing, connecting, communicating what we know and the value of all those different things, the better off we're all going to be. This is actually what drove me originally to become an evangelist, loving the tech, understanding the tech, and thinking, this is so cool, this is so awesome, I need to share this with some people. So in that spirit, I'm finding that content creation and video streaming is a really rich field for us to actually go about doing this. Here's a couple screenshots of my of where I'm actually streaming from. I've got a green screen. I've got some good lights. I've actually got several different cameras. If you'd like, I can switch over here to my studio camera. So here I am in my studio cam. Being able to use all these technologies really lets you do things that were once upon a time, all of these technologies required just a huge amount of expense and complications that required multiple people to set up and to run. The hardware is not that expensive. There's free open source software that allows you to do all of this. Well worth learning as a way for you to be a better, more engaged, more capable communicator. So that's one of the things I've been focusing on learning. So let's think about reinventing. And a lot of interesting, to me, questions start to arise. We've always valued local, okay? You live somewhere within commuting distance of your office. Well, I see day by day, I see different announcements from companies that say, well, we've been doing this experiment this year, and we're now saying, well, working from home, working from anywhere suddenly is a valid option that we can offer to many of our keyboard-based tech employees. So we need to start thinking, what does local mean if we can suddenly live and work and learn from anywhere? What does it mean if you're a country or a city or a neighborhood? What's so special about your country or your city or your neighborhood? How are you going to actually make it so all of these somewhat liberated folks can now actually have a little bit more freedom? And I'm not underestimating the difficulty of travel or of uprooting and moving your family, but if things persist as they are, and we see that working from home, working in more flexible conditions continues for the next couple of years, I really think these are all going to be questions we have to ask ourselves and really start to examine a lot of things that we have simply taken for granted. What are the boundaries of living, working from anywhere? Who's going to be the beneficiaries as far as who's going to get will people start flocking to a couple of really amazing cities with the best climates and the best restaurants and the best cultural offerings? Or are they going to say, well, where are the places that might be emptied out a little bit? We really don't know. And if history is any kind of a guide, all of the predictions that we could make right now are probably not going to be all that accurate. But I think these are things that we should start thinking about as we're just thinking about what is the future of a year and 5 years and 10 and 20 years look like for us. Let me just talk and wrap up with just a couple of open challenges. Presenting's a wonderful thing, but there's another side to it that I call audiencing. So I imagine most of you are watching on your phone or your laptop, or maybe you've streaming up to your TV. You're out there in the audience. I love the fact that you are out there. I don't have any sense of who you are or that you are an actual audience. I think there's a really great challenge there, and I'll talk about that more in a bit. I think learning is going to be wholesale changed. Communication at scale, wonderful opportunities there. And then also health and well-being. So I just picked 4 just because of the limited amount of time that we have. I picked 4 different challenges and put together just a few thoughts on each one of these. I honestly and humbly really think that there are some great apps and tools and businesses and industries perhaps even to be invented within this. And if you pick up on one of these and do something awesome, go for it and let me know what you come up with. So let's talk about presentations. It used to be that the priority 1, the most desirable result, was I get an invitation from a user group like your user group, and they say, "Dear Jeff, please come to India and present." And I'm like, okay, look at my calendar and say, okay, well, it's going to take this long to travel, a little bit of time to recover from jet lag. I'm going to do a presentation. I'm probably going to get some things before and after to make it so that time spent traveling is worthwhile. And then if you said, well, I can't do it, you make a little bit of an apology and say, well, I'd love to get there, but schedules are really tight and I can't be there in person. That was the model that worked for me from 2002 at Amazon up until the beginning of this year. At the end of February, I was actually in the Nordics when word came down that I needed to get myself home as quickly as possible before entry to the US became became impossible. So old model, you'd apologize for that inability to make your personal experience. New model, I'm getting the sense that with the right tech, with the right skills, with a lot of practice, you can actually start to do a better job from home than from live. Maybe you're not jet lagged, maybe you have a little bit more control of the technology, you're running in a familiar environment, you don't have any kind of surprises when you get there that can actually affect your ability to present and to perform well. So that's going to mean maybe we can do better from home than from live, more time to create content, a little bit more control of the operating environment, and something that you learn as you become a frequent traveler. It's costly, and there's a certain amount of just personal wear and tear. It grinds on you as you travel a lot. So I'm thinking that the whole world of online presentations is going to really take off. The number of my colleagues I see that are doing streams like this, they're doing video streams on YouTube and on Twitch and other locations. We're all learning as we go here, and I think we're all learning that there's some new models to do this. Not saying it's perfect, not saying I'll never travel again, but I think there's some great opportunities to make this even better. All right, this one, I honestly think there's some amazing things to be built here. As a presenter, I'm just sitting here, as you saw. I'm sitting here in my office. I'm speaking out into the vacuum. I can imagine you are there. I'm hoping you find what I'm saying interesting, and I'm hoping that you're actually listening. I don't know if you're there. I don't know that you're paying attention. I don't really know how many of you are software developers and how many of you are students and how many of you are entrepreneurs. I don't know any of your demographics. I just don't have a good sense of who the audience is. I certainly can't directly see if I can't make eye contact with you. I can't get any reactions. I can't get feedback. All of this I can imagine, but I also can think there's got to be some really interesting technology that might actually help us to, if I'm sitting here and there are 5, 10, 20, 25,000 of you out there, what kind of tools could you give me that would give me a sense of what the audience is? What's happening there? Are you liking what I have to say? Are you following along? Are you excited? Are you on the edge of your seat? Are you kind of bored and thinking you've heard this before? I would like to be able to know that in real time as I present. It's some kind of aggregated way with some metrics or icons at scale, so I could actually do a better job as a presenter. So this is a brand new word. As far as I know, I invented the word audiencing. I haven't bothered to search it, but I'm pretty sure that as an audience, there's great things you can think of to address some of these challenges. All right, so let's talk about learning. Don't know exactly how the situation is for you and for those of you who are parents and you've got children still in school. Around here, parents have been forced to, in addition to their regular job, they've been forced to become educators. They've had to set up effectively classrooms within their house. We've got children trying to do online learning. It sounds like this wonderful, magical, awesome thing. What we're hearing back from the teachers is the students are actually not finding it all that compelling. The teachers are really struggling to keep the students engaged. So we might have to think, well, these teachers are effectively competing with all the other more flashy, more dynamic, more professionally polished content they could find online. To be a really good teacher, do you need to become some kind of a performer or entertainer in addition to an educator? Is there a scale-up model? What might be the scale-up model? One really interesting thing that I found is there's this course taught at Harvard University in Boston called CS50. This is a legendary course, apparently. I haven't had an opportunity to watch any of the videos or look at the content, but the introductory video has been viewed 700,000 times. And on edX, the edX site, there's been 2.4 million students have registered for this course. Not all of them have actually taken it seriously and actually gone through all the lessons and done all of the work, but this might be an interesting scale-up model for various kinds of education. Do we have fewer teachers that are scaling up to multiple thousands of students, and they have the talent and the equipment and the audience to do something on the scale of CS50? I don't know, but something certainly worth thinking about. All right, another interesting thing that comes about, and we've got to talk about this idea of communicating at scale. So once you do something well and you become even a little bit well-known, and if you've been doing it for a while, this challenge comes up that I call personal scalability. And I think there's some great ideas that people need to come up with to solve these kinds of challenges. The challenge that I face all the time, there's one of me, there's many of you. I'd love it if everyone were to send me DMs and send me emails. It would be so awesome to read and understand and appreciate and reply to every one of those. Unfortunately, they're, again, just one of me, and I would never ask anyone else to pretend to be me. So how do I deal with this personal scalability? It's a really just interesting challenge that you find as you become even the least bit well-known. So many interesting ideas, suggestions, requests, comments. I love them all. Sure wish there was enough of my bandwidth to address them. So are there some great tools that could actually let me do that at scale? I don't know. I'd love for one of you to invent one. I do see that it's really interesting how I think as now that we are working online so much, I think we're learning to be better communicators. As working with my own colleagues, I'm seeing we're more direct, we're more honest. Because we're at home, we don't get to kind of get that subtle sense of body language and read people's body language so well. So there's less ambiguity. I think we're getting even better at being sensitive to the fact that people are different all around the world, have some level of sensitivity and awareness of that for sure. So again, open challenge for communicating at scale. Last challenge I'll leave you with, health and well-being. I've got several friends in the medical field. I've got friends who are health educators. I've got several friends who are doctors of various sorts. Very, very difficult and very challenging from them. Teaching, training, seeing patients, very, very different than what's happened before. But we're seeing things that you might have once thought, well, you need to be there, you need to be in person. We've got this whole cool thing called telehealth. That little cartoon in the bottom left is kind of a humorous example from 1954 about this whole idea of telehealth. Literally a doctor inside of a TV set. Well, that's somehow 70 years, almost 70 years later, we effectively have that. I've got friends who now practice telehealth medicine. We've got companies running on AWS like Peloton. A friend of mine has a company called Moxie where they use Amazon Chime to create online studios for exercise and for yoga classes and so forth. So lots of interesting opportunities within the health and well-being space. Okay, so where are we? I think we've been through a whole lot as individuals, as societies, as the world. Certainly it's been tough. It's been traumatic. It's been really hard for a lot of us. But I do think we're going to actually get to the point where we say, okay, the future is actually looking kind of bright, and there's going to be some opportunities that come from this. So you're going to learn a whole lot today. You're going to get some new technology, some new skills, hopefully get some new ideas. My challenge to you, take what you learn, do something awesome, and take that and share it. All right, from here, I know we wanted to go and do some Q&A, and so let's switch over into our Q&A mode, if we could.
Hello, Jeff. Thank you so much for doing the keynote. That was really exciting and insightful keynote, I must say. And raising the bar not only applies for AWS and Amazon as an organization, as a user group, and also AWS community. We are also raising the bar year on year, month on month, and week on week, adding more content, more members to the community. So I have two questions for you today. The first question is little personal from my side. Back in 2004, when you started writing AWS blog, I'm sure around early November or late October-ish, what were your initial thoughts? What exactly were the trail of ideas that ran through your mind? Did you ever anticipate it would scale it to the level it is now? I mean, If I'm not wrong, I think you wrote the first blog when you were traveling from Seoul to Seattle. I have heard stories there. Correct me if I'm wrong, but what was your thought process as such?
Well, I absolutely for sure never thought it would grow to the point where it is the thing that at whatever point that I decided I'm no longer relevant and I retire to the beach or the mountains or wherever. I really think that the AWS News blog is going to be what people remember me for, which is really, really awesome. And I didn't set out to do something that was this impactful. To me, what I've always learned, I've always loved to learn something and then to explain it. And the blog was simply my way to do it. I was lucky enough in the early days of AWS, I got to work directly with Andy Jassy, and I was reading all of Andy's documents he was writing as he was putting all the plans together for storage and compute and network and database. And I'm seeing all these different plans, and I'm just thinking, well, how can I effectively communicate all this to a large scale audience? And I said, well, let me create a blog and see if we can use that as our communication tool. Never would I have dreamed that 3,000 plus posts later that I'm still doing it, and that but it's still fun. It's still really, really, really fun. I actually spent most of today reading a big stack of documents we call PR FAQs, press release plus frequently asked questions. I read a big stack of those documents in preparation for my blogging I'm going to start working on for reInvent.
Awesome. Thanks for answering that, Jeff. So I have second question, which is coming from one of our community leader from Pune called Anurag. The question is, your product teams are autonomous. How does AWS make sure the product deliverables align with their higher goals of AWS service delivery? I assume AWS follows something called two-pizza team. So how does that align with the delivery of products with higher goals?
Sure, that's a wonderful question. So what each team does is we have a methodology that we call start with the customer and work backward. So each of these two pizza teams is organized so that there's a business leader, and the business leader is effectively the owner of whatever service is about to be built. So this business leader is responsible for knowing who the customers are, and really before anything is built, they are going to sit down with customers. They're going to understand what is the challenge that these customers face. We then, now depending on what we're doing, if we're launching a brand new business, we write a document called a narrative where we have a space of 6 pages to actually outline the entirety of the new business we're going to build. If we're launching a new service, we actually only allow ourselves 1.5 pages to write the press release. And the interesting and amazing thing is it's very hard to write that first press release, because when you really come down to it, there's not a whole lot of words in that 1.5 pages, and you have to then subtract out all the kind of the standard words, the boilerplate, if you will. So the press release forces us to make sure that we fully understand what we want to build, and that we can describe it exactly and precisely, what it is, what it does, what customer challenges it solves. And we write that document. We make sure that we're very happy with it before we fully hire the team, before we decide on architectures, before we write any code. Getting that definition first is absolutely crucial, and that's one of the first steps.
Yep. Thank you so much, Jeff, for answering that question. A pleasure to have you today, and thank you so much once again for doing the keynote, and hope to see you soon in India.
I would love to get there sometime.
With an offline event. Thank you so much, Jeff, for being here. Thank you. Have a great day and stay safe.
My pleasure.
Take care.
Have a great conference.
Yeah, thank you. Thank you. Yeah,
right.
Thank you. Thank you so much. Yeah, bye-bye. So over to Vaishnavi Singh, who will take us to the track 1 details. Over to you, Vaishnavi. Thank you so much.
Hi, Jeevan. Thank you so much. So good morning, ladies and gentlemen. I hope everyone is safe and doing good. My name is Vaishnavi Singh, and I'm a final year BTech student who's pursuing information technology. This is track 1, and I am going to be your host for this track. We have one more technical track that's happening in parallel. The link to track 2 is given below in the description. Once again, thank you so much, and I'm really honored and excited to be your host today for track 1. And I know you're excited about the event too, because your presence here shows us how much you care to learn from AWS experts. Without further delay, let me just walk you through the agenda for today's program in track 1. We have 6 technical sessions by the industry leaders. We also have a few exciting games and quiz competitions. At the end of each session, we request you to send us feedback. Please use our Lanyard app for rating the speakers and for providing feedback. The link again is given below in the descriptions. You can also post your doubts and your questions in the YouTube comment box. Our team is on standby to answer them. And do not forget to share on social media. Use hashtag ACT India and hashtag AWS India hashtags. We have gifts for the best tweets and for the best shares. So without any further delay, let's just dive into the sessions that have been tracked up for track 1. Great. So let me invite our first speaker for today's technical session. Swaroop Hegde is the co-founder of BlockVigil and currently its CEO. He is a nomadic serial entrepreneur who is passionate about building products and hacking on new technology. In the past, he has worked and built technology products like Dota Pro Hub, Atticus, Planga, and Filter. Please join me in welcoming Swaroop to talk on using Aurora Global Databases for 10x faster API. Welcome, Swaroop, to the AWS Community Day. Over to you.
Thank you. It's good to be here. Good morning, everyone.
Yeah, you're right.
Yeah, I hope you're able to hear me right. Yeah, good morning, everyone. And it's quite an honor to actually follow after Jeff, having seen AWS's early journey. Yeah, so today's agenda is using Aurora Global Databases for 10x faster API. So before I sort of get into it, maybe a bit about myself. I'm Swaroop. I'm one of the co-founders of BlockVigil, and actually, as of this week, another company called Parloop. I've been building technology companies for about 15 years. I don't know how many on today's audience know this term called a hosting company, because AWS has made it redundant. I actually used to run one of those like about 15 years ago. And of course, these days, it's so easy to do that through AWS. I actually do a lot of different things at BlockVigil, apart from being a CEO. I still like to code. And more importantly, I enjoy doing DevOps the most. And maybe a little bit about what BlockVigil is. So we are an API gateway for blockchain. So our mission is to make blockchain development really, really easy. So what we do is we abstract all of the intricacies of blockchain into an easy to use API. So you just get as a developer, you get a REST API, you can interact with it without having to worry about how crypto and gas and all these things work. We're an early stage company. We've been around for a little under 3 years. We're actually only just 2 full-time engineers, and that actually includes me. We currently process about 10 million API calls a day, and most of the growth has come in the last 3 to 6 months. And I believe we're growing at a pretty fast rate. And I think it's very surprising to a lot of people, but we do not have a dedicated DevOps person, especially for an infrastructure company. I think half of the reason is also why we call ourselves Swiggy profitable. To the people outside India who are listening to this, it's equivalent of something what we call as ramen profitable. And part of it also goes to AWS and other services that are out there that make our life so easy that we sort of outsource all of that to these managed services. I also wanted to give a little bit of shout out to AWS Activate program that actually helps startups like us to sort of not only get credits, but a lot of resources, which makes us to focus on our business, right? Now, let me talk a little bit about the problems that we were facing, right? So some of you who've probably gone through my talk brief or the video, I talk about how much of the infrastructure for early stage companies, you're sort of around a particular region, right? In our case, we were mostly around US East 1, because all of my companies are US based, and I think I personally was a very early user of AWS, so I always default to that region. And as we sort of started to grow, and we actually saw that pretty early on, that we have developers from all over the world. And let's say if, like right now, I'm not in San Francisco, even if my background says so, I'm actually back here in Bangalore. And if I try to connect to our infrastructure, we are looking at a latency of around 8 to 10x, right, depending on the ISP and so many other reasons. So, and although people like to take a jab at blockchain, saying it's a slow thing, we unfortunately cannot say that, right? We are a company that is trying to make that easy and faster. And so we were trying to figure out how do we sort of solve this problem. And so for today's topic, I'm just going to stick to the database aspect of it. So we do a lot of different things. Obviously, we have Elasticache and many other services that we use, which also is something we scaled. But you know, from a perspective of database, if you had to sort of do this, you would have to have a multi-master setup, you know, replicas all over the world, maintaining all of that, right? So what we ended up doing was not only did we use read replicas in different regions, but I believe this was somewhere around June that the Aurora's global write as well, that sort of went GA, right? So I'm not sure of the exact date, but it was somewhere around June of this year. So that allows you to actually write from a regional instance as well, without having to maintain another master over there, right? Or a writer is what AWS likes to call it. And we were able to bring down the latency from, so we would have around 400 to around a little under 600 millisecond, depending on our expensive write transaction. That is something that we have with blockchain because we have so many other elements to it. And more importantly, we were able to do this without involving any external help, right? All of this was just done by me over a matter of a few days. The only, I would say the downside was the infrastructure sort of costs went up because now you have to have this expensive sort of setup with different servers all over. But you know, if you want to scale, that sort of comes with it. I will go into the cost aspect of it a little later on as well. So one plan that I do have is I actually find talks quite boring if it's like a bunch of slides. So I decided I'm going to do as much of a live demo. Obviously, I can't do the entire provisioning in less than 40 minutes because it takes a while to sort of provision all these servers. So I'm going to walk you through that, right? Okay. All right. So I'm going to show that disclaimer a little later. All right. So what I have here is the entire setup already ready to go. So we're going to come back to the screen, but just to give you an idea of how a global RDS server setup looks like, right? So let's try to go to an AWS console. You don't have to do anything special. That's what I wanted to sort of show you, that anyone with like basic AWS skills can sort of do it as well. So go through the standard create mode, choose the Amazon Aurora option. And for our purposes, I'm just using MySQL, and you know, you're free to choose whichever one you want. Preferably go for provisioned because I think serverless has a different sort of a role. So I'm going to stick with, I know a lot of serverless talks are there today, so I'm going to go with the more old school way of doing things, right? Okay, now here's where it's actually very crucial, right? So you have to choose a version that is compatible with the global database feature, right? So if you don't do that, then it becomes really difficult for you to, let me show you the versions around here. Okay, there you go. I was just waiting for this site to show up. So UI is a little clunky as always, but I think it's improved a lot over the years. So don't worry about it. Okay, so if I don't choose the global database feature, you know, you have all these versions, but if you choose the wrong one, you will not be able to sort of do that. So without having to like do a lot of modifications, right? So if you're setting it up from scratch, I would highly recommend that you choose this. And then for your reference, AWS does show it here as well without having to go through the documentation, all the versions that are supported. So I actually went with the most latest one because I didn't have anything to lose. And honestly, I wanted some of the features of 5.7 without having to worry about additional maintenance, right? So go ahead, everything else is pretty much standard, set up of credentials, password. Now, this is another crucial part, right? So, which is why I said I want to talk about the cost aspect of it as well. So you have memory optimized instances, and I believe Jeff's post just a few hours ago talked about the new Graviton 2 instances, which is amazing. I don't know if my demo actually accounted for that because I just set it up last night, but they're much more powerful. But ideally, if you don't have a lot of workload, like something we also do is we try to go with burstable instances. That will not work for global databases, right? So that is the big caveat here. But honestly, if you're at that scale, you'll probably not be sort of having these instances to begin with, right? So just keep that in mind. Just go with the R5 large to begin with. You're welcome to sort of try different versions depending on your workload. I'm going to go with the multi-AZ deployment because when we are looking at scale, you might at least have the multi-AZ in your primary region, right? So, and then the global ones actually have something very smarter. We'll sort of go over it later if there's enough time. In terms of VPC setup, I'm going with the defaults here, just to show you how easy it is. You're completely welcome to have your custom setup for maybe different accounts, VPC peering, whatever you have set up. Let me see, what else did we have to choose? So usually I don't go for public access. I don't recommend people to go for that. Just set up a security group, right? So in my case, I think I had a couple of groups that I set up. Maybe I'm on a different region right now. And that's how I sort of talked them through the instances. I'm going to show you that as well. Okay, additional configuration. This is you're welcome to sort of set up encryption. I like to keep performance insights just to see how much of the load is actually coming through different, I have customers who do different things in different parts of the world. So it's kind of very interesting to sort of see that. And yeah, so once you're done, just create the database. So since this takes a bit of time, I've already sort of set it up for us here. So let me first start maybe with just the primary here. Okay. So this is all I had set up in the main region. As you can see here, this is the US East one. And I will be showing you the demo through the EC2 instances as well. So I've got a writer and a reader, straightforward, right? Anyone who's used RDS already is aware of how to set it up. Now, here's the interesting part, right? So the first time, it actually will not have this sort of a global identifier because it's like any other setup, right? You just set up a cluster. The action actually happens is when you do the first region, right? So I believe in this case, yeah, there you go. So you're going to get this option the very first time. You're not going to see it right now. It's showing it differently, but the first time you do it, you're going to see that option to add a region. All right. So when you try to add that region is where things are more crucial, right? So choose something that's best for your customer base. In our case, we actually went for Singapore instead of India, even though we have more customers from India than rest of Southeast Asia. And of course, majority of our customers are in US and Europe. So Singapore sort of became a good sort of middle ground for most of Asia, right? So it's got good connectivity, and I'll show you later in the demo on how the latency from India is not that bad, right? Unless you're on a bad ISP, I guess. And similarly here, you have to set up instances. I believe you can give it a better instance for sure, but you'll see there's no option to go for the burstable instances, right? So choose your region wherever you're doing. There's probably no need for an AZ here, but if you do have a lot of traffic, then I think it's just better to have that because then it can act as a good failover, right? But I don't want to go into the failover aspect of it for today's talk, but you're welcome to sort of do that. Similar VPC, all of these setup. Now, this is the most crucial part of it, right? If you don't do that, and I'll show you what happens when you don't have this enabled. Now, this is, I would say, AWS's sort of secret sauce or the magic that allows you to sort of write from any region over through like a read replica, right? So this is something it's a little hard to wrap your head around if you're doing it for the first time. And I myself was quite confused, and I'll sort of show you how in the console and within the code as well, how it works. So make sure you choose this. Even if you don't, it's okay. There is an API which you can call. So let me just quickly show you the documentation. You're welcome to sort of see this later on. I don't want to go over it each and every version here, but you can sort of set it up in using the API later on as well. But when you know that you're going to set it up, just make sure go ahead at that region. Okay. All right. So I think we are all set here. So let me just bring up something. Yeah. So this is the part. The reason I had this was, now if you're a smaller company, you might be on one of these burstable instances, because if your budget's under, like, you're spending less than $1,000 a month, you're probably not on R5, right? So because R5 is approximately, let's say, I would say about $200 a month, right? Depending on the different region, I guess Mumbai is a little higher. It's around 245, and this is for every instance, right? So you're going to multiply that by every instance that you have. So it doesn't matter which region you're using.
Hey, I'm so sorry to disturb you. Could you just do the screen for full screen? Like, there's a few problems, like people can't see the screen properly.
Sure.
Could you just zoom in, like make it full screen or something?
Yep. Is it
Yes,
better?
thank you so much.
Okay,
Yes,
cool.
I think it's better. Great. Thanks a lot.
The
Sorry.
problem is I can't switch tabs that easily without knowing. That's the issue. Okay, I'll let me do one thing so that I don't waste more time on it. I'll just zoom in the text so that it's a little easier to read. Sorry about that, guys. Okay. All right. So I was talking about the costs, right? So keep that in mind. Now, what I've done is I have set up 2 regions, right? So we're going to see something before we sort of start interacting with them. Let me zoom this in as well. You can see here US East 1 setup, and here is our AP Southeast 1C. I believe this is Singapore, and South 1 is Mumbai, right? So even I have a hard time remembering all these ones. Okay, so let's open this one, and let's open this one. Right, so you'll see the endpoints, which is something that you'd only see like a reader endpoint, right? Because we only created a read replica here. And here we go. Okay, cool. Looks like the Zoom is not persisting for some reason. Okay, I think that's what's happening. Okay, so as you can see here, there's only a reader instance, right? Because this is a cross-region replica that we have created, so there is no master or writer. But I did talk something about write forwarding, right? So that'll probably confuse you. Don't try to use this endpoint. I don't even know if it will actually work. So just go with this and I'll show you how that magic works, right? So this is for this is the Mumbai region. And this is for, sorry, that was for the Singapore region and this for the Mumbai region, right? So different clusters that we have. Okay, so what I've done is I've written some bit of very simple Node.js code to sort of talk to all of these. And I built a very simple API, right? So I couldn't share the entire API that we have. There's so many moving parts. So I've made a getter and I made a setter, right? So this way we can sort of test everything out in different regions. Okay. All right. So I'm going to share, so the link to this repository is there at the end of my slide. So I'll share that link again. So you guys can, feel free to try it out. I just made the repository public as well. So here's that little bit of code. As you can see here, I create a connection pool. What I do is that if I do need to enable write forwarding, there's one extra step that I need to do, right? So this is something that you may not have been doing in your regular SQL queries, right? So if you see here, this is what generally a SQL query looks like, right? So I'm just going to be setting a session variable, right? So that's in the documentation of the write forwarding page as well, so you can go through it. And all I'm doing is I'm setting this variable in the session. So that's ensuring that each time I get a new pool, or if my pool gets reused or any of those things, I'm constantly setting that, right? So if I need to enable write forwarding, and I will show you what happens when you don't have write forwarding as well. Okay, and yeah, here we go. There's a reader. All it does is it reads from a simple table that I've created, and the writer just inserts into that table, right? So as simple as that. We're not going to worry too much about code. My goal is to show you what is the performance improvement, right, when you have something like this. Okay. So let's open up the console, and before that, let me show you the instances that I created. So I have US East 1 instance here, and I have a Mumbai instance, and I have a Singapore instance. Right? So I've just set it up for this purpose, so we can actually do it live. Please don't try to query these IPs right now. I need to make sure this demo works out well. All right. So we have the UC East one here. Let's actually go through the configuration. Don't worry about the credentials. It's meant to be temporary for this demo. So as you can see here, different endpoint here, right? So there's that US East one that will give you a clue that this is the US East one server. Similarly here, Southeast one, this is the Singapore server. Notice here, I've set write forwarding to false. This is intentional, right? So I'm going to go over it why I've done that. And this is the instance in Mumbai, which is talking to the Mumbai RDS, right? So the best part is now I'm not doing some sort of a crazy routing from the Mumbai instance to all the way to the master or the replica in some other place, right? So all of that is just gone away. They're just talking to their local, via their local VPCs to their local RDSs, and everything is handled magically, right? So we're going to see that. So, okay, all of this is done. Let's make sure my servers are running. Okay, there we go. I got a new MySQL pool writer in this instance. This is what I was actually just testing before that. We're going to see this error, what it does. So same here. Again, I've gotten a new MySQL pool writer. And in the Mumbai one, I hope you guys are able to see my screen now. If it's not, please do let me know in chat. Let me see if I can see the chats here. I think there was somebody said the voice is low. Can you put the microphone closer? I have it as close as possible, I believe. Okay. Let me make sure. Can you please zoom in on the screen again further? Okay. All right. So I've zoomed in as much. If I go beyond that, I think it'll be a little hard to read. So, all right, I'll try my best here. Okay, so we have, this is the Mumbai instance. And you see here, I've actually write enabled, write forwarding has been enabled here, which is why there's a different console message here, right? Okay, so now we're going to talk to these instances and see what really happens. Okay, so I hope many of you used a tool like Postman. Okay, I just see voice is breaking at times. Okay, I just hope, let me just turn this camera temporarily off if that's what's causing this. Let's just do it for the sake of it. I hope you can hear me fine, right? Okay. There's a question here. Can you ask how did he get connected to the Ubuntu VM instances? Okay, through a local terminal. Well, okay, let me actually show that what I did. So all I did is I just did an SSH into the servers. I have my public-private key set up on these servers, so I didn't want to go into all of that, right? So those are the IPs that I'm connected to, right? So similarly here, the US East 1, Singapore, and Mumbai. 3 terminals open. And now, okay, looks like my voice is better. I think it's my camera that's what was causing the issue. Okay. All right, so let me see if I can zoom in here as well. Okay, the zoom kind of works. It's a little funky, but we'll stick with it. Okay, so what I've done is I've just made these 6 endpoints, and we're going to benchmark this as well, just for the sake of it, because it's fun. But for now, I'm just going to show you what happens on each of these calls. I'm making the first call to the US East one. You can see there's a bit of a delay here. Obviously, I think it's because of my first call. Let me do another call. It should be a little better. So there we go, 564 MS, right? So this is what I was telling you, that this is the delay that you would preferably have to a US server, right? So you can probably speed it up if I had like more caching in front of it, like maybe using Cloudflare or some other service. And let's try to make it right as well. Now this write should be very straightforward because I am talking to the main master, the writer, right? So similar here, it just comes in and I get an ID 14. We can do the call again and you can see the data is here, right? Okay, all right. Now I'm going to make the same call to the Singapore server, right? And if I do that, I already see a huge performance improvement. Because why? Because Singapore is very close by. We have very good, how do I say, internet pipes to the Singapore location, right? And AWS ensures that we have better connectivity here as well. So immediately we see an improvement, right? So, but there's a reason why I've done 2 different regions just to show you. Now here's where I'm going to have a problem, because what would happen, okay, there we go. The error is right here. And just to maybe, let's open the terminal up. There we go. Okay, so we had the previous terminal open as well here. No errors here. And we have a huge error here, right? So the reason for this is because you can pretty much read it here. MySQL server is running with read-only options, so it cannot execute this statement. This is something you deal with even if you were just talking to any read replica, right? Regardless of which region you're in. So that's something you cannot solve. You have to talk to a writer instance, right? But remember that initial feature that I told you about write forwarding and ensuring that you have that checkbox enabled. Now this is where it's going to come in handy. So here's that bit of code that I'm setting on the Indian instance, not on the Singapore one, just for the sake of consistency here, just to show you the difference. So I'm setting that in, right? So this is what is enabling that. So that is just a simple configuration that I'm doing over here. And you can go through my repository. I'm just setting up in a config file. Let me actually just show that just for the sake of it. So I have a default configuration, and then I have a environment-based sort of a production configuration, right? So let's maybe open that up here and show you again, sorry. Okay, there we go. So here, the difference is that I have set it as enabled, and which is why I actually was able to connect the console. I have a different response here, right? Okay, now if we try to write through Bombay, which is also, let's actually do a read first and see if our response times are better. We got 120 ms. What's happening with Mumbai? Okay, that's surprising. I just hope, oh, looks like the IPs got overwritten. Let's fix that. Mumbai. Of course, a live demo can never be smooth, but that's the whole point of it, that this is live. All right, so the tool I'm using is Postman. It's actually a Bangalore-based company, very widely used by all over the world. You can use anything you want. I could have shown it in curl. It's just a little easier here. Okay, so 110 ms, 75 ms. So it sort of varies a bit depending on your ISP. There we go. That's what I was waiting for, 30 ms, right? So that's the speed that you will actually get to a Mumbai thing compared to 450 or 500 in the US, right? So this is the big difference. Now, all of this only makes sense if you're able to write to your API as well, right? So whether it's an API or whether it's just a simple backend, you need to be able to write. So that's super important here. And that is what I should be able to do. And again, I was connected to the copy paste was here. There we go. So I'm able to write. It's a little higher for writes because you still have to sort of write to a database. So there is an extra latency around that. But you're not going to get the same latency as writing to, let's say, having a different sort of an endpoint talking to maybe the US East writer, right? So that would still be on like 450, which I showed you, right? Or maybe even more than that. And now this is where that magic is happening, right? So through the replica, AWS is ensuring, so we can verify that it was written. Let's actually make a read call. You can see here, the ID 17 is right here. This is what it's ensuring, that it goes through their infrastructure and it's written to that master, right? So that's what makes it super, super easy, okay? Now I'm gonna just show you, for the sake of the demo, I'm gonna make sure that I can actually show that I can disable this, and the Mumbai one will also stop working if I don't set that session variable. So the 2 things are important. You need to make sure your replica is set up to handle that. Let's go back to a write. And this time we are going to give it a success false, right? Because that was not able to execute it. All right. Okay. So now let's actually just do a quick little benchmark here. And we do it somewhere. We do it here. Yeah, let's do it this one. So this is in Postman, you can do like a collection runner, right? Could you also show, Rashmi is asking, could you also show us the headers that you're using? I don't believe I'm using anything special. All of this is actually added by Postman, where they're, like if you see there's calculation of requests, they're adding a user agent, accept everything, gzipping. These are like standard stuff. Even your browser would sort of do that, right? So I'm not actually doing anything extra. This could be run in curl as well. I was actually going to show in the browser. It's a little harder to see. So let's go back to the collection runner. And I'm going to just make these, maybe these write calls. And I'm going to make 5 of these just to benchmark it, right? Because you saw how random it was. So I'm going to run this. So what it does is every API, it tries to automate. I mean, it's all happening on your system, but it's making calls to them so that you can get a bit of a consistent response, and you can see what is the, you can calculate as an DevOps or an engineer, what is the mean response time for different regions, right? So you can see the difference here, right? India will always be better. This is generally what you will see. Okay, and on the highest side, this is the difference, right? So it's just about 10x. I actually took that as was not intended towards the 10x engineer joke, but we did actually manage to reduce to 10x. So we have slightly higher API response time because we have so many other things involved. Okay, I think there was a lot of the demo. I just wanted to go back to the slides for a bit and then open up for Q&A. So let's actually quit all of this. Let's go back to our slides. There we are. Okay. Now, I wanted to put a disclaimer here because I told you about the costs, and I think I've mentioned it enough times, right? So if you're a small company that cannot afford a huge budget or does not have a lot of AWS credits, please don't do this, right? So, and that also goes for point number 2. If you don't have customers outside a certain region, this is just an overkill, right? We ourselves have still been only recently experimenting with it. And precisely why I've actually written something about, has this been battle tested? Because even I don't know, right? So we've just been starting to use this. And I thought this was a perfect time when the call for speakers was open. And I actually decided to sort of put this, and one of my friends, Satya, I think, who is a community hero, he had tweeted about it, and I think I submitted at the last minute because I was like, this is something really cool I was able to do without much expertise, and I think it'd be useful to all of you. I don't know how much it will be, but I hope you guys got a good idea through the demo. And yeah, I wanted to give a big shout out to the entire AWS Community Day India team for organizing this, being very patient with me because I have very erratic sleep cycles. Like I've been actually working all night today on some other AWS stuff, and I've not been as responsive, but I wanted to make sure that it's done. They've been very helpful about getting that right on. So this is the repository where you can check out the slides. So there's a bit.ly link, there's a QR code. I'm going to drop the link in chat. I don't know if somebody else can. I'm going to drop the link in chat in a bit. And you can try this out with your AWS account. If you even have like $100 credit or something, you should be able to try it out and quickly shut it down, right? That's precisely what I'm going to do after today because it's costing me a lot right now even to run this demo. Okay. And yeah, so follow me on Twitter. I'm Swaroop H. And please share the feedback, join the AWS user groups, and I believe I am open to Q&A. Let me drop this link.
Thank you, Swaroop. That was an amazing session. Thank you for sharing your reflective knowledge with us. So we have a few questions lined up for you. So our first question is that what percentage of costs spiked up from one of our attendees? What percentage of costs spiked up?
The major cost difference was just having extra instances here, right? So I'm going to just turn my camera back on.
Yes, that'd be great.
Yeah, because I think the screen's shared. Yeah, there we go. So the major difference, like I did the math, right? So the Arfa instance itself costs about $250, $250. And the more regions that you're adding, you're multiplying that by as many X, right? So if you were not using R5, then you're looking at an exponential increase because suddenly you're going from like T3 or something to like we ourselves were, I believe we were not using R5, but then we figured out a way to merge all of our things to justify this extra cost. But if you think about man hours, right? So that's how I like to look at cost, right? So if I had to put an engineer to have this set up, it would cost me tens and thousands of dollars and ensuring maintenance overall. And I think that's, you're probably saving costs if you have the justification for it.
Right. All right. Thank you for answering that question. We have one more question for you. So, how much latency can we expect if we want to replicate the Bombay instance data to the US database instance? If we want to keep the same set of data in all locations?
You can monitor that through the AWS console, but I don't think there's high replication lag because this is all happening through AWS's infrastructure, right? So they're experts at it. They've been doing it for a long time,
Sure.
so they know how to do this. And we actually did not notice any replica lag. If you noticed, I showed the demo, right? The write that I did is not happening on Mumbai, and it's probably happening on the main US database, and then it has to come back there. So it was pretty quick. And unless you have a very, very crucial app, then of course you'll be having a caching layer, which is what we have as well. But I think as a demo, you'll not see any major lag as such.
Okay, okay. That's a great answer. I mean, as much as I could take from it. So there's just one more question for you. What is the advantage of using Aurora over MySQL? Because I think we don't have the red replica, right, forwarding feature in MySQL. So is that the main reason?
So Aurora is, so to set it clearly, it's the managed MySQL and PostgreSQL now that they support that as well. I was actually doing that overnight, setting that my very first Postgre instance. The idea is that they are two different things, right? So one is it's MySQL compatible versus MySQL, right? So that's the main kind of thing. So if you're using Aurora, of course you can't. It's not the same as MySQL, but I've never run into anything has something different, right? So, and I think that's the difference. So if you're willing to port your data, it should not be any difference to you, right? So, and I believe AWS offers ways to quickly import that into AWS.
Yeah. All right. All right. So that's been an
Just to
awesome
answer the
session.
weird question about background flicking, because I'm actually using experimental software. That's why the microphone
The
keeps
black.
going in the middle.
Yes,
Just
because
to,
of black.
it's annoying some people. I've been
No, but
beta
then
testing
although
someone
your
else's.
background's really cool though, it's really nice
Yeah,
to
I'm
look at.
missing San Francisco. It's been 8 months, but I'm
Better
also
than
happy to be in
mine.
Bangalore. I'm
Also
also
in
happy to be in
Bangalore.
Bangalore. Yeah.
Right.
Awesome.
Great. So that was an amazing session. Just to let you know again, thank you so much for joining us today. And I hope all of the attendees enjoyed the session as well. Swaroop, we'll let you know if there are any additional questions from the attendees. Please join in, log into YouTube. You can directly comment there as well. Thank you so much once again.
And thank you guys as well. And thanks everyone for listening. Bye-bye.
Yeah. Bye. So everyone, please stay tuned for the next session coming right up. Yes. All right. Welcome back, everyone, to track 1. All right, so before we move on, do not forget to share your feedbacks via Lanya, that's our app. Without wasting any further time, let's dive into our second technical session for today. Our next speaker is Kapil Gambhir. He is Enterprise Solution Architect who's currently working with Amazon India Private Limited, having more than 2 decades of IT experience. He has a special interest in serverless and personally believes that it's the closest paradigm to what cloud has always stood for. His passion for technology keeps him motivated and he likes to tinker with things and breaks them sometimes. So let's gear up to hear from Kapil on what he has to say, finding the right needle in the haystack, mastering desired observability for serverless applications. Welcome, Kapil, to the Amazon Web Services Community Day. Over to you. Sir, your mic is muted. Could you just unmute yourself, please?
Sure.
Yes,
Hopefully
we
now
can hear
you
you.
can hear me. Yeah.
Yes, we can. We
So
can. Great.
thank you so
Great.
much for that introduction. I'm humbled. And yeah, thank you so much for being a part of this dynamic user group. It's always a pleasure to be part of the community, which is so vibrant and really doing great stuff. Yeah, as Vaishnavi said, I've been with Amazon for almost 2 years plus, and today I'm going to talk about one of the topics which is really close to my heart. So today, what I'm going to talk about is mastering a key operational dimension of applications, which we call it as observability, with a focus on serverless application at AWS. With microservices becoming prevalent, the granularity of each service is further reduced, right? So, which is they're operating independently and they're usually deployed in a distributed manner. This distributed nature requires a very different approach towards the overall health of the system. Getting to know whether things are fine, whether it's the performance, whether it's the availability, whether it's the overall health. It needs a very different approach because you have these small services deployed across everywhere and you need to be in control of the bigger picture, right? It's critical to really care about the health of each component, every event that's happening inside your system, whether it's coming from the user, whether it's an event which is a change of state inside your application itself. You need to be in total control, right? It's just no more anymore about really just the high level incident management or outages, but also to have a visibility at all levels and being able to really zoom in and zoom out. So being able to really go at the highest level, have the bird's eye view, find an issue if there is any, and then be able to zoom in back to have the overall control in the system. Basically, being armed with the correct data points is hypercritical now, and it should help you carefully filter the noise and focus on the signal. So back again, I am Kapil Gambhir, an enterprise solution architect. In this session, we will discuss AWS native solutions, providing capabilities that enable you to identify bottlenecks, issues, defects proactively, right? Without you having to manually sift through so much of data which otherwise gets produced in logs, metrics, and traces that you might be having. This whole process is quite analogous to the expression finding the right needle in haystack. That's where the topic really came from, which is about the continuously generated logs and the operational data, the huge volume that's getting generated by the system today. So once again, thank you for joining the session. I believe all the slides would be available post the session, and the recording also will be available later. So let's get into it right away. So what's on agenda today? Let's quickly cover the agenda. First, we'll define on what observability is, why it's important, and how it has evolved from the traditional monitoring. Is it really the old wine in the new bottle, or is there something, a value proposition that we see in the observability? We then go through how to actually create, view, query logs, look at the matrix and the traces in your serverless application, and then get the whole thing together. It's very important to be able to correlate so much of data being produced and make sense of it, get some insights out of it, get insights which are actionable, right? So we'll go through that. Then we'll cover through what metrics are. We'll talk about some of the metrics which are available out of the box. We will talk about custom metrics that can be created. There is a new embedded matrix format which we rolled out, how it really enables you to do certain really nice things. We'll talk about that. And then we'll come to logging, tracing, to see a request flowing through the system. So tracing is about how do I really trace? How do I look at a request the moment it lands in my system, in my application, and traverses through different components that are there in the application before it goes back as a response, and be able to really look at behind the scenes how the system is behaving. We'll culminate the discussion by bringing it all together and seeing how you can correlate all of this with a single comprehensive view. That's where the whole magic happens, right? So let's get straight into it. Okay, so this, I believe, anybody who is seen AWS serverless presentation would have seen this, but just to level set what we mean by serverless, there are these 4 core tenets we believe it must adhere to for truly being serverless. Firstly, reduce time spent on things that are not core to your business, right? Most of the customers that we work with, their core business is not about managing the server, not managing the infrastructure. They are in a different business altogether. So they want to focus on their products and driving their business outcomes rather than focusing on the infrastructure itself, right? So serverless enables you by not really doing the undifferentiated heavy lifting around the servers itself. Then it's about the scaling, and it has auto scaling and automatic scaling to a near infinite levels, as we believe the cloud is all about. Resiliency and fault tolerance are also baked in. You don't have to really work around the resiliency and the high availability. The platform and the capability, service capability takes care of that. And then very importantly, you're paying for the business value derived. You're not paying for the servers. You're not paying for keeping the resources up and running, even if there is no request, even if there is no user, if there is no end user really consuming your application or your services, there is no infrastructure which is running, and nothing that you're paying for. Only when the infrastructure, the traffic comes up, the infrastructure comes up on its own and start really responding to the request itself. So all in all, basically it leads to faster time to market and maximum agility. And that's what is really the key for serverless. Okay, so with that, with a common understanding of what serverless is all about, let's move into the core aspects of the session, right? So first, we need to recognize that there is no such thing as an application that never fails, right? As our CTO, Werner Vogels, always brings about, everything fails all the time. We have to embrace failure. These are systems at the end of the day. They will fail. There will be some component or the other that will fail sometime or the other. We must assume we will need to deal with these failures, and often exactly when you don't want them to happen, right? And this whole thing is codified in the operational excellence of our well-architected framework, focusing on running workloads effectively to deliver business value. So failure is a reality, and we have to deal with it. Deal with it in a way which is graceful enough so that your end users don't really see that or go through that experience. They have the best of the experience possible. Okay, so with that, let's look at the traditional monitoring that we are used to in the typical monolith architecture, where you have all these layers which you need to monitor. These whole layers in the stack from the network, right from the network layer to the other abstraction layers of virtualization, operating systems, and also the business outcomes, right? So you had to kind of look through the whole stack itself, and it does get challenging. Undoubtedly, it does get. It's specifically the operation teams. They usually spend a lot of time setting up monitoring, alerting for many of these components across the layers that we can see here, right? Now, serverless kind of works differently. If you're building serverless application, platform has taken much of the burden off your shoulders, so you don't have to monitor many of the layers yourself. This becomes AWS responsibility. We look after the physical infrastructure, virtualization, operating system layers, and the platform runtime. This basically enables you to focus more on your business logic as part of your application code and data, and also have the business visibility. Very critical for you to know what the end user is really experiencing. Are business users, are the end user getting the business value? Are you making the right business impact, right? So that's how the serverless kind of changes, because you can now focus on the top two layers and not really worry too much about the underlying layers. So how has the monitoring really evolved, right? So as applications have evolved and customer needs have expanded, right? Monitoring needs to do a lot more than just watching the layers of the stacks. Customer experience has become hypercritical, very important, really. Resources, specifically in serverless, as you would know, are often short-lived. They're ephemeral in nature. As the request kind of goes back, its response back, the infrastructure might not be available anymore. At least you can't really see the infrastructure, right? So there are more and more connected parts to the application. We are connecting so many things with the application. It continues to evolve and continues to talk to so many components which are globally distributed at the least. And then we are also releasing things at a very fast rate, right? The whole agility, the whole idea about iterative development, experimentation, MVPs, rolling out, has a very fast release velocity. Now, to be in control of this fast-moving, evolving ecosystems requires a different mindset of how to really be in total control. So what is required is being able to quickly identify the source of the problem, right? If there is any. All customers need to be able to start with infrastructure or application level views, where I can really have a bird's eye view of, and that also dynamic in nature, not something which is static, right? Something which is a reflection of what's really happening inside the system. Real reflection of the traffic, real reflection of the problems if there are any, real reflection of the connectedness between these systems altogether, right? And if there is a source of problem, the customer should be able to identify and quickly drill in, right? Just zoom in into the resource where the problem is emanating from, look at the logs, look at the matrix, be able to correlate them, and understand the problem with the whole context being available to you. So if you're looking at the logs in isolation, you might not really realize, you might look at an error, but you might not really fully be able to understand where this started from, who is the caller of this call, where was it going, what was it trying to do. So getting the whole context when you're doing troubleshooting is really critical. The other critical need is the end user experience of the application, right? So this is core to the business outcome of how application is being used and how traffic is flowing within the application and facing any potential bottleneck or issue. It directly helps in knowing the business impact. Very critical, really. So with serverless, you have access to more granular information. Now your components are executing as functions. So you have very granular information about where the function, which all functions are doing well, which are not doing well, where is the potential for improvement, where is the challenge, where there is probably an issue. And you can convert that or look at them from a pure business metric perspective, whether my customers are able to do the payment in a fast way, whether they are able to book whatever merchandise you have to offer. Is there any issue all around that? So you look at it from a very business oriented mindset, which is really very different from the way we were doing the monitoring part earlier, which was largely technical. So, I mean, with all that said, we now come to the concept of observability, right? Which is the core idea of this session. So this word is derived from control theory. While monitoring can be seen as probing, querying, and reporting on different aspects of your application, observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. I'll repeat that. Observability is a measure of how well internal states of a system, which is how what's going on in the system, can be inferred from knowledge of its external output. So how well have I really put the probes in my systems? What are the telemetry that I am receiving? What information am I getting out of it? And is that something which is good enough for me to really know what's happening inside the system and be able to kind of, one, be aware of it, and then if required, act on it and really make sure things are working fine. Observability is having more visibility into the system as a whole. Not just knowing you have a problem, but understanding why is it happening and hopefully also creating a path of resolution. I like to think of it as being able to see the big picture from outside, looking in, and then to be able to work out everything that's going on in an application and be able to zoom in and zoom out depending on the requirement. And very critical again, without losing the context. So if I'm zooming in, if I'm going to the logs, I should be able to look at the traces around the logs, should be able to see what were the various communication where the request was flowing while these logs were generated. And the context really plays a key. So observability is really critical. So we focus on observability in this session. There are three key pillars of observability, right? So matrix, log, tracing, something we've already mentioned, and importantly, kind of correlating all of these together and providing a contextual link between them. So matrix, as we primarily understand, gathers numerical data about things you want to track for your application. Think of them as request rate, error rates, and probably some business metrics, such as number of orders placed, payments received, and all that, right? So the numeric, a time series data, which kind of gives you an idea of how things are performing over time. Logs are timestamp record of events, something happening at a point in time, a failure, an error, something informational, such as state change. Log may have certain metrics included in them, and we'll talk about it more in some time. And then finally, the traces. Traces are a single user request or a journey through a number of separate components of our application, the services which are kind of bringing the whole of this together, and kind of giving you a very visual way of looking at how different requests have traversed your application. To exemplify, if I'm alerted on a metric, I should be able to see the associated logs and traces with a few clicks and easily navigate between them and try to understand the various components involved. If I can do that, if I can spend less time working out what's currently wrong and have more time fixing the problem, I think the overall business objective is served, right? So that's what we will talk about. So for observability, these three pillars need to contextually correlate to bring better visibility into the system. You need to make sure you're collecting enough data to actually understand the system. Debugging is super important for observability. Using the data you collect to help with quick troubleshooting. Realistic testing honestly also happens in production, right? So not just in an isolated test environment. As often smaller components are released, more often testing these smaller changes in production becomes important. It's critical to really be aware of as and when I'm rolling out the changes, whether they are working fine. I should have a clear view of the metrics, the clear view of the traces, the information that's being generated. And at any point, if I see that they're not really matching the pattern that I expect, it should be easy for me to roll back the incremental change and bring it back to the stable version that it was earlier. So from AWS perspective, we have two main services to help with the overall goal of observability. That's it. That's AWS Amazon CloudWatch and AWS X-Ray. Now, CloudWatch is a service that collects monitoring and operational data in forms of logs, metrics, and events. It also gives a very nice unified view across your AWS resources, application, and services. You can set up alarms if something is important. You can visualize your logs and metrics pretty easily, and you can take automated actions, very importantly, based on what is happening in your logs, traces, or the metrics itself. X-Ray, on the other hand, is the tracing service. It helps anybody who wants to look at the data, analyze it, debug the environment, and it's particularly helpful for those built with multiple distributed components which are working together in tandem, so that you can see the requests, see the journey really moving across, and be able to understand where are the hotspots and where things are working fine. So CloudWatch and X-Ray have a number of services, and they probably are big enough to really be talking about them in a separate session itself. But primarily, these are the four capabilities, the four breadth areas that we talk about. So first, they allow you to collect the logs and metrics, right? The information needs to be collected. Then you monitor the collected data using dashboards, alarms, so that you can see what's going on, view history, and spot trends, right? Then you can act on the data you've collected, you're monitoring, you would want to act on it, right? With alarms, if an alarm is fired, either based on the threshold values that were defined or anomaly detection that could be used, you can then send an alarm or run tasks automatically to do some rectification, and you can also do canary testing, right? In the end, it really helps you also analyze the whole thing, whether it's a log by running queries or visualization or analytics using higher level services like service lens, something which we'll see, to analyze your application across the whole thing. But CloudWatch and X-Ray are not the only options. Pretty much like everything else on AWS, we have a broad partner ecosystem with some amazing monitoring and observability products and features. In the interest of time, we would not be able to cover those today, but some of the partner integration offer a lot more than just monitoring or observability. I would strongly encourage you to look at these options also. Developing serverless application doesn't have to mean you can't use your existing tools if you're already relying on those partners. So the idea is to make life easy, things that you're comfortable with, you should be able to carry forward in your serverless application. Okay, so let's delve into the metrics pillar. First, let's talk about the metrics that are available to you without you doing anything at all, right? So once you have the application deployed, CloudWatch comes with a number of standard built-in metrics. It gives you the telemetry right away without you really putting in any probe. And these are important, more important in the serverless environment, because you can't really log into a server there and kind of look at this data. We have to provide you all this data baked out of the box itself. These are automatically generated when you're using Lambda, API Gateway, and many other serverless applications or services that we have to offer. Lambda, as you can see here, offers 13 built-in metrics covering various invocation, performance, concurrency metrics, so that you can easily see how many functions that you have deployed, they're executing, how long they are taking, what invocations are you getting. There are also many concurrency metrics for seeing how many functions are running at the same time. Very important for a serverless function perspective. From an API gateway perspective, we give you 7 metrics out of the box, which show you how many API calls you're receiving, along with any error counts and the cache details if you're using caching in the API gateway. HTTP and WebSocket API also gives you similar metrics. Remember, these are automatically generated, so you don't have to do anything for really looking at this matrix. But as helpful as they are, the built-in matrix are not enough. That's the lowest common denominator, but typically we have seen you would need more visibility into your application, and not just at infrastructure application level. that you're looking for. You may need to track your business and customer metrics. How is your application performing against your business goals? Are you generating the revenue you need? Are you getting enough people signing up for the awesome service that you've created? Are customer uploading the number of tracks you expect? So a very different perspective of looking at it from outside in, from the business outcome perspective. Similarly, operational metrics are also important for observability. How often are you safely deploying? How long, how long does it take for you to recover from failure? Right? These are important operational metrics. What if you want to create metrics for a particular category or environment? Another dimension altogether, right? This is why you need custom metrics. These are the metrics that are specific and custom important for you, your application per se. And you can generate custom metrics by instrumenting that in your code. I have a sample on the right hand side of the screen, as you can see. This is a Lambda function. You can observe that it's spitting out a specific data point. Capturing data has a dimension called write. And let me see if I can show you this. So this is where the write is being captured, right? So and then it goes out and sends that data to the CloudWatch metrics. This basically illustrates that you can publish fine-grained data metrics based on the function capability. If there is something custom that you need, it's pretty much feasible using the custom metrics that as a sample that I'm showing here. This is improved by something we call the embedded metrics format, and that's something which I'll cover shortly. Okay, switching to logs now. CloudWatch logs generates operational data for a number of AWS services. For API gateway, REST APIs, you can have execution logs and accessing logs with two levels, error and info. You can also choose to log the method request body, the response body content for a deeper troubleshooting analysis itself. Now, the API gateway REST API logging is either set globally in the stage of an API, or you can override the global setting at individual methods if required. There is also CloudWatch logging available with the new HTTP APIs and WebSocket APIs. For Lambda, there are some log lines that we capture automatically for every single request. Things like the duration of time. We also capture if there is some error. But if you additionally want additional data to be there in the logs, you can directly do that from the application code using the standard debugging like console log statements or whatever is the equivalent of your function language of your choice. This is useful for logging basic request information. Pretty helpful when the code is deployed and you're totally dependent on this information to tell you what is going inside the system. You can also create JSON structured logging. We'll touch on that, and also use our new embedded metric format. Once you have your logs created, you can do a number of things with that, right? That's the base data for you. You can filter them, you can create metrics for them, or even ship them off to somewhere where you can do the analysis, with popular options being Elasticsearch or using S3 with Athena being as the interactive query service tool. So looking a little more at the structured logging, here's a structured logging message format, which may be part of your event. Your Lambda function is working on your application. This has number of fields. You can do a language equivalent of the language you're using in your function. In JavaScript, you can use the console.log. In the Python, you might have a print statement, and so on and so forth, to send these CloudWatch logs messages. This gives you some basic logging information and appears as text line in the logs, but it's difficult to correlate and often have the whole complicated system give you a value of just by the text message and not really any having metrics provided from that. That's where the embedded metrics format steps in. So to help you with this, AWS released AMF to publish logs using a specific format. This allows you to embed custom metrics which may be part of the event payload alongside more detailed log event data, which could include invocation information. These then get automatically exported as matrix, right? So while you are generating the log, the structure of the log is such that it will automatically generate the matrix without the need of any additional processing on your part. And that can be consumed directly in the dashboards, even in the alarms also. There are open source client libraries available for Node and Python. And I have a snapshot here which kind of shows you how this can be done. You can see the structure of a JSON embedded metric format log here. You can see this function includes the Lambda function invocation information along with the metric in this case, time in a specified unit, milliseconds. This log with the included metric will then automatically be exported to CloudWatch Matrix so that you don't have to ship your console.log somewhere else to then have a whole process of extracting the matrix or kind of analyzing the data that you're looking for. Now, one thing to mention here is that embedded metric format is more verbose, as there is more information here than the typical console.log messages. It's certainly more useful information, but it will impact your CloudWatch logging billing. So make sure you're managing your log size and using appropriate retention policy, which is anyway a recommended practice. So we can go a step further with this. One of the great things about the embedded metric format is that it allows you to use CloudWatch insights also, which are primarily helpful to drive actionable insight from the log. This allows you to do more complex queries. Say you're looking at the top 100 longest Lambda execution, right? This query creates a report, the sample that you're seeing here, which gets a request ID and then also retrieves and sort by the build duration, right? Something which is important from the overall cost perspective. And then it displays the top 100 in the results. You could use this to filter out any Lambda function across one or more log groups that are taking longer than expected, and maybe investigate them further for any potential performance issue that might be there. Or you could just be improving on what the current state is. You could also use this to know where you can look first to save the cost by finding the most expensive Lambda execution. Similarly, another example, here we're talking about finding the most recent 100 errors. This could help troubleshoot and pinpoint function errors without having to navigate each function across the logs group manually, right? So CloudWatch Logs has also added recently the saved queries for insights. This allows you to save and organize queries in folders and then easily run them again, even for a different purpose by another team or another application. And for all you may know, you might want to include them in the run books so that it becomes easier for your operational team. CloudWatch Insights gives you some powerful querying and analytics capability to get insights into your logs. Okay, now moving on to the last pillar, which is tracing. Tracing, as we discussed, is about understanding the path of different events as it propagates through the components of your application. X-Ray is our service for tracing. It basically provides a distributed tracing solution from AWS, which provides an end-to-end view of requests as they travel through your application and shows a service map your application of the underlying components. Again, purely dynamic based on what's happening under the hood at this point of time. X-Ray collects data about the requests that your application serves, which helps you understand how upstream and downstream services may be affecting the workload that's currently deployed. You enable X-Ray for various AWS services, including the serverless ones like API Gateway, Lambda, SNS, SQS, and AppSync included. For Lambda, you enable X-Ray and then optionally instrument your application code to add tracing data if you need more fine-grained tracing for different things that you're doing inside. For API Gateway, just by enabling the active tracing, it reports data to X-Ray as well as inserts tracing headers into the HTTP calls, which can then flow into your Lambda function. So you can know which API gateway call is associated with which Lambda function. That's the correlation under the hood phenomena, that the mechanism that the platform is using. X-Ray receives data from services as segments, which we'll see shortly. Segments for a common request are then grouped into traces. Segments then can be further broken down into more granular subsegments. You can then add custom data key value pairs with annotations and metadata, very powerful concepts, which are custom description of how you can add information to your instrumentation that you're producing. So you could, for example, capture the payment ID generated by a third-party service and see how that flow is going across different functions. This is a quick example of Node.js. So you can see on the top where we've including the AWS SDK and the X-ray kind of covering that to kind of ensure that the X-ray instrumentation is produced. And then in this case, we are instrumenting the S3 bucket activities. So all the S3 bucket activities related would kind of come into tracing. There is an option to individually select the service if you don't want to do a blanket coverage like we have done here, where you would want to cover specific services only. That capability also exists. Now, AWS X-ray also creates a very nice visual map of services used by your application with trace data so that you can use to drill into specific services. As you can see here, you can see the connection between different services and you can create dependency trees and be able to kind of see if there are certain issues by the different visual colors that we give. Looking at the individual traces, you can see the specific errors. In this case, there is something related to the S3 access. Right, so this kind of makes it easy for you to make it visual, intuitive, and easy for you to really look at the errors. Now let's focus on bringing the whole thing together. Let's change gears and kind of talk about the magics as to how this whole thing comes together to give you a much higher aggregated value. So last year at reInvent 2019, we announced Service Lens, which really ties together CloudWatch metrics, logs, and traces more closely to give you a complete view of your application and their dependencies. Think of this as a single pane of glass, which enables you to more quickly pinpoint performance bottlenecks, where the issue is, have a better idea of how users may be impacted. Log and metrics are automatically captured to the base level, but it requires to enable X-ray for this to come up. In addition, another part about the end user experience simulation is facilitated by CloudWatch Synthetics, which allows you to monitor web application using modular lightweight canary tests. This is done by creating a canary using existing blueprint or a script that you might have created. Then you set up thresholds where you want to be alerted. Finally, you can troubleshoot failure using features like getting the snapshots of the screen that your customers might be seeing once you run those canary tests, and also have the HAR file, which is the HTTP archive file, which is the standard format to help in understanding the browser interaction with the site. So you have the whole thing to analyze in a much easy fashion. Really helpful to really look at the whole application from a customer perspective. We'll just look at certain views just to get a better sense of it. So this is a typical application where you have multiple nodes kind of talking to each other. This kind of helps you quickly visualize the whole application at a single shot. This is a typical application in production, right? So where your multiple components are collaborating together for a much bigger purpose. This is all dynamically generated based on the requests that are flowing in through the system right now, right? The thicker lines are interactions which are happening more often. The thin lines are where there is less interaction. So it gives you a sense of where the traffic is maximum flowing, right? And then similar is the case with the node size. It has modes, two modes for now, right? So there is a request mode on the top right hand side, as you can see, which kind of shows the whole information, the visual basis, the request data. And then you can switch it to a latency mode so that the size of the nodes and the edges are kind of reflecting the latency in the application itself, right? So you can focus on, for example, the areas where the latency is higher and kind of drill through that. So this is another application where I'm just showing a view where I've clicked on a particular Lambda function in the service map, which is part of the service lens. And then I could see here the matrix correlated to it. So as you can see here, alert is being triggered. So bottom right, you can see the alert is being triggered with 3 metrics being available about latency, request, and faults over the selected time period. With the request specifically broken down at P50 and P90 to understand the change on those specific percentiles over time, as you can see in the graph, that orange and the blue line down below. Going to the second pillar of traces, to understand the request flow and visualize application performance, it shows where your P50 of your application stands versus P90 and P99. To get a good understanding of the variation and how many requests are falling into which zone. For those traces that we saw, one can get into the details and look at further segmentation of those requests. So the thing that I was initially discussing about how the request is flowing, you can look at the finer segmentation and look at the components that the request has traversed through and understand how much time was spent in each component and what response code was observed, right? The green is good, the red is obviously a concern that you want to take care of. Coming to the third pillar of the logs, in the same context, while you're looking at the traces, if you kind of scroll down, you would see that where you were looking at the tracing details, you would go down, you will look at the correlated logs for those traces. So it's all happening in context of a bigger view that you were looking at. It helps you troubleshoot in cases where there are any issues. So this is the overall summary of how it comes together to give you a consolidated view, something where 1 + 1 becomes 11 and helps you traverse different levels of your applications, kind of zooming in and zooming out. So in a nutshell, a typical troubleshooting workflow, the way I look at it, would start with a notification based on anomaly detection or an alert which would trigger an alarm. The moment you get that, you would open up the service lens, take a look at the service map to visually identify if anything stands out, like anything is red or there are bigger circles. Then you would dive into the traces to understand where the call failed, which call failed, why it failed. And then you could look at the X-ray analytics, something which was rolled out recently again, to understand how its performance has changed over time and got to where it is right now. Is there any correlation with the other errors that you're seeing? And in the end, you could use log insights to search for similar situation with the log information to look at the specific issue. This is where the log data kind of helps you trace back to the X-ray data which was available. So in summary, we've gone through many concepts today about observability, and hopefully we now appreciate how it's more than just monitoring, the traditional monitoring which we used to do with microservices, distributed architecture in place, how correlating different data points presented in 3 pillars of logs, metrics, and traces helps in being able to achieve better operational effectiveness, how tools like CloudWatch and X-ray helps you, the embedded metric format, which gives you a dual power of logs with automated generated matrix, and finally with Service Lens, how all of this comes together and gives you a single portal for desired visibility and troubleshooting. Thank you so much for listening to me, and we have come to the end of the session, and I'm open to take any questions now.
Thank you so much, Kapil. That was a great session, and thank you for sharing your reflective knowledge with us. So we actually do have a lot of questions for you from your session today, from our attendees on YouTube. So my first question to you would be, how do newly introduced Lambda extensions help us to achieve better observability?
Awesome. So clearly the audience is much ahead of the presentation. And I'm really glad that comes up. So just for level setting the context, so the Lambda extension was rolled out sometime last week. So it's as recently hot baked as last week itself, and which is why I couldn't capture that in my presentation. The idea is that you should be able to now instrument Lambda functions not at just the invocation time, but also when the initialization happens and when the final cleaning up of the sandbox happens. And what is it being used now is all the partners that I talk about, they are now able to instrument into the Lambda functions at different phases which they were not able to earlier, and give you a much more comprehensive view of how the Lambda function, from the point of it getting initialized, a container or the underlying container getting initialized and getting through the life cycle, how much time each service or each request is taking. So it helps you really get a better telemetry. It operates parallelly. It has a very different and very interesting execution model. It interests some kind of offers some interesting use cases. And we're just at the starting of it.
Right, as you said, this last week, right? So, moving on to the next question from our attendees. The next question is, if we deploy application in different regions, can we get logs specific to the region?
Absolutely. So there
Right.
are logs that you can get within the region. There is a capability which allows you to look at the logs across region and across accounts also. So there is a capability now by virtue of which you can connect not only across regions, but across accounts. And we are also kind of hoping that the same thing will get stretched to X-rays also. So yes, we
Right.
acknowledge that need and we are working on it. From logs perspective, it's already there.
Sorry, then. All right. Great. I hope that answers that question. The next question is it possible to extract data only from the dashboards of CloudWatch, which we can feed to the existing dashboards?
Yeah, so as I mentioned in the session itself, you can pretty much extract data. There are various ways to it. You can send data directly to, for example, your Elasticsearch or S3. It's available right from the menu, console menu itself. It's baked in, that capability is baked in. Then you have something called as subscription filters. So where not only you can get the data, but you can also filter out. So you can look for certain type of information which you want to send across. It could be to your Lambda function. It could be to any of your analytical system where you want to send that. So yes, you can do all that very easily.
Right. All right. So the next question is AWS X-ray API oriented or across heterogeneous systems? Like say databases, web services, or any other enterprise systems.
Absolutely. So you can pretty much use AWS X-ray with on-prem systems also. So you can, for example, have a hybrid system where your application is traversing from the cloud, getting into your on-prem systems, and then coming back. And you can trace the whole thing with finer segmentation. Yes. And you can use it outside AWS also. So it's available as an open source thing, and you can basically instrument anything outside AWS also.
Right. All right. So another question is that
Yes.
are the X-ray services available as public APIs or so, and like any non-AWS environment can invoke? So I think, yeah,
Yeah, we just talked about
answer
that.
that.
Yes, they
Right.
are
Yeah.
available.
Perfect.
Yes, they're available, and you can use them outside AWS. Absolutely.
AWS. Right. All right. So the last question is how actually is user experience evaluated with the combination of logs, metrics, and traces?
So that's where the service lens kind of comes together. So that's the
Right.
way we call it, the service lens. So there is a lens that we have given by which you can look at your services in a contextual view. So you start from a high level view where you kind of see the whole application with different components, how they're talking to each other. That's coming from X-ray, right? So that's data coming from X-ray. Then when you click on a particular node, you can look at the matrix of that particular service. You can look at different data, the latency, how many requests were there any errors. And when you kind of get into the dig deeper into those metrics, you can look at the logs, right? So if there was an error, what were the logs saying? The specific verbose message, which you would typically find in your logs. So you can clearly kind of start from the top and go to the bottom, or kind of start from the bottom and kind of go up to the top. Yes.
Right. Okay, so that was the questions from the YouTube comments. We from the community also have like a couple of questions for you if you'd be able, like if you'd be ready to answer them. The first question is, as an AWS professional, what keeps you busy on a day-to-day basis? I mean, how does your day look like? Because all of us are so new here in the community, so we'd like to hear from someone, professional.
Awesome. No, absolutely fine with that. So every day is full of exciting stuff, honestly. And there is so much to talk about, honestly, that I could go on for a very long time. But typically, if I try to kind of step back, it's usually a lot of customer discussions, a lot of discussions with different customers about what they're trying to do with the platform. Are they doing it the right way? Is there something that we can recommend to make it whole better? Kind of reviewing and evangelizing about the platform, making sure that they've got the things the right way. Talking about the various capabilities, the innovation pace at which we are rolling out things. So we have to kind of take the ownership of making sure that the things that we are rolling out, customers are aware of it and are using in context of their business. I mean, not for the sake of knowing the technology, but kind of translating that technology into how it can really help the business itself. So that's really
Right.
all about, right? How you can really, business can take advantage of the platform itself to really be more agile and really going about it, right?
True, true,
So
true.
a lot of
Correct,
fun
correct.
stuff, I must tell
I
you.
agree, I agree. That's what it looks like. So there's actually another question from the comment section. I think the users are really interested in knowing from all of your session. So the question from one of our users is, would any data compliance we need to be taken care is one of the case? I mean, would we, when we are feeding our app logs into the AWS?
Correct. So important question, and yes. So our logs, X-ray systems, they are compliant to different public compliances that are available, including the HCI and different compliances that are available. It's very much well documented. I can share the link with that. It clearly talks
Okay.
about the different compliance level at service level that are already existing, and how you can obfuscate certain data, for example, if you don't want it to be printed, and at the same time how it kind of naturally aligns to the different compliance level and different governance level that your customers might need at the end of the day. Yes, it's all
Right.
publicly available and I can share that.
Yeah, that'd be great, actually. All right, so we'll be closing the session with one last question for today. It's again from the community. So we'd like to know that there must have been, like, you must have faced some sort of problems while architecting on AWS, right? Because initially, when you were in the community and in AWS, so any of these tough problems that you faced when architecting on AWS and how you solved it, if you
So
could shed your light on that.
okay, so there be many instances. I would not say problem. I think that's our core of our job, really, right? Solving
Right.
problems. So when we say
Exactly.
solution architect, our core job is to solution the problem statements that customers
Exactly.
have.
Fair
And
point.
I
Yeah.
think if I have to really focus on one specific piece, I think it's the scale. So in different conversation with different customers, I think one of the important capability that everybody now talks about is scale. How can I really scale from really, let's say, a few users to tens, thousands, and millions of users, and kind of
Right.
architect it right from day one itself, so that I don't have to really rethink about it when it's in production, when it's really popular. So the resiliency and scale factors are really critical, and that's what we really spend a lot of time on, to ensure that once it goes out in the wild wide west, then it's kind of, it can take care of its own, right? It can take care of its
Right.
own and can auto heal itself, can auto scale itself, and really evolve and help businesses really grow themselves. So yeah, that's the area I think where we spend a lot of time on.
Exactly. Great. Great. Like amazing answers. I mean, we had fun listening to your session, and it was an amazing session. I hope all of our attendees on YouTube also enjoyed the session. So, Kapil, we'll let you know if there's any additional questions from the attendees. Please join, log into YouTube, and you can directly comment there as well. Once again, I'd like
Sure.
to thank you for coming here today with us, joining our community day, and thanks again.
No, Vaishnavi, the pleasure is all mine. Thank you so much for being a part of it. I'm really excited.
Right.
So thank you so much. Yeah.
Great, great having you here, sir.
Bye bye.
Right, right. So the next session is going to be live soon. Please stay tuned. It starts at 12 p.m. Thank you, everyone. So, welcome back everyone to track one. We're in for technical sessions today. Continuing our technical sessions for the day, we are here with talk 3. But before that, I'll just remind you guys to not forget to share your feedbacks via Lanyard. Without wasting any more time, let's dive into our third technical session for today. Our next speaker is a solutions architect, digital and cloud consulting from BlazeClan Technologies, Swapnil Jaketia, who's an architect by day, a developer by night with more than 10 years of experience on various cloud platforms. Swapnil helps enterprises on the cloud adoption and cloud migration journey, along with app modernization and DevOps. He is always on the lookout for new ways to solve problems, and in his spare time, he enjoys watching History or Discovery Channel and play video games. Swapnil will be talking about the hottest topic today, that's infrastructure as a code with AWS CDK. I would request everyone to please join me in welcoming Swapnil to share his experience. Welcome, Swapnil, to the AWS Community Day. Over to you.
Hello, guys. I hope all of you tuned in for Jeff's session and enjoyed it. I certainly did. And the key takeaway for me was, always being open to share your knowledge. And that's what this event is all about. Right. So I welcome you all to the session on infrastructure as code with the AWS Cloud Development Kit or the AWS CDK. My name is Swapnil Jaketia, and I'm an AWS Solutions Architect at BlazeClan, which is an AWS premier cloud consulting partner headquartered in Pune. I started off my career around 10 years ago as a Java developer, focusing on cloud-based projects. And since then, I've moved on to a cloud advisory role, wherein I focus on areas such as large-scale cloud migrations, DevOps transformations, and app modernization. A quick look at the agenda for the day. We'll start off with an introduction to infrastructure as code, and we'll see how it translates on AWS. We'll then move on to its benefits and what are the some of the limitations that we see on traditional infrastructure as code implementations. We'll then move on to the Cloud Development Kit or the CDK and see how it helps us to address those limitations. We'll cover its components and concepts and have a quick look at some of the developments that CDK has gone through. At the end, we'll have a quick demo wherein we will see CDK in action. So starting off with infrastructure as code. If we have a look at the concept of infrastructure as code or IAC, we'll see that it consists of 3 main components. At the heart of this lies something which we call as the resource provisioning engine. This engine accepts input in the format of a text file. This text file contains information about the sort of resources that you want to provision, along with the configurations and customizations. This text file is then fed into the engine, which digests it and provisions your cloud resources for you. If we have a look at how this translates onto AWS, we'll see that the resource provisioning engine is replaced by AWS CloudFormation, which is an AWS native service. And AWS CloudFormation accepts input in the format of JSON or YAML templates. Apart from AWS CloudFormation, there is another third-party tool known as HashiCorp Terraform, which is quite popular and accepts input in the form of HashiCorp configuration language. Now, what is the big deal around infrastructure as code adoptions? I mean, what's in it for me? The whole idea of adopting infrastructure as code is the expectation that as a user, I will get to leverage all the benefits that you can expect from a typical software or application development process. Meaning, I get to version my infrastructure. I can bring in things such as CI/CD, which will help me increase the deployment times and thereby reducing the time to market. I can bring in a lot of automation and help protect against manual errors and configuration drifts, which is a real world problem. If we have a closer look at the 2 formats that AWS CloudFormation supports, which is JSON and YAML, we find that it's not real code. It is more or less just configuration syntax and offers little support out of the box. There is no abstraction offered and no best practice implementations built in. And as a user, as the IT landscape expands, I will see that managing these templates becomes a very tedious task. So that is a big problem. How do we address these limitations? So if you have a look at the AWS Cloud Development Kit or the CDK and its official definition, we'll see that there are two aspects which stand out. Harnessing the true power of modern programming languages, along with leveraging the majority of AWS CloudFormation. So that's quite interesting. With the CDK, I now get the ability to use high-level programming languages such as Python or Java, along with AWS CloudFormation. It also comes pre-built with built-in best practice implementations and offers a real high level of abstraction. And the best thing about the CDK is that it is open source, which allows the community to contribute to the project. So we've had a look at this process earlier. This is the typical infrastructure as code cycle. Where does the CDK fit in? We'll see that the CDK fits in right at the very beginning and brings in two components, which are the CDK app and the CDK CLI. The CDK app is nothing but the programming code that you write, and whereas CDK CLI helps to execute this application, which is your code, and generates the low-level JSON or YAML templates for you. So if I use the CDK, I no longer have to write JSON or YAML formatted syntax. These generated templates can also be pushed to CloudFormation using the CDK, which are then in turn used to provision your cloud infrastructure. So if you recall, the original intent behind infrastructure as code adoption was to move as close as possible to an app or software development process. And if we take that lens and apply to this process, we will see that the CDK app acts as your source code, whereas the CDK CLI can act as your compiler. The CDK CLI compiles your CDK application code and generates the output, which is the CloudFormation templates. So using the CDK, I'm moving very close to a typical app development process. The three main components of the CDK are the core framework, the construct library, and the CDK CLI. We'll dive deep into each of these components next. The core framework consists of three aspects. The first one is the CDK app. The CDK app is the outermost container within which you define your CDK stacks and resources. A CDK stack is nothing but a collection of resources or constructs that you will define. And a CDK stack maps very closely to a CloudFormation stack. If we talk about what a construct is, it is the fundamental unit of CDK and maps very closely to a native CloudFormation resource. However, CDK comes with the ability to define custom constructs as well, wherein you can bundle more than one resources into a single custom construct. Now, what is the CDK construct library? It is essentially the modules or packages which are specific to each language, which ship with the AWS CDK and which you can consume within your CDK application. You can browse to the CDK construct library on the web and have a look at the various parameters, specifications, and functions that the construct library provides. Now, each of these constructs is broken down into one of the three categories. Starting with the level 1 constructs, these are the base of the CDK construct library. And level 1 constructs are available for each and every AWS resource which is supported by AWS CloudFormation. These being the low-level constructs, they don't really offer a lot of abstraction. And if I have to talk about the amount of effort that one has to spend in using level 1 constructs, it would almost be the same as if I'm using a native CloudFormation resource. Level 1 constructs have a prefix of CFN, which help you to distinguish them with other constructs. Moving on to the level 2 or the high level constructs. Now these are the constructs which give CDK its true power. They offer a high level of abstraction as well as come pre-built with a lot of best practice implementation and default values. The whole motive of level 2 constructs is to reduce the amount of complexity and boilerplate code that as a user I will have to write. And most of the AWS services out there are supported by the level 2 constructs. So for example, if I use the level 2 construct for an S3 bucket, it is going to provide me with a lot of capability as compared to a level 1 construct for an S3 bucket. So using a level 2 construct is advisable instead of a level 1 construct. The third one is the higher level constructs or known as patterns. These are essentially production ready pre-built solutions to most of the common use cases out there. And patterns typically span across multiple services and resources. Patterns are also vetted by AWS Solutions Architect and follow the AWS well-architected guidelines. You can browse the AWS Solutions Library and gather more information about the patterns available out there. Patterns come with predefined defaults, but also offer you the flexibility to configure as your requirement. Moving on to the third component, which is the CDK CLI. The CDK CLI would be your primary tool, which you would use to interact with the CDK application. And it offers a range of commands which can be used for tasks such as app instantiation, compilation, execution, and deployment of your resources. A few of the CDK commands are shown on the screen. So if we have a look at the typical flow a user would have to go through when working with the CDK CLI, it will look something like this. I could use the CDK init command to initialize my CDK application. And at the time of initialization, I have the choice to provide which language I want to use. So for example, if I want to use Python, if I want to use Java, I can specify that at the time of the app initialization. The next one could be CDK Bootstrap, which is essentially used to deploy all the prerequisites which are used by a CDK application. This is essentially an S3 bucket, which will be used to store all the compiled code or the compiled templates that your CDK application generates. The next step would be either use CDK LS or CDK Synth to compile your code. CDK LS not only compiles the code, but also lists out the various stacks that you have defined within your CDK application. And CDK Synth helps to print out the generated output of a particular stack onto the terminal. CDK deploy is self-explanatory. It helps you to deploy the resources or stacks that you have defined onto your AWS environment. Now, let's say I have made a few changes and I want to compare the changes that I have made versus my deployed resources. I can use the CDK diff command to get that information. And at the end, if I wish to delete everything, I can use the CDK destroy command to clean up my environment. So now that we have a look at the three components, let's have a quick look at some other concepts that CDK provides, which really help to improve our experience with the CDK. The first one is a context, which is nothing but a concept used to provide and extract information between various stacks and constructs within my CDK application. It's important to note that any construct variable or information that I have described at a parent node will be available to a child node as well. For example, if I define a construct variable at stack 2, it is going to be available for, to all the child nodes, which are construct 2, construct 4, and 5. But it will not be accessible to stack 1, construct 1, and construct 3. The second concept is assets. So assets are nothing but files or directories which are required by your CDK application. This could be a Python file, which is required by your Lambda function, or it could be a Docker image, which is required by an ECS application. So using assets, CDK is able to upload these artifacts onto AWS internally. I do not have to upload these to respective repositories or a bucket before I deploy my stacks. So that's quite handy. The third one is the use of connection methods. So every resource that comes with or creates an Elastic Network interface supports the connection methods. What are these used for? Connection methods are used to manage traffic between two or more resources. All that I have to do is provide the source resource, the destination resource, and the port that I want to allow the traffic on. Using the connection methods, CDK will automatically update the security group rules of the source resource as well as the destination resource. Similar to the connection methods, you have the grants methods, which help you manage IAM permissions between one or more resources that you define. So for example, if I have one particular resource which needs permissions to interact with another resource, I can use the grants methods to do that. So now that we have covered those components and concepts, let's have a quick look at the various developments the CDK has gone through. The CDK was released in the developer preview in August 2018 and released in GA with Python and TypeScript support in July 2019. Java and C# support was released in November 2019. And since then, CDK has grown leaps and bounds, and the CDK for Kubernetes or CDK8S was released in May 2020 with Python and TypeScript support. So what the CDK8S does is apply the same principles of leveraging high-level programming language to generate your target files. You can use a CDK8S to generate Kubernetes artifacts. Important thing to note over here is that CDK8S not only supports EKS, but also native Kubernetes. So Kubernetes users out there can leverage CDK8S not just on AWS, but on other implementations as well. Recently, in July 2020, AWS and HashiCorp joined hands to come up with CDK for Terraform. So using the CDK for Terraform, you are able to use high-level programming languages to generate Terraform files. So with this, we are able to get a very good idea about the real power of CDK and that it is gathering a lot of momentum with each passing day. Right, so before we start off with the demo, let's just quickly cover the steps of installation and initialization of a CDK application. CDK is installed using Node.js or NPM. And once installed, you can use the CDK init command to initialize your application. The CDK init command has a -- language flag, which can be used to specify the language of choice. For this demo, we are going to use Python as our language of choice. Now, once my application is initiated, what are the steps I need to do to create a full-fledged project? There are essentially 3 steps, and the first step is initialization of the app construct. The app construct is available within the core framework, and I can use a built-in method to initialize the application. The second step would be the definition of my stacks and constructs. So each stack or construct takes 3 parameters as mandatory. The first one is scope. The second one is ID, which is a unique keyword that will be used to recognize my resource. The third one is props or properties, which varies from each construct. The third one is app synthesis, which will generate the output, the end result, which is my CloudFormation templates. Okay, so the first example that we are going to cover is the very basic one, which is an S3 bucket. So I'll be using the level 2 construct s3.bucket construct available within the AWS_S3 module. And when I compile or synthesize this 4 or 5 lines of code will generate around 90 lines of JSON cloud formation template. So you see the true power of CDK coming to the fore. Now, if you talk about what sort of abstraction is this going to provide me, if you look at the last parameter, which is encryption, I've only just specified that the bucket needs to be encrypted with a KMS key. I have not explicitly specified a KMS key resource. However, CDK is intelligent enough to understand that since the encryption property has been specified, it is automatically going to generate a KMS key resource with a default KMS key policy for me as well. So that's the true power of CDK. Now let's have a look at a demo. So I'm going to move on to my CDK project. So over here, I have initialized a Python project using CDK. And the first file that we are going to have a look is the Python requirements file. So within this, I define all the packages that I need. The core package consists of the CDK core framework, and the AWS_S3 and AWS_EC2 are the two modules or the two construct libraries that I will use for our examples. The second file that we're going to look at is the cdk.json file. This consists of two keys, which is the app and context. Now, context is what we are going to use to pass on values such as the region, other parameters which are relevant to my code over here. And we'll have a look at how do we get these values within our code. The first one is going to, it is app.py. This file is the root file of my project, and it is going to be executed first when I synthesize the application. Now, I told you that CDK app definition is a 3-step process. So the first one, which you can see over here, is app initialization. I also have a couple of stacks defined over here, which is the second step. And the third step is app synthesis, which I'm doing over here. Stacks are nothing but classes, which I have defined under a directory known as stacks. So if I go within this directory and have a look at the S3 stack, I will see that there is a class, which is my S3 stack, which is extending the core.stack present in the core package. And this is the exact snippet that we had a look on the slides. Right, so what I've done over here is defined my resource and imported it within my app.py file. And I've used this line of code to instantiate that as well. So let's see what happens when we synthesize this. So I'm going to use the cdk synth command to do this. And the name of my stack is my S3 stack. So I'll provide the name of the stack to generate the output. Right, so why that? So this is going to compile the Python code and generate the output YAML syntax for me. While that happens, let's have a look at the next example. So we had a look at the S3 syntax. Let's move on to the next example, which is that of a VPC. Now, on your scene, what you see is a very simple 3-line code, which defines the VPC with a CIDR range of 10.00/16. If I synthesize this, I will see that this 4 lines of Python code generates around 600 lines of JSON cloud formation templates. Now, how is this possible? This is due to the level of abstraction and default values that CDK comes in. As per best practices, a VPC should be spread across at least 2 availability zones, and by default should have 2 public subnets and 2 private subnets. If the region or the environment that you're deploying it consists of 3 availability zones, CDK is intelligent enough to detect that and generate 3 private subnets, 3 public subnets, and 3 NAT gateways, which one each in each availability zone. Right. But as a user, I don't really have to use this. If I want to customize it, I can do something like this to customize the VPC definition for me. So using this snippet, what I'm doing is defining a typical 3-tier VPC. And I can use properties such as max AZs and NAT gateways to define the number of NAT gateways that I want to create within the target VPC. This is useful in scenarios, let's say I have a development or a test environment where I don't want to use or I don't want to create 3 NAT gateways. What's interesting over here is the subnet configurations property. Now, the CDK takes a very different approach to defining a VPC. I no longer have to deal with defining each and every subnet separately, defining each and every route table separately, and then plugging them all together. CDK treats subnets in the form of layers, and that's what I have used over here, wherein I am defining 3 different layers. CDK also helps you to specify the type of each layer. And in this example, I'm defining the web layer as public, the app layer as private, and the data layer as isolated. And the subnet CIDR range for each of those is going to be /24. So based on the type of subnet, CDK is intelligent enough to understand what sort of routes it needs to create in the route tables associated to these subnets. For example, if it is a web subnet, the route will route to the internet gateway. If it is a private subnet, the default route will be routing to your NAT gateway. So this is the amount of abstraction CDK comes with. Let's go back to the project and see if the synthesis is complete. It's still, there it is. So if we have a look at the synthesized code, we have the KMS key resource over here as promised, and the S3 bucket resource over here. Now, I talked about best practice implementation that CD comes with, and that is something that you will see using the deletion policy. So the deletion policy, which is default, it is something that I did not specify, is the default built-in within CDK. And this really helps us to protect accidental deletion of my data. I obviously have the choice to override this if I want, right? So now that the synthesis is done, let's do one thing and let's deploy the stack. So what I'm going to do is use the CDK deploy command to deploy the stack. While that happens, let's have a look at the network stack that we just had a look through. So this is the same snippet that we saw on the slides. A quick thing to check over here is that the CIDR or the VPC CIDR is being fetched from the context. Each construct or node within the CDK app comes with this method called as try_get_context, which will essentially read the context variables from either the CDK.json file or other ways which are there to define your CDK context variables. Now, if you see over here, I am being asked for confirmation to deploy the stack. So that's interesting. Anything within CDK that requires or which would change security features such as security group rules or things like encryption or IAM policies, CDK is going to ask for permission to deploy such changes. So CDK really takes security quite seriously. In this case, if I review the changes, I'm happy with them for deployment. So once I confirm, CDK is going to go ahead and deploy the stack for me. And if I have a look over here, go to my account, go to the CloudFormation console and refresh, I should be able to see the stack deploying over here. Right? So that's my stack deploying for me. And to be honest, I don't really have to go to the AWS console and check on the progress because CDK provides the same progress on the terminal as well. So that's also quite interesting. Using the CDK, I get to see the entire development experience within the same window. So that's done. While that deploys, let's move on to the next example. So other than the next example we will cover is that of an EC2 instance. So these are the three basic constructs that we have. So in this example, I'm going to use the AWS_EC2 package, which is available in the CDK construct library. This package has a level 2 construct known as instance, which helps us to define an EC2 instance. If we talk about what abstraction this resource is providing us, if I have a look at the machine image parameter, I'll see that I have specified an OS, which is Windows Server 2019. I am not really specifying a particular AMI ID over here. So using this, depending on the region that I'm deploying the stack, CDK is automatically going to detect what is the latest AMI ID available for this OS in the region of deployment and take that as a base to deploy the instance. So I can use this to have almost updated images always available. The second level of abstraction that this is providing me is the last parameter, which is allow all outbound equals to true. So when I deploy this resource, I will see that CDK will automatically create a security group and associate it with the EC2 instance. And within that security group, the mention of allow all outbound equals to true is going to update all the outbound rules within the security group and allow all traffic. I can use the connections method that we saw earlier to allow inbound communication on the security group as well. So do check out that I have not specified or defined specifically a security group resource in this template. That is something that CDK is going to do for me automatically. Right, now let's have a look at the code. So we see that the stack deployment is complete. And what I'm now going to do is deploy the network stack as well. So what I'm going to do over here is use the command cdk deploy star, which will essentially deploy all the stacks that you have defined within your application. CDK is also intelligent enough to figure out if there is dependency between your stacks and will ensure that those stacks are deployed in the required order. So while this happens, let's move on to the examples. And the next one that we're going to have a look is how the CDK helps us to import existing resources. So this is a real world example, right? I mean, we will not always have the luxury to initialize all of our resources from scratch. Typically in any organization, you will have separate teams taking care of separate resources. For example, you will probably have a network team, which is managing your network related resources. You will probably have a security team who is managing IAM roles and permissions, right? So that's fine. Almost each and every resource or construct that CDK comes in supports the import of existing resources, wherein you have static methods, such as if we talk about the VPC construct, it comes with a from lookup function, wherein you can use the VPC ID or the VPC name to import that pre-created resource into your CDK application and reference that in the other resources that you are defining. Similarly, the security group construct also comes with a from security group ID static function. Right, so before we summarize, let's have a look at the deployment, and I can see that the network stack is actually being deployed. And if I go ahead and look over here at the console, I'll see that the network stack is indeed being deployed. So this stack is going to take some time, and we'll let it run its course and move back to the slides. So summarizing the benefits of using the CDK, what it essentially boils down to is the ability to use real code within your CDK applications. And with the CDK, you can use your infrastructure as real code. With this, you get the ability to get code completion within your IDEs. And as a developer, I do not have to learn new languages such as JSON or YAML to define my infrastructure. I can use whatever language that I'm comfortable with and start from there. I can also leverage existing CI/CD practices or code review or testing practices which are already being used within the organization and apply to the cloud infrastructure as well. Some of the useful resources that I would recommend, especially the CDK workshop. It consists of language-specific examples that, as users, you can browse through and get to grips with the basics of CDK. Final parting notes. Each CDK construct library or package has the stability parameter against it. I would advise against using the experimental packages in a production environment. You are free to use the stable packages in your production environments. I would advise always using the level 2 constructs because those are the ones that really provide the level of abstraction that we are looking for. Now, the CDK is a very actively developed product. So if you want to make use of the latest features, it is advisable to frequently update your CDK and go from there. And since the CDK is open source, and you have found a bug or you need a feature, please go ahead and report a request for the same on GitHub. So with that, I thank you for your time. Please share your feedback on this session and join the various AWS user groups out there. I thank the AWS User Group India for giving me this opportunity to interact with all of you. Thank you.
Thank you, Swapnil. That was a really nice and informative session. So we can head over to the question and answer session now because there are some questions from the attendees in the YouTube comment section. So we can start by asking, the first question was, why do you think is CDK better than Terraform?
Right. So if we talk about Terraform, although it does come with some certain intelligence, we will see that it's not real code, right? So the amount of power that a true high-level programming language provides, such as defining object-oriented concepts and the creation of constructs, really comes to the fore. And if I'm not sure if it was evident, but even HashiCorp has joined hands with AWS, and CDK for Terraform is now available. So even Terraform has now realized the true potential of CDK and are leveraging to generate Terraform's files as well.
Right. All right. Thank you. So the next question is, does CDK do state management like Terraform?
Absolutely. So CDK, okay, I'll put it this way. CDK itself does not do state management. CDK is something which is a layer on top of CloudFormation, and it is actually CloudFormation which does the state management.
Right. Okay. So, all right. So the next question is, tell us something weird or maybe interesting CDK bugs that you ran into while working on CDK.
Yes. So I've been involved with CDK for since it was in the beta version, and with every open source project, it did take a bit of time to get healthy documentation out there. So the first bug that I sort of came across with is around the creation of or defining of a security group, because it supports multiple languages. So you will probably, I used to struggle at the time with getting references out there, but since CDK is now quite matured, you have language-specific examples if you browse onto the CDK repository.
Right. Okay. Great. So another question from one of our attendees is that how can we destroy a stack like we do with Terraform? Is it possible with CDK to do the same?
Absolutely. So CDK comes with a CDK destroy command, wherein you can give the stack name and destroy or delete that stack. If you use CDK destroy star, it is going to destroy all the stacks that you have defined within your CDK application.
Right. All right. So one more question is it possible to distribute CDK modules for use in company? And if it is, how?
Absolutely. So I'll give you a scenario. Within our organization, we have defined a custom construct for a typical 3-tier web application, right? So you have your load balancers, your application servers, and the backend databases, right? And this is essentially a collection of 3 stacks, which I have referenced in a separate stack. So it's essentially, if you think of in the terms of object-oriented languages, I'm referencing 3 objects within another class. So that's the power of custom constructs. And we have redistributed this custom construct within our team, which are using this to create multiple instances of any 3-tier application.
Right. Right. All right. So one more question is, CloudFormation now has a testing framework called TaskCat. How do you go about testing infra defined using CDK? Any
Yes.
suggestions from your side?
Right. So that's a very good question. Since CDK, is based on a high-level programming languages. So if let's say if I'm using Python, I can use testing frameworks which are there for Python within my application. I don't really have to depend on CloudFormation supported testing frameworks.
Right. Okay. So we have a few more questions left. So appears that AWS CDK and both BOTO3 library in Python are similar. What is the difference between the two? And in which situation is AWS CDK preferable?
Okay, so I would disagree. CDK and BOTO3 are 2 very different things. BOTO3 is a software development kit, which essentially makes synchronous API calls to AWS, wherein the CDK is a wrapper on top of native CloudFormation. Okay.
All right.
So if you have a look at CloudFormation, it provides you real-time progress of your resource deployments, wherein it is not always possible if you use BOTO3.
Right. Okay. So another question is how to safely restore or roll back to previous state if anything goes wrong during stack deployment?
Yes, so that is where the maturity of CloudFormation comes in. Since CDK is a wrapper on top of CloudFormation, the rollback capability that CloudFormation already has is being used or rather leveraged by CDK as well.
Right. All right. Swapnil, that was all from the comment sections. We have 1 or 2 questions from the community as well. We'd like to know your thoughts on, like you being an AWS professional, what is one of your favorite services of AWS, and like why?
Oh, that's a very difficult question. Which is my favorite service? I would say CloudFormation, because
Right.
Since I started as a developer, and the project that I've sort of worked on, at the very beginning of my career were focused around infrastructure automation, right? So I used to deal with, provision infrastructure on private clouds, public clouds as well. So,
Right.
and that's where I started my journey with CloudFormation. And being from a development background, I always wanted to have a way to leverage high-level programming languages, which I can use in my day-to-day journey. And CDK has done just that.
Yeah, right. So you've said in your session as well. That was a great answer, by the way. We have 1 more question. So as an AWS professional, what keeps you busy on a day-to-day basis? Because we'd like to hear from like directly the people itself who are involved so much into it, that how does your everyday work day look like?
Right. So every day is different. With AWS and with working so many customers across several different regions, what I see that each customer or each workload has various use cases. Each of them have different aspirations, different constraints as well. And as a solution architect, it is quite interesting to how you leverage one particular service keeping each of those different constraints in mind.
That's true. That's true. Thank you so much. That was a wonderful answer. And thank you, Swapnil, once again for joining us here on AWS Community Day today. And I hope all the attendees for the session enjoyed it as well. Swapnil, we'll let you know if there's any other additional questions from the attendees. Please join, log into YouTube, and you can directly comment there as well. Once again, I'd like to thank you for a wonderful session and for your insightful session. And yeah, so thanks again.
Glad to be here, guys. Thank you. Thank you all. Bye-bye.
Bye. All right, that was the end of session. That was the end of the session. After so many informative sessions, I'm sure all of you must be tired by now. So, ladies and gentlemen, we'll be announcing the lunch break right now. We'll be resuming here at 2 o'clock in the afternoon. However, there will be a second quiz that'll be online from 1:30 p.m. Please try to play the game and stand a chance to win goodies. Also, please be on time as we have a lot more sessions to cover. Thank you once again, and please be on time.
Very good afternoon, and we welcome you back. The quiz 2 is now live, and you can take it from the screen. There are some issues with, sorry, let me go on camera. So there are some issues with the leaderboard. So requesting all of you to submit the quiz, and we'll announce the winners by end of day today during our closing notes. Please go ahead and start playing the game. Thank you. Just use your registered email for playing the game if you don't know your booking ID. Hope everybody is back from lunch. Quiz 1 and 2 both are live. We have some issues with the quiz 1 leaderboard, but please submit your answers. And quiz 2 is live fully and leaderboard is available. So please play your chance and win Amazon vouchers for today. Thank you. Hope you all had a chance to play the game. Quiz 2 will be ending by 2 p.m. So requesting all of you to play a chance and stand a chance for winning Amazon vouchers today. Thank you. The top 10 winners of the quiz will be getting Amazon vouchers for today. So for each quiz, quiz 1 and quiz 2, we'll have top 10 winners from both the quizzes. Thank you. There are questions about the winners and the prizes.
Welcome back, everyone. I hope all of you are having a great day so far. Since we're almost done with our quiz for today, we'll be announcing the quiz winners by the end of the show in the evening. Please tune in to know if you have won vouchers. I'm sure everyone has had lunch and is back on track one for our afternoon session. So we're continuing with our technical speakers. The next speaker for the day is Abhesh Rajashekharan. Welcome back. So before we move on to the fourth talk for today's technical sessions, I'd like to remind all of you that we're closing the quiz at 2:10 p.m. We're closing the quiz at 2:10 p.m. just so the attendees can note. All right, so moving forward with our talk four for today, Avesh is the technology senior manager for Thomson Reuters, leading the DevOps and automation teams, a DevOps evangelist and cloud solution architect with a focus on CI/CD, continuous testing, infrastructure as code, Docker container orchestration, and cloud security. He's also an avid learner and has multiple cloud certifications with AWS and other cloud services providers. Let's hear it from him on how they're using Ansible to manage hybrid architecture. Welcome, Abhesh, to AWS Community Day. Over to you.
Hi, thank you. Thank you for the introduction. Hope you can see my screen.
Yes, it's
Yes.
visible.
Cool. So, hello everyone, and good afternoon. I hope all of you are doing well, staying safe and healthy. Today, I'm going to be talking about managing hybrid architecture using Ansible. Without delay, let's jump in. Before we talk more about hybrid architecture and how to manage hybrid architecture using Ansible, I would like to take a minute to introduce myself. My name is Abhesh Rajashekharan. I'm a senior engineering manager with close to 15 plus years of experience in the IT industry. My area of expertise, as it was said in the introduction, is around DevOps and automation, continuous delivery and deployment, cloud solution architecture, security. I have multiple AWS certifications. Most of my experience has been in Amazon Cloud, but I have fair amount of experience in Azure as well. So before we talk about hybrid architecture, let's spend a minute to explain what is hybrid cloud and hybrid architecture, and then go into how do we manage it. A hybrid cloud is a mashup of on-premise and off-premise IT resources. In simple terms, one or more public clouds connected to my data center. There are really a lot of advantages of using hybrid cloud. We'll just one, leverage the computing power of public cloud while keeping the business critical data on premise. There are so many reasons why you might want to keep business critical or customer critical data on premise, maybe due to compliance reasons. We'll talk more about the use cases in the next slide. But while keeping that data on premise, you will still be able to use the computing power of cloud. You will be able to use managed services from cloud and to grow your business. The second advantage is eliminate the need to make massive capital expenditure to handle short-term spike in demand. So what do we mean by short-term spike in demand? So if you're in an industry where the demand for your application depends on market conditions or time frames or events that happen, then you will have short-term spike in demand for your application, and investing a huge amount of capital in handling that spike is not going to be very efficient. So you can still run your application in your data center, but still use the public cloud just to handle. Again, there are a lot of other advantages, but in service of time, we will move on and talk more about why hybrid cloud exists and what are some of the use cases that we have in the industry. So one of the most common use case in terms of using hybrid cloud is for compliance and regulatory requirements. Depending on the industry and the country you are in, you might have to adhere to various compliance and regulatory requirements. A simple example would be HIPAA regulations if your product is in a healthcare industry, GDPR data protection and privacy requirements if the customer European Union. So based on which area your product is in, your industry is in, and based on where your customers are coming from, you might have to adhere to a lot of compliance, and hybrid cloud is a good way to manage those requirements and still ensuring that you can use some of the benefits of public cloud. Another big use case that we have in the industry today is running big data processing in data center is highly inefficient, especially while considering the elasticity that you need and also considering the amount of automation, amount of managed services that are that exist, especially in Amazon. And instead of leveraging some of that public cloud capabilities, if you decide to run that in data center, it might be really inefficient. So running big data workloads in public cloud while your applications are still in your data center is also a big use case. A third big use case is moving to cloud incrementally, and I think this is a very important one, especially if you consider a lot of enterprises who have, for lack of good term, I'm going to call it legacy monolithic application that needs to be migrated to cloud as well. So there is obviously the option of lift and shift, which is in my opinion, it's very inefficient and it's operationally very taxing. So a better option is to basically carve out service by service from your monolithic application and start developing a loosely coupled microservice-based architecture in public cloud like Amazon, and then slowly migrate. So you will be able to migrate functionality by functionality or service by service into cloud, but still be able to run the core application in your data center till everything is migrated, till you achieve that end goal. So hybrid cloud enables you to do that. Another use case in the industry is disaster recovery solutions. This is again not really used as much as it used to be. It's a fairly common practice to use public cloud as a DR solution. It is still used in certain part of the world where the trust towards public cloud is still not as much as we would like it to be. The last option is best of both worlds or multi-cloud, right? Hybrid cloud and multi-cloud is really different in terms of architecture and how it can be used, but having a hybrid cloud mindset and an architecture will enable you to use multi-cloud. As much as I love AWS, the reality is that as a user, as a consumer, the future of cloud is multi-cloud. So based on a consumer, based on specific use cases, the data sets that they have, they will be able to pick and choose what service to use from what cloud provider, and have your application orchestrate across multiple cloud providers, even within a data center within that mix, right? So you will be able to use hybrid cloud design to extend your capabilities beyond one cloud. Again, there are many other use cases, but we will move on. Why to use Ansible? We will talk more about how Ansible is used in the coming slides. But in this slide, I'm just going to talk about why Ansible is a preferred option. One, it's pretty simple in terms of it's human readable automation with not really skills required. Yes, once you start doing some advanced stuff, you will have to understand the programming paradigms. But in general, it's a pretty straightforward and simple language, a simple tool to understand. This is really important if you are, for example, if you're an enterprise and you're trying to upscale an operations team to adopt a new tool and then adopt a DevOps culture and a DevOps mindset. Having a simple tool to adopt really matters. The second reason is it is very scalable in terms of it can do application deployment, configuration management, workflow orchestration, network automation, and effectively everything. So it's very scalable. Agentless, so you don't really need an agent to be bootstrapped for Ansible to work, and it really works in terms of having a hybrid architecture, managing on-premise and public cloud. Cool. So before we Ansible in terms of managing hybrid architecture, we are going to take an example. I didn't want to really consider any real products because real products brings its own complexity. So we are going to be building our own site. We are going to call it mysite.com. My site will be handling tax data for customers. So there is definitely, so due to the compliance reason, some customer data need to be in the data center itself. Big data to run ML workloads in AWS. So there's definitely a use case where we want to run ML workloads, machine learning workloads in AWS. MySite also uses AWS to run multiple APIs. So to explain it simply, we have a UI in the data center. You have a database. Let's consider that database to be Postgres in the data center. And then you have multiple workloads that runs in Amazon. And you need to have the capability to orchestrate this application across your data center and Amazon Web Services. So what does this application really demand from us? In terms of automation and in terms of managing, what does this application demand? One, it really demands the ability to orchestrate and manage infrastructure and application between the data center and AWS. What does that mean? It means that we need to be able to deploy the UI in the data center, and maybe one API in the data center, or multiple APIs within the data center, and the rest of the APIs and the rest of the services in AWS. So you need to have that capability to orchestrate that. We need automation to provision infrastructure in AWS. You need automation to configure infrastructure, application and infrastructure configuration needs to be done in AWS as well as on-premise. You need to provide flexibility to use preferred compute, for example. What that means is you need to have, for example, if you have a service which basically is deployed in AWS, and this one is very specific to AWS, to be honest, we should be able to provide what kind of a compute the developers want to use to run that API, run that service, right? It can run in EC2 in a traditional manner, AMI, AC2, ASG kind of a setup. It could run in containers. It could run in AWS Fargate or EKS. The developer would want to use serverless using Lambda, or orchestrate that Lambda using step functions. So the automation that you're developing needs to have the flexibility so that developers can pick and choose whatever service they want and still have all this automation behind the scene to orchestrate the application. The last one is, with respect to the requirement, is ability to enforce operational compliance. So there is definitely some operational compliance that needs to be enforced. It could be as simple as tagging, naming convention, project code, expense tracking mechanism, or anything else as well, right? So you need to have some ability to enforce compliance as well. From an automation perspective, so we talked about what does the application demand, right? From an automation perspective, what are the additional things that we need to consider? Like we said in the previous slide, we need to have the automation to deploy, provision, and manage infrastructure and application. We need automation to perform configuration management. In terms of configuration management, we are not just talking about server configuration management, we are talking about application secrets here as well, right? For example, you have APIs running in AWS, and you might want to use AWS Secret Manager as your secret to manage all your secrets for the API. But at the same time, for the APIs running in your data center, you might want to use something like HashiCorp Vault. And you need a tool which can actually span across both. You need a tool which can manage your secrets in AWS using Secrets Manager. At the same time, install and configure Vault in your data center and manage secrets in Vault for your application, the parts of the application running in data center. So again, the tool needs to span across both public cloud and your data center. Of course, we are developing an application. We need to have blue-green deployment, and that blue-green deployment should be scalable as well. So how are we going to do this, right? What we are going to do is we are going to be using Ansible as a wrapper for CloudFormation. Before we even talk about CloudFormation, how Ansible will be used as a wrapper on CloudFormation, let's talk about how we are going to manage the infrastructure that we have in the data center. So managing infrastructure using Ansible in data center is actually a very traditional using tasks, roles, modules. It's a very traditional and normal use case that have existed in the industry for quite a long time. So I'm not really going to spend a lot of time there. What we will do is we will spend as much time as possible in talking about how we are going to manage our AWS infrastructure and how we tie everything together. So let's focus on AWS. As I said, managing the data center infrastructure using Ansible is pretty straightforward. You should be able to apply into a web server or a database server, configure everything. It's a pretty straightforward use case. As far as the infrastructure in AWS is concerned, what we are going to do is we are going to be using Ansible as a wrapper around CloudFormation. This is kind of a different approach or a tangential approach from what CDK does, if you're familiar with CDK. But what we are doing here is we are basically developing Ansible playbooks, and we are developing a set of CloudFormation templates. And the set of CloudFormation templates will accept variables from the Ansible, and Ansible is responsible for executing the right CloudFormation template. Formation module to execute the Ansible one or more Ansible playbooks, right? Ansible is also responsible for orchestration of the deployment across the data center and the AWS. Ansible is responsible for determining which CloudFormation template to execute and what parameter to pass to the template. Now, what do I mean by that? Let's take an example. We are going to take example of two services, Service 1 and Service 2, that needs to be deployed to AWS. Now, what are the requirements for Service 1? Service 1 is running in EC2. Service 1 has a dependency where it requires an S3 bucket and for it to function properly. It's going to be containerized. It's going to be running in AWS Fargate. It needs an RDS instance, a database. It's all service or a cluster that needs to be existing for that service to function correctly. So what effectively happens is, let's take this example as a user. Ideally, this part will also be automated, and we'll talk more about that later. But if a user is executing a playbook by saying that for my project, in this case, my project name is my site. For my site, I want to deploy Service 1 to a dev environment. What the playbook would do is it will consume all the variables for the project, for the service, and for the environment. And we will talk more about variables and how variable precedents can be used. I have example slides in the next slide to describe that. But bear with me for now in terms of variables. Just understand that all these variables come from variables file, and based on what service we are deploying, it will know that yes, this needs to be deployed in EC2. So the deployment will be done by using an ASG, and a CloudFormation template for that will be called along with parameters that will be passed by this playbook. The other thing that this playbook will also do is it will also know that since the service requires an S3, it will create that S3 before the deployment happens. It will also create the SQS queue before the application is deployed as well. So what we're talking about is while an application is getting deployed, all the requirements that it has becomes a end automation. At the same time, if you execute saying that I need Service 2 to be deployed as part of the project, my site, Service 2 to be deployed. And in this case, the environment is going to be production. And based on all the variables that we have defined for those specific services and for those environments, will execute, and it will know that this time I need to call the Ansible or the CloudFormation template to deploy the service to Fargate. I will also call the CloudFormation template to create the RDS, update the secrets in Secrets Manager, create an Elasticsearch cluster, and those values will be available for the service to actually function. So the idea here is that your playbook and the CloudFormation remains very static. And what we are actually changing is a set of variables. So you can have multiple projects and multiple services managed just by having these variables defined and by defining the precedence order of these variables. So we talked a lot about variables, and we said we could do everything. We could do magic using variables, right? Let's talk a little bit about how we are actually doing it. So this is an example. Again, this is just an example. I think the actual implementation will have much more values, but we are going to just take this as an example of how the variables can be defined. So you will have a very high level set of variables, which is for your organization. This could be account level information, data center specific information, especially if you have multiple data centers, compliance information, organization level tagging, default options. For example, if you want to set default options for all projects in your organization, if you want to be using a default as EC2 as the default compute type and specific size that you want to default, you can definitely do that. Then what you will define next is the project level variables. This is just an example, but you could have a business unit level variables also in between. But just to simplify for the talk today, I've just taken as after the org level, we're just talking about the project level variables. In this case, our project is my site. So we are going to be defining all the variables that are required for my site at this project level variables, right? So you will have default AMI that I want to be using, or the ALB, observability and monitoring variables. data center specific information, project level tagging. All these comes under the project level. Let's drill in one level deep able to right. So we have a project, and within project we have multiple services or UIs, microservices, lambdas that could be running. So all that will come under the service level variable or one level below that project level variable. So under the service level variable, what are the different factors that we need to consider? One is going to be service level tagging. The other one is going to be service level options. For example, if we're using compute as EC2, then what should be the instance type you want to use? What should be the instance size you want to use? ALB route, certificates, all those things. Then you can have service level specific observability and monitoring values, application and infrastructure configuration information. All those things can be done at the service level variables. Now, what we have not defined here, but I'll show you an example in the next slide where we actually show the playbook, is that you can have within the service, you will be having environment level variables. So for example, at the service level, you could define that the service runs in EC2, and I want to use AMD based instance type for all the instances, all the environments. I could override that by having a prod level environment where I will just override by saying that in production, I want to use some other instance. Similarly, we talked about service or the UI that is running in data center. You could actually define all the variables that are required for managing that service in the data center as well. And what we're looking at here is your environment in terms of AWS as well as in terms of your data center becomes a single project and a single cohesive unit, and you're managing it as if it is a single infrastructure, single piece of infrastructure, even though it is distributed as far as your public cloud provider is concerned and your data center is concerned. From your infrastructure as code, you're treating it as if it's just one big piece, right? This basically allows you to manage your infrastructure as code much better. Now we talked about the variables here. Let's just take a look at how we can actually use that variable precedence. There is no precedent that comes in out of the box, right? So what we're doing here is, and this is a sample playbook that we have defined, org level variables, right? So the org level variables is dot contains all the org level variables. Then we talked about the project. So you can have multiple projects, of course. You can have multiple BUs as well. But for simplicity, we are just considering one project here. We are calling is project.yaml. And within that project, so this project.yaml will contain all the project specific values that we explained here. So basically the org level file is this one. The project level file is this one. And then if you look at the service level file, that is here. That is this one, right? And then the service level service one in this case will have all the values which is specific to service one. And then you will have service one -environment. It could be dev, test, QED, or production, and it will have that environment specific values. Now, the importance of loading this is in such a way is that if you have a variable, for example, you have a default in service1.yaml, you can definitely, because that is the file which is loaded at the last. So this is where the variable precedence comes in. Now, the other advantage of doing this is also that you will have the capability and flexibility of passing. For example, you can say, we talked about if I go back one slide here, we talked about this Ansible playbook, just executing by saying that service one should be deployed to dev environment, right? And again, you're basically just loading that environment specific file. It's not really hard coded. So this playbook effectively becomes generic as well. So for adding a new project or adding a new service, all you're doing is adding new variable files and just managing those. In reality, again, this is an example, so that's why I didn't complicate it further. In reality, what happens is your project will be parameterized as well, and your service name will be parameterized as well. So all these values that you're seeing that will be loaded here will all be from parameters. So your playbook will accept what project, so it can accept what BU, what project, what service, what environment, and it will know what to do with respect to just by loading those variables. All of a sudden, you have a framework which is highly scalable across your organization, but still giving the flexibility for each developer to pick and choose what services to be used. If I come down how we are actually executing the CloudFormation template, we are basically doing that by using the CloudFormation module. And if you look at the CloudFormation template name also, that's also coming from compute type. The compute type is actually coming from one of these variables. So you don't really have to define or hard code which template to execute, right? And the same thing, set of parameters that we are passing, again, we have just shown a couple of parameters here, but the same list of parameters that needs to be passed to the template is coming from the set of variables that you're loading here. So all of this can be pretty fluid. And then you can also use a lot of your programming paradigms within the playbook to make sure that if you have S3 defined, you will execute that. So you can have a list, for example, based on how these parameters files are defined, you can basically loop through them and execute things in a specific way. So this becomes, once this is developed, which is the initial work that we do, once this is developed, this becomes very flexible and scalable to be used across for multiple projects. Before I move forward, I think there will be a couple of questions that you will have in mind, right? So one is, why Ansible as a wrapper? So why not use CloudFormation without Ansible? So why not use CDK is also a good question, but if you're using CDK, again, it's not going to be scalable across multiple cloud platforms and across your data center and public cloud. So that's why I didn't include that. But why not use CloudFormation without using Ansible? It's the same answer there also, right? So you can use CloudFormation, you can use nested stacks and variables to do exactly what we just talked. You will then have to have a set of infrastructure as code or a project that will manage your AWS, and then another project that will manage your data center. Orchestrating your application across this multiple infrastructure pieces will not be easy, or will not be really possible. It will be two different pieces that breaks apart. The other question would be, why not use Ansible modules and exclude CloudFormation? So Ansible modules are definitely capable of doing infrastructure management in AWS directly without really going and using CloudFormation. There are multiple reasons why we should not do that. One is because Ansible modules are not updated as fast as we would like. For example, if you have a service, if you have a new service, or if you have an existing service where functionality changes or option changes, feature changes, the module gets updated a little bit later. The other thing is, if you are working very closely with Amazon, and if you're doing beta, for example, if you want to do a beta on Kendra before it even comes out, you need to still be able to use infrastructure as code to do that beta, but Ansible modules will not be available. So using the right tool, which is the cloud specific tool, which is meant to be in terms of managing that cloud, that we are using that. And then we are still using the abilities of Ansible, the programming paradigms of Ansible, the ability of managing variables of Ansible, and then merging them together and using the best of both worlds. Another reason why we are using Ansible as a wrapper is because managing variables using Ansible is very, very easy, right? Like I said, if you go back here, you can have multiple projects, or basically, as long as these values are parameterized as well, you can just add a new project, a set of services, and all that can be done at a variable level, keeping your CloudFormation and your Ansible playbook very generic and static. What that does is, your change, the amount of change that you have is mostly on the variable side, and the blast radius is much smaller. So when you make a change, the ability to unit test that, for example, if you use the unit test module, if you use TaskCat to unit test, you can changes really fast without really worrying about what else I'm going to be breaking. You have the ability and the flexibility of and overriding values specifically to environment application. So if you have an application which runs ML, which uses ML models within that, it needs a bit more use, it needs a specific type of instance, you can always override that at a specific environment level. Then you can have the infrastructure as code for data center and cloud as a single project. I said that it basically works as a single cohesive unit. It really gives you really better SDLC workflows. Again, managing pull requests, rolling out your code changes will be really, really faster, and you will be able to adhere to those best practices as far as software development lifecycle is concerned. One last reason why to use Ansible is also managing observability and monitoring with third-party tools and as part of automation, right? Um, Again, you might want to use CloudWatch alerts, CloudWatch events. Along with that, you might decide, your organization might decide that you want to use Datadog or New Relic or Splunk, App Dynamics, any of these tools. So you need to have the capability to basically deploy these applications across multiple infrastructure pieces and go to a third party and set up monitoring and observability and APM and trace for these applications as well. Synthetic test. You can go on and on, right? So all these requirements, which are non-functional requirements, should also be part of your automation. So you need to have an automation in place which can scale right from take the code check-in and then build everything, deploy, and do each and every piece that is required for the application end to end. So having a tool, having a design like Ansible will allow you to do that. Managing multi-cloud, right? I spoke about this in the initial slide. The reality is the future of cloud is really multi-cloud. Let's take our example of my site, right? So we decided that we are going to be having the UI and the database in data center. We have your APIs running in Amazon Web Services. Now we decided that we check for a search functionality that we want to develop. Now the spell check, as you cognitive capabilities that are cognitive services, to be give spell check out of the box. It also has Bing search that it gives out of the box. So you might want to use Azure for those capabilities, or you might want to use capabilities and use Azure for spell check. So as a user, as a consumer, I should be able to pick and choose what service fits best for me based on my use case, and still be able to orchestrate my application across all these cloud providers and have my application work seamlessly. So having a tool and a design like this will allow you to do that and manage the infrastructure across different cloud providers. So in this case, as I said, Ansible will be used as a wrapper around CloudFormation. But when it comes to Azure, we are going to be using the AMP templates, and Ansible will again wrap around that. So effectively, what you're doing is using Ansible as a wrapper around all these cloud-specific tools and having the capability to manage your project just by using the Ansible variables and the playbooks. So before I wrap up, I would like to talk about one couple of points in terms of automation, right? So I talked about this in bits and pieces overall during this talk. You need to automate everything. Automate the creation of the application builds right from check-in to production deployment. The end-to-end piece needs to be orchestrated and automated, including your non-functional requirements, monitoring and observability, right? So for doing that, you need to have an architecture that will scale across your monitoring and feature flag platform and all these things. So have an end-to-end pipeline which can be automated. Automate execution of quality checks and approvals. So ensure that quality checks, performance tests, security tests are all baked into the again, which should be able to talk to a Veracode, for example, or any other tool that you want to use for your vulnerability scan or anything like that, and have an end-to-end piece which is orchestrated from, again, code check-in to deployment. Use feature flag platform, using a feature flag platform, right? In hybrid infrastructure, it is really critical. To be honest, it is critical in any infrastructure. For a lot of organizations out there, deploying to production and release of a feature is the same thing. So what feature flag platform does is it really decouples that. So deploying to production does not mean that a feature should be available for a customer. Feature flag platform enables you to have that capability to enable that feature, have that capability teams and business teams so that they can do customer based, can do that so that the product team decides when a feature needs to be released to a customer, but if you decide that everything that needs to be checked in can go through this pipeline, you can move as fast as you want and go to production, but still not have the feature being visible to the end customer. So having a tool like Ansible, which can talk to third-party feature flag platforms like Split.io, and enables you to basically bake that as part of your deployment as well. The last point that I would like to leave you with is architecture matters. I think I will be able to explain that with the next slide. let teams use the right tools. The freedom of outweighs the disadvantages. Accelerate. If you have not read it, I would. The book Accelerate is authored by Nicole Forsgren, Jess Humble, and Jean Kim. It is a book basically for building high-performing technology organizations and how the ability to deliver software have real organizational outcomes. They have really defined that. They have really done a lot of market research and considered over 23,000. A great read. I would highly recommend that. It's up, right? The reason why I have this up is because I want to emphasize that what matters is the architecture and the design that we talked about. Yes, I would suggest using Ansible because of all these capabilities. You could actually flip out and take Ansible out and then switch that with something like Terraform and still have all these capabilities baked in, or Chef have all these capabilities baked in. What matters is the architecture that can scale and do all these features and end-to-end automation that we talked about. My preferred tool is Ansible, but if you have an option of using Terraform or some other tool, you can definitely do that as well. So that basically wraps up the talk. I know we had quite a lot of topics there. So if you have any questions, I would like to answer that now.
Right. Thank you so much, Abesh, for sharing your experience with us here today. It was
Sure.
a very informative session. And we'll move to the question and answer session right now. We have a few questions from our YouTube comment box. So the attendees are asking a few questions like Ansible with CloudFormation versus Ansible with Terraform. What benefits can we get?
So I think I explained that during the last slide, but again, it depends on what level of maturity your team is at, right? So if you have a team which is basically adopting something new, Terraform it's a great tool. I'm a big fan of Terraform as well. Terraform is an area where a lot of development is happening as well. If you joined the HashiCorp conference during the last few days, you might have seen that. So definitely Terraform has its own capabilities, its own advantages. So I will not say that using Terraform versus Ansible there is a benefit, pro or con. It depends on your capabilities of the team and how you want to scale that team going forward. And again, there with respect to org level agreements that you have, whether as an organization for everything or deciding to use Terraform. It could be a mix of both as well. So I think there is you get the achieve the right goals as long as you design the architecture correctly.
Right. I think we missed a bit of your answer here and there in between. I think the network connection issue was there, but it's all right. We got an idea. The next question is, did you run into any unexpected challenges with this sort of approach?
Yes. So we did run into some obviously with every define failure is a really good teacher, right? So with everything that we do, we have to fail fast and learn from there. So for example, if you're using Fargate and the capabilities of CloudFormation to handle Fargate, it is at least it has improved slightly, but it was not when we started using Fargate, when it came out, right? So we did run into missing capabilities, things like that. But the advantage of using Ansible is obviously that you can still go back to using, you can have Python scripts and things like that, which will have, you can actually use programming to back it up. So
exactly, right. Great answer. All right. So So next question is, what types of quality are used for Ansible code?
So TaskCat is a very good tool that you can use in terms of unit testing. I would suggest TaskCat as a tool that can be used for unit testing for your CloudFormation. As far as the Ansible code is concerned, you can use the unit test module. The unit test module that is available, it works really well. Again, you can you can go all the way out and have a way to create your infrastructure, a demo infrastructure, and then basically pull that down as well. So, but in our experience, what we have done, or in my experience, what I have done is have stick to unit testing and making sure that the unit test works fine for both Ansible and for CloudFormation.
Right, great. All right, so we have a few questions from our community as well. So, as an AWS professional, what keeps you busy on a day-to-day basis? I mean, we'd like to hear how you go about your day.
Correct. So, with this we are in a phase where technology is moving so fast, right? So we don't.
Right.
I think we all of us, even when I learn so much. I try to learn so much every day, but time is not enough to learn everything that is coming out, right? So, for example, there were a couple of announcements that came out from HashiCorp yesterday. Great, and there is always an announcement that comes out from Amazon. You need to keep up to pace. Doing a certification, for example, I have 6 certifications with Amazon. Doing a certification does not mean that you stop there, right? You will have to keep on updating yourself. There is new things, new options that is coming out. So that really keeps me busy in terms of knowing the latest and greatest out there, so that when a design option comes out, when an opportunity comes out to leverage some of that, you're actually you know what to use. And then also what to reach out to, right? So Amazon is great in terms of reaching out to them. So with respect to Thomson Reuters, we have Amazon. One thing that we do a lot is we reach out to them, give feature requests, we do beta with them. So that also is a very good option there. So you need to understand what capabilities they want to go as well, and then have conversations with Amazon in terms of what are the new features that you're expecting and how you can use some of that. So again, all these things with respect to cloud keeps me busy a lot. Again, I spend a lot of time in terms of learning, reading, trying it out. I'm pretty hands-on, so I try it out and see how it works as well. So
Right, great. All right. Thanks for the answer. So there's one last question that I'd like to ask you for today. So how did Amazon Web Services or AWS help you to solve some complex problem easily? I mean, some service of AWS or something that you use.
Okay, I think that's a good question. So there is a lot of I think there is so much that I can actually look at. So first simple thing would be, if you want to have a recommendation engine, if you want to build it yourself, it's a huge task, right? But if you look at recommendations, comprehend all these managed services that we have, SageMaker, for example, for running training your models, from what it used to be, SageMaker has really radicalized and changed the whole training model environment, right? So machine learning has changed drastically because of SageMaker alone. You have other options like Kendra, for example, search indexing and searching of documents. That has completely changed. Kendra is basically giving you out-of-the-box functionality that you used to build using Elasticsearch and multiple services on top of that. So many managed options that are available which can be leveraged. And again, the other options are also managed infrastructure. So for example, Elasticsearch. If you have worked on managing infrastructure by yourself, you will understand the pain of doing that. Managed service like Elasticsearch service really scales. And again, it allows you to work with AWS, and they are coming out with more options in terms of making all these managed services better as well. So I hope that answered your question.
Fair point, right. So yes, it did definitely. We did miss out a little bit here and there because of the network problem, but then other than that, that was great. All right, so we'll wrap up the session. Thank you once again, Aves, for coming over here and doing this session for AWS Community Day. It was a very informative session, and I hope all of the other attendees enjoyed the session as well, because I did personally. And so, Abhish, we'll let you know if there are any other additional questions from the attendees. You can also join and log into YouTube, and you can directly comment there as well. Right?
Sure, definitely.
All right, thank you so much.
Thank you.
All right, so that was the talk 4 of our technical session for track 1 today. Tune in to find out who the next speaker for today's session is. Welcome back, everyone. We are back with our talk 5 for today's track 1. Before moving on to the session, I just like you to remind that do not forget to share your feedbacks via lanyard because we'd like to hear back from you. Please share your feedback before the session for today ends. All right, so without wasting any more time, we'll dive right into our 5th session for today. Are you interested to listen to how to automate security using Lambda? Because, well, in this session, we are going to hear Sapna Singh talk about it. Welcome, Sapna. You're live now.
Hello, everyone. Welcome to this talk. First of all, thanks to all of you for attending this session. My name is Sapna Singh, and today I'll be talking about security automation in AWS using Lambda. So about me, I have almost 10 years of experience in cybersecurity. I'm a regular speaker and have been speaking at various conferences. I'm a strong supporter of women in cyber. So working with a couple of communities in India and Middle East to support and empower women in cyber domain. So let's get started. To set the stage, I will cover some of the current trends related to cloud security and to also explain why I'm talking about security automation. By 2022, 95% of the cloud breaches will occur due to customers' fault. 92% IT professionals are worried that their organization is vulnerable to major cloud misconfiguration related data breach. 84% believe that their organization has already been suffered a major cloud breach that is yet to discover. In last 2 years, 33 billion records are exposed related to cloud breach, and that has caused more than 5 trillion to companies. In an average-size organization, there are at least 14 IaaS or PaaS instances running which are vulnerable or misconfigured and trigger more than 2,200 misconfiguration-related incidents per month. And this number is huge. So statistics like these show that there is a rapid spike in cloud-related breaches, alerts, incidents, but 73% teams still rely on manual methods to defend against these threats. With this talk, my objective is to walk you through how we can minimize cloud breaches, alerts, incidents, misconfigurations, reduce delay in response using security automation. So there are several reasons why we should focus on security automation or security response automation. Cloud misconfiguration is one of the common and prevalent reasons for cloud-related breaches. So in my previous company, when management decided to migrate to cloud, developers were happiest. Why? Because now they need not to rely on other teams such as server or operations or infrastructure team to procure hardware or software for them. Rather than they were free to do and launch as many resources as they wanted and free to make changes in the settings or configurations. And that had happened with most of the organization. But if the cloud developers or cloud users not aware about the security concerns and how the misconfigurations can lead to an account compromise, they might end up making the mistakes or misconfigurations. And that is very easy to do in cloud, as cloud providers provide easy to use interfaces where misconfigurations are just a single click away. Most of the cloud services are accessible through APIs. And if APIs are not secure or are misconfigured or have more permissions than required, can also lead to a data breach or account compromise. We have also seen and observed that business units in rush to push the applications into production sometimes bypass the security processes. And it's possible when there is a lack of a strong governance in organizations. In today's scenario, there are hundreds of accounts in organizations and thousands of resources, more than hundreds of developers working on these resources along with other teams. It's kind of difficult for security teams to have control and visibility over who is doing what data is being migrated to cloud, how the roles and responsibilities are segregated. And these all reasons adds up to cloud misconfiguration. So As we are aware that organizations are migrating to cloud rapidly due to various reasons, such as cost optimization, cost saving, for competitive advantages, to provide innovative offerings and solutions to customers. So they have all right reasons to do it. But as we are seeing mass adoption of cloud, security left behind somewhere. And there are a couple of factors and reasons for that. In today's scenario, organizations are not restricted to one cloud. They are on multi-cloud, hybrid cloud. Cloud first strategy is very common. We keep observing new features, new services from cloud providers. And even we can see and observe that with the advent of DevSecOps, now applications and new features are pushed to production not in months, rather than in days and sometimes in hours. We are using Docker, microservices, Kubernetes, and applications are no longer monolithic. They have several moving pieces and components. All these makes cloud highly dynamic and complex in nature, where traditional methods of security fail. We can no longer rely on manual methods of detection or responding to security threats. Lack of trained resources, it is one of the biggest issue in cloud security. Even bad actors are using automation. They are using automated scripts or tools to scan the internet for misconfigured or vulnerable resources. And with that, to address all these challenges, we need to use security automation to ensure that we are defending against all internal and external threats and scaling the security with the business demands. So talking about benefits of security automation, there are several, but some of them are listed here, such as we can enforce regulatory compliance or security requirements in real time, such as GDPR, PCI, or HIPAA. And if not, we have organizational security requirements. Using security automation, we can reduce the mean time to respond, detect, or recover. And using manual methods or traditional methods, we provide long window of opportunity to cyber adversaries. Sometimes they have weeks or months of time to enumerate vulnerable resources or scan it or exploit it. Using security automation, we are reducing that window of opportunity. We are fixing the issues in real time so that they don't have even scope or time to exploit our cloud resources. And by doing that, we are reducing the number of alerts. Our SOC teams, those who are focusing on cloud security, are overwhelmed with number of alerts. And if we are able to reduce that, then they can focus on more critical tasks or strategical tasks. We are also reducing the human error and the customer fault, which is one of the common reasons for cloud-related breaches. By doing all these, we are reducing the security operation overhead and at the end, achieving the goal that is scaling the security with the business demands. There is no hard and fast rule how we can implement security automation, and as each and every organization is unique in terms of people, process, or technology, but we can follow certain rules for successful security automation. First is define requirements. So our automation vision should be aligned with enterprise cloud security strategy and business goals. We should not put our efforts, resources, or budget if something is going to be changed in the next 3-4 months. Maybe business has planned to move from one cloud provider to another. We also need to consider the regulatory and compliance requirements. We need to sit with our security teams and understand the common misconfigurations alerts that they see on a day-to-day basis, and then find out the low-hanging fruits, where we should invest our time, efforts, budget, or resources so that we can get most benefit out of that. And then we can set specific goals. We should not try to automate because other organizations are doing it and they are successful, or just sake of doing it. We should do it because we have a real business use case, the problem that we want to address using automation. We should not try to automate everything and anything at once. Rather than we should define a short-term goal. We can start with 1, 2, or 3 use cases with few services or with few cloud accounts. And based on the short-term plan, we will have understanding the support and challenges that we have in our organization. And based on that, we can define long-term goals. Runbooks. Runbooks are the heart for automation. It contains the minimum steps to address or respond to common alerts or misconfigurations as well as incidents. So once we have a runbook for various kinds of alerts that we see in our environment, it's very easy to convert that into automated solutions. Collaboration. If you collaborate with relevant stakeholders, our chances of success are higher. If we convince various business units, stakeholders, teams such as developers, operations, infrastructure, about the use cases that we want to automate, then they can provide the insight because they are the expert in their own environment. They understand what could go wrong and how things can impact the production applications or resources. They can provide inputs, exceptions, and expected outcomes. So we need to agree with them on security responses for a smoother adoption. And at the last, we can implement our automated use cases, set up solutions, scripts, or templates in test environment to test all the possible inputs, exceptions, which is very important because not everything we can automate 100%. So we need to make sure that we are testing all possible kinds of exception and our stakeholders are happy with the outcome. If not, then we need to iterate it until and unless we have expected outcome. And then we can move our automated solutions to production. So now I'll talk about how we can automate security responses in AWS. So this diagram depicts the 3 different phases to achieve the successful security response automation in AWS. So in monitor phase, we try to collect logs from various sources using automated monitoring tools. Logs from S3 bucket, logs from various sources such as VPC flow logs, logs from WAF or CloudTrail. And in detect phase, we use automated monitoring services or tools to detect the unauthorized activities, deviations, misconfigurations, non-compliance. And for that, we can use services such as GuardDuty, Macie, CloudTrail, CloudWatch. And in respond phase, we try to respond or we try to automate the responses on flagged conditions. In AWS, we use Lambda or step functions. If it is not possible to respond and fix 2 issues, then we can also build the compensatory control around the vulnerable or misconfigured resources, and then can send out the notifications to security teams about the responses or actions that was being taken. So these are the top 10 AWS misconfigurations, basically related to encryption, logging, security groups misconfiguration, authentication related issues, and the one which we normally talked about and most commonly talked about is S3 bucket related misconfigurations. We have almost 5.5% of S3 buckets exposed to internet and have public read permission. So now I will cover AWS Lambda, which I already talked about, that we can use it for automated responses, as well as other core services, which we can use for monitoring and detection purpose. So AWS Lambda is the computing service that runs code in response to events and automatically manages the computing resources required by that code. From the scalability point of view, we need not to worry because Lambda itself is scale when or as per the incoming request and events. As an end user or as a security professional, we need to upload the code or write the code on Lambda console. And once we have uploaded the code, Lambda waits for triggers from various AWS services. And as soon as it receives the trigger, Lambda executes the code to perform the automated responses, remediations, or operations on other AWS resources or services. AWS CloudWatch is a monitoring service for AWS cloud resources. It collects monitoring and operational data in the form of log, matrices, and events. From the security point of view, we can define rules or patterns and then detect the certain condition or desired condition that we want to receive the alerts for, or for which we want to set up the automated responses. So as CloudWatch has event received, then based on the rule, it can trigger the Lambda function. CloudTrail is another important and crucial service from the security point of view, as it tracks all the API activities in the AWS environment. It tracks the API calls made by a user, services, or applications. So it's important that we enable it for all the reasons so that we have all the maximum API activities tracked that we can use for detection of various kinds of anomaly in our AWS accounts. Coming to AWS Config, it's a continuous monitoring and assessment tool that tracks all the AWS resources in AWS account, as well as it tracks the configuration changes. And that is the reason it's a great tool to enforce the compliance for our AWS resources. So now I'll go over some of the use cases and explain how we can fix certain misconfigurations. So our first use case is respond to S3 buckets allowing public access. So more when we come across news that a leaky S3 bucket end up disclosing millions of customers' information or corporate confidential data. Though AWS provides various security features and settings to secure S3, and moreover, S3 bucket is by default private. But then too, it seems that misconfigurations are unavoidable. So this is automated remediation flow for this use case, where if there is any unauthorized changes on S3 bucket, then the changes are detected by AWS Config. Config sends the non-compliance to CloudWatch. CloudWatch triggers or invokes Lambda. Lambda goes and responds to these unauthorized activities and fix the issues, and then can also be used to send out notification through SNS or to the ticketing system so that a security team is aware about the successful auto remediation, as well as they want to do further troubleshooting or understand or investigate what has happened. So this is a demo for this use case. So on this bucket, the bucket ACL is used to allow write access for everyone. It means everyone from internet. So as soon as we save this change, the bucket status is public. On the second bucket, the bucket policy is updated to allow the bucket for read access from everyone. So as soon as we save the changes, we can see the bucket status is public. So if we go to AWS config, we can see the non-compliant resources and non-compliant rules. And for this use case, we have rule defined in AWS CloudWatch, where it receives the non-compliance record from AWS config and then triggers the Lambda function. So this is a Lambda console where we can upload the course or write the course which we want to use for automated responses. For Lambda, we need to set certain environment variables as well as the execution role, which is very important so that Lambda has permission to perform the automated responses. So if we go back to S3 management console again and refresh it, we'll find that the public status is no longer visible. It means our automated response for this misconfiguration is successful. And if we go and check the bucket policy and bucket ACL, we'll see that those are also removed. So let's see what happened in the background and how this use case was implemented. In AWS config, we have already predefined managed rules for various resources or services. Or we can also have our own custom rules as per business requirement. For this use case, there are two managed rules used. S3 bucket public read prohibited that checks if bucket is allowed from internet for read access. And the second is S3 bucket public write prohibit. This rule checks when the bucket is allowed for write access from internet. So as soon as changes are made on bucket that allows bucket to be public for read and write access, these two rules trigger. And then we have a config dashboard where we can see overall compliance status. So how config checks the non-compliance? Config has a previous value, and then after the changes on S3 bucket, now it has an updated value. Config compares these two values, and then the difference is matched against the managed rules. And if that matches, config triggers the non-compliance record. Here we can see this is one of the non-compliance record where we have relevant information such as config rule name, config ARN, compliance type, and S3 bucket name and relevant details. So this is CloudWatch rule where the non-compliance record is received from AWS config, and then CloudWatch triggers the Lambda. So this is Lambda code. So if there are changes on ACL, put bucket ACL function is used to make the bucket private again. If there are any changes on bucket policy, then delete bucket policy is changed and used to remove the bucket policy. So this is CloudTrail event for this particular case. It can be used to provide additional context to security teams so that they have enough information to go and further investigate. It has the information such as source IP address, which was used to make the changes, and user details that can be provided to our security analyst. So our second use case is revert the unauthorized modification to security groups. This is also one of the common alerts or misconfiguration that we see on a day-to-day basis. As the administrators or developers sometimes to troubleshoot certain issues, they allow any to any on security groups or NACLs. Or sometimes to work remotely or work from home, they allow port 22 such as SSH or RDP. This can also happen due to a compromise where there is a malicious agent running inside our cloud environment and trying to connect to CNC center. Whatever the case is, if we have a SSH or RDP open to internet, it means we can expect tons of alerts to our security teams. Or that can also lead to account compromise. And we don't want to be in that situation. We want to detect this issue in real time and then take actions accordingly. So this is automated remediation flow for this use case. When there are changes on security group which are unexpected, these changes are detected by CloudTrail, and CloudTrail sends the event to CloudWatch. CloudWatch triggers the Lambda. Lambda performs the automated responses, remove those rules which are unexpected, and then can send the relevant notifications to security team. So this is a demo for this use case, where on the security group, port 22, that is SSH, is being added and allowed from internet. And as soon as we save this rule, we refresh it and we'll see that this rule is removed. It means our automated response is successful. On the second security group, outbound rule is being added where MS SQL port is allowed outbound to everyone, to internet. So when we save this rule, we'll see that it's visible. But when we refresh the console, it's gone. It means our automated response or remediation is successful. So let's see how this use case is implemented. The unauthorized changes are detected by CloudTrail, where we can see all the relevant information such as security group ID, the rule which was added, and other relevant details. Now, CloudTrail sends this event to CloudWatch. CloudWatch has a rule to filter out the events such as authorized security group ingress, authorized security group egress, revoke security group egress, revoke security group ingress, create security group, and delete security group. So based on this rule, CloudWatch triggers the AWS Lambda. So here's the main code which performs the automated remediation. So if there is any change on inbound rule, then we can use function revoke security group ingress to remove the rules. Or if there are changes on egress or outbound rule, we can use revoke security group egress. So for this use case, we are using two events, but based on our use case or requirements, we can use other events, such as if you want to receive alerts for if somebody is creating a new group or deleting a group, and then take actions accordingly. So this is sample notification that can be sent to a security team so that they are aware that automated remediation is successful. But if they want to further take it and find out the root cause of it, they can do it. Our third use case is automatically enable CloudTrail when disabled. So when cyber adversaries compromise the AWS account, the first step would be to disable the CloudTrail so that they can close their tracks. This can also happen by a mistake or misconfiguration when the S3 bucket is deleted, which is being used to collect the CloudTrail. So this use case can be implemented through CloudWatch, CloudTrail, but I thought to cover more advanced services to give you a perspective understanding that how different services in AWS can be used for security response automation. So for this use case, we are using AWS Security Hub, AWS Guard Duty, and Event Bridge. So AWS Security Hub provides a comprehensive view of current state of the security within AWS account. We can also use it for checking the compliance against security standards and best practices. It can be integrated with security services such as Guard Duty, Macy, or Inspector, as well as other third-party solutions. It gives us a prioritized finding, and that is very easy for security analysts to log in and see what are the findings detected currently. AWS Guard Duty is a threat detection service that continuously monitors the AWS account for malicious activities and unauthorized behavior. It uses machine learning, anomaly detection, and integrated threat intelligence to identify and prioritize potential threats. AWS Event Bridge allows us to route events between AWS services and other SaaS applications. So this is automated remediation flow for this use case. When CloudTrail is turned off, Guard Duty detects this undesired activity and sends the finding to Security Hub in AWS Security Finding format. Security Hub publishes this finding to Event Bridge, where Event Bridge has a pattern defined to invoke Lambda function. Lambda goes back and responds to this undesired activity and turns on CloudTrail again and send the information to security team. So let's see the demo for this use case. So for this demo, CloudTrail is used. We are simulating a cyber adversary and stop the logging. We can see trail logging status is off. We can see the relevant finding associated with this activity in Security Hub as well as on Guard Duty. And then we have an event pattern defined on Security Bridge, which receives this finding from AWS Security Hub and then invokes the Lambda. and we can see the Lambda code here. And if you go back on the CloudTrail console and refresh it, we'll see that trail logging is enabled. So it means our automated response is successful in this case. We can see the associated finding in guard duty, that is stealth IAM user CloudTrail logging disabled. And then on Security Hub, where we can see on the Security Hub finding page, all the findings as well as findings related to this particular use case. This is the pattern that we have defined on event page to receive the finding from Security Hub and then trigger the or invoke the Lambda. This is a sample SNS notification which can be sent to security team for their actions. So with that, we covered 3 use cases and understood how we can fix common misconfigurations. Now I'll cover automation myths. First is automation can replace security professionals. That is not true. Automation is to make security professionals' life easier, to make them more efficient, effective, proactive, and productive. So when we present our automation use cases to business, the questions are something like, can you solve all your security issues with the automation? And the answer is no. We cannot solve all the security issues using automation, but we can minimize the risk up to a certain extent. We cannot automate everything and anything because still we require the human intervention and decision-making capabilities for certain workflows and use cases. We cannot automate and forget about it. We need to review all our automated solutions, setups, scripts to ensure that they have the expected outcomes all the time. We need to make sure that we check it and review it in case of any changes in our organization in terms of people, process, and technology, as well as we need to make sure that we are reviewing it periodically. So with that said, we are on the last slide. And to cover and summarize what we have learned so far today and how we can implement the security automation or security response automation after this talk, first step would be to evaluate the manual processes that can be automated in your organization or for your clients. Then define the short-term goals to understand the support and challenges that you have. And then take the step-by-step approach. Don't try to automate everything and anything at once. We need to definitely have our automation vision in long term and how it can support the business goal at the end. When we try to automate certain workflows or use cases, there are definitely risks. But then we need to balance the risk with the benefits. So these are the references which I have used for this presentation. So with that said, thanks all for attending this talk, and thanks to the organizers for this awesome conference. And now we can start the question answer session, as well as I'm active on LinkedIn and Twitter. So you can reach out to me to share your feedback or if you have any queries in future.
Thank you so much, Sapna. That was an amazing session and a really informative talk. We have a question answer session right now. We can proceed with that. A few of our attendees have written down some questions in the comment box for you to answer. So our first question for today would be, what is the worst security breach that you were associated with ever, and what learnings did you have from it?
So due to the reason that I don't want to disclose breaches related to my companies, I would not be able to answer this.
All right,
but definitely
all right.
the common challenges or the security breaches that we see more often is related to S3 bucket, right, for AWS, or the storage related breaches for various other cloud providers that we see on very often.
All right, all right, all right. So the next question would be, what was the first security automation that you built, and what was the response to it?
First that I built was related to S3 bucket security, because in my previous company we were using lots of S3 buckets, and
Right.
we wanted to make sure that due to misconfiguration and mistake, we would not end up exposing those buckets to internet, because we did not have any use case to expose them. So I built
Right.
that, but it was kind of challenging to implement it because not everyone was ready to automate certain aspects. So with
Right.
the time, we need to convince them and explain them how it will benefit them and how it will benefit us. We don't want to call anyone in midnight that you have
Right.
exposed this bucket to public. So with
Fair
the
point.
time, everyone understood, and we were able to convince about this implementation.
All right, great, great answer, ma'am. So the next question would be, how should we proceed if, according to the use case, we want to, some bucket to be public and some to be private?
You can filter out the bucket names and then or tag. You can tag buckets which you don't want to expose to public, and then you can implement. Tagging is the easier way to filter out the buckets.
Right. All right. So the next question is, moving to multi-cloud environment, how can we make sure that there are no security breaches? And also, can we use CloudWatch and Lambda for multi-cloud environment?
Multi-cloud environment, you have now suppose you are using AWS and Azure. So they have their own services for monitoring purpose, for detection and for response. So you can use that, or you can use the third-party monitoring services as well to make sure that you have a complete visibility over the your all the environments.
Right. All right. All right. So the next question from our attendees was, we can use AI capability to automate for known or right pattern and route them to right team to review, at least to check first level verification to minimize the manual proc. Is that possible in AWS?
Yeah, that's the reason we are using guard duty, because guard duty uses the machine learning capabilities and then detect the anomalies, right? It takes some time to baseline the environment and understand what is undesired, what is unexpected, and then triggers the events and alerts.
All right. Okay. So, so the last question from the comment box is, what technology stack did you use to write security automation tasks that was shown in the demo that you showed?
So basically, as I shown, the various kinds of services that we use, such as CloudWatch, CloudTrail, Lambda, Security Hub, or Guard Duty, Macy, Inspector, as well as couple of automated setups from the open source communities that we try and see what fits to our environment.
Right, right. Okay. So that's it from the comment section, but we also do have a few questions from the community. So as an AWS professional, we'd like to know what keeps you busy on a day-to-day basis. I mean, what does your regular workday look like?
So first of all, I will say that I'm passionate about AWS security. So I keep learning about new security services and various settings and features that AWS releases. Recently, I have also passed AWS security specialty and preparing for AWS Cloud Architect certifications. So I make sure that I keep learning new technologies, tools, services related to AWS and from other cloud providers. On a day-to-day basis, my job is to review the current setup or new projects that we are going to migrate to cloud, as well as finding out the gaps, recommend to the various teams, work with them, understand their concern, provide them recommendations, and some part of monitoring as well, and pen test.
Right. All right. That was a great answer, ma'am. So one more question would be that what was one of your favorite services from AWS? And did it like ever help you solve a complex problem or something in your job?
I would say there are many services, but as I'm talking about Lambda, I will say Lambda because it helps us a lot. We can do a lot with using Lambda, and there is no administrative management effort that we have to put in. It's easy to use.
All right, all right. So this Lambda was the first AWS service that you came across and you used?
No, not Lambda. Lambda we use after a long time. Initially, we
Right.
used config and CloudWatch and CloudTrail. We turned this
All
on
right.
for long. I started working on cloud, I think around end of 2014. And Lambda, maybe we started using in 2016 or 17, because initially our main job was to make sure that we are setting up detection properly, as well as monitoring. And then when we started receiving like huge number of alerts, then we focused how we should reduce it, because we cannot cope up with that like a huge volume of alerts on a day-to-day basis.
Okay. True, true, true. All right. All right. Thank you so much, Sapna. I hope all of you enjoyed the session. Ma'am, we'll let you know if there are any additional questions from the attendees. You could also, meanwhile, log into YouTube, and you can directly comment there as well. Thank you so much once again for attending this AWS Community Day with us. It was a pleasure having you on board with us.
Thanks, everyone. Thank you all.
All right, so with that, we end our session 5 for today on track 1. For the next session, please stay tuned here. We'll be putting up this poster very soon. All right, welcome back, everyone. We have our next speaker lined up for today for talk 6. Our next topic is serverless beyond Lambda functions and will be delivered by Shushit, Head of Engineering and Confab. He got the first taste of serverless by participating in the AWS Chatbot Challenge and fell instantly in love with the technology, and the unparalleled passion for Lambdas henceforth began. Regularly speaking at conferences and meetups in the serverless community, he started the first serverless-focused meetup group in Bangalore, contributing, presenting, and encouraging young, passionate members to pursue the same, which currently blossoms around 5,500 members. Let's put all our hands together to welcome Shushil.
Hello.
Hi, Shushil. You're live now.
Hi, thank you. Hello, everyone. So this is Rishit. I'm the head of engineering at Confab, and today's session is about serverless beyond Lambda functions. So let's get started. A little bit of introduction about myself. I'm the head of engineering at Confab, a serverless consultant, a co-organizer of one of the largest serverless meetup groups, that is the serverless architecture meetup group in Bangalore, and I'm also a mentor at Girls Group Bangalore. So if you guys are interested in serverless and want to discuss or talk about anything, you can follow me on Twitter, you can follow me on LinkedIn. I'm pretty much active everywhere. I'll be more than happy to talk about serverless. So let's get started. Okay, so I'm pretty sure you guys have already understood from the previous sessions about what is serverless and where it is coming from, what is the evolution and stuff like that. But before, I thought I could start just a brief introduction for people who probably needs or joining now and needs a little bit of intro. Serverless, this is how serverless has evolved over the years, right? So we had physical machines, then we had virtualization that came into picture, then cloud. Then came containers, and then serverless. So at each point in time, there is one level of abstraction that has happened, and one level of problem, if you think about it, is taken away from the developer's perspective, and one less thing to be worried about. And with serverless, it is all about the business logic that we write, and nothing else. We don't have to manage any infrastructure or any sort of scaling and stuff like that. We don't have to worry about anything. The cloud provider, in this case AWS Lambda, takes care of everything for us. And as an individual developer, our main focus is to just write business logic and solve real world problems. So that is what it is, serverless. And I'm pretty sure most of you already would have explored, or from the previous sessions would have understood what is serverless and things like that. So without getting much deeper into the introduction part, I'll just get started with the topic for the day. So as the topic talks about, it is serverless beyond Lambda functions. So most people perceive that whenever we talk about serverless, it is going to be just Lambda functions, but it is not the case. If you guys have built any small, simple applications or have worked with AWS Lambda in production, you guys will understand that Lambda is just one small, tiny piece. Of course, it takes a lot of, it does a lot of things, but then still, it is just one small, tiny piece, right? You need various other services to come together and play as a team, like an orchestra, where they all perform some wonderful music for us, for the application to be up and running and like scale automatically and all those things that comes with serverless, right? So this session is not going to talk about what are Lambda functions and what can be done, what are the triggers and what are the event sources and stuff like that, but it is going to be about how we will be leveraging various other services that are also serverless, but then which are very less talked about, or which are less explored. So that is the thing that we will be focusing on today. And the first service that I would like to talk about is the AWS step functions. I don't know how many of you have already used step functions, but this is one of the services that I feel is not very much touched upon when it comes to the serverless world, where people talk about okay, if you think about it, if you think about the various sessions and the getting started things, you will understand that people talk about Lambdas, there's API gateway, there's DynamoDB, and then how you collaborate or how you integrate all these three services and bring up or build a small simple application, right? And then there's an S3, and then we have IAM and all sorts of things, right? But when you come to real world, there are a few things that we'll have to take care about, right? One of the few things is, so when you build a real world application, it's not just one Lambda function or two Lambda functions or three, right? You have a proper application, you have a proper product where you have numerous Lambda functions. I mean, you have a lot of functionality that needs to be done. So if you go by the best practices of Lambda functions, it is about single responsibility principle, right? Each and every Lambda function should do one and only one thing. If you go by the principle, what it states that you have like 50 features that you want to implement, and then there are 50 Lambda functions if you take one Lambda function per feature. But then in real world, it's not the case, right? What happens is you have multiple Lambda functions per feature. So the number of Lambda function goes exponentially the moment your product or your application grows in complexity and more and more features are added to the application, right? So what is the problem? So serverless is very, very simple, very, very easy to get started. There's no problem at all. I mean, I'm pretty sure whoever have just got started with serverless would find it, oh, this is amazing. You just have one create button in the AWS Lambda console. Go there. There's a boilerplate code ready available for you. Then you have a designer where you can simply add an API gateway, and you have a REST endpoint for you, and then done. You have a hello world application, right? It's very, very simple and straightforward to get started with, absolutely true. But the more and more we dig deeper is where you, I mean, like any sort of technology, right? It has its own pros and cons, right? With Lambda functions, what I personally feel is the more the product increases, the number of Lambda functions exponentially increases, and then playing all of them together becomes a little tricky. The monitoring, everything becomes a little trickier. So this session is going to touch upon a few aspects of all those things to help you guys build serverless applications and try to leverage all the various other services, not just Lambda API Gateway, but the other services that can help you build really good, amazing serverless applications. Again, Lambdas as such are a wonderful service. I mean, they can scale automatically. We don't have to really configure anything much. I mean, minor configurations like the timeout and then the runtime environment and stuff like that. But as such, there's no heavy configurations that we will be doing when we are building Lambda functions, right? But that's what. When we are building serverless applications, it is not just the Lambda function, but it is all the various other services that come into picture. So let's get started with the first service, that is AWS Step Functions. Now, so what exactly is a step function? I mean, if you guys, for people who have already used it, they would understand that it's sort of a flowchart that helps you orchestrate your application flow, user flow, while building your applications, right? I'll be touching upon a simple example as well. Before I go there, let me just explain you what exactly a step function is. So as I told you, in real world applications, you have numerous Lambda functions, and for one feature, you will have multiple Lambda functions that are doing their designated purposes, right? So when we have multiple Lambda functions, it becomes really important that as a user flow, you call one Lambda after another, after another, after another, right? There's a user flow that happens. So each and every Lambda function has to be called upon in a specific order. So you have to orchestrate the Lambda function's execution so that the user flow is maintained and you achieve your functionality, right? So there are multiple ways how we can do that. One way is, you can call a Lambda function, let's say Lambda 2 from Lambda 1. So after execution of Lambda 1, we can call Lambda 2. After Lambda 2 executes, we can call Lambda 3. So stuff like that. So we can obviously code for that in our application itself. In our, let's say you use Node or Python, we can use the SDKs to call the second Lambda function or third Lambda function based on the execution. That is one possibility. But imagine, which I will be showing a little complex user flow where, let me just show you that. So this is a simple example, right? Where you have a little complex flow where after one Lambda function, you want to do something else. And based on the response of Lambda 1, you want to execute either Lambda 2 or Lambda 3 and stuff like that. So there's some kind of a conditional execution that you want to achieve with your Lambda functions itself. So with step functions, step functions offer this out of the box for us, wherein so we can orchestrate the Lambda function. Let's say you have 10 Lambda functions and you have a specific user flow. Then what will happen is you can define that as a simple JSON, and AWS will take care of executing that step function so that there's an order now. You have one Lambda after another, after another, after another. So there's a proper set flow chart, like I showed you, that executes and your user flow is executed. So instead of we hard coding or rather invoking one Lambda after another, we can simply use step functions, which gives us out of the box things. Now so invocation is one part of it, right? There are various other things. So a few of them I've mentioned here. One is the orchestration. So it really helps in orchestrating the Lambda function instead of we in the application code orchestrating for the same. So you're moving out the orchestration logic from the application layer and keeping it one level higher, so that the flow doesn't actually really creep into the application logic, right? So that is the orchestration advantage that we get. But then there are multiple other things. The other one is parallel processing. Like I mentioned just before some time, based on the response of the first Lambda function, I want to decide what I want to do. Instead of me actually writing that code, let's say, for example, it's a very simple thing. I don't want to handle at the application level, but rather what I will do is write it, code for it in the step function. And let's say Lambda 1 returned an array of 3 objects, right? And for each of the object, I want to perform a different, or I want to perform some computation, right? So instead of we handling all sorts of things inside the Lambda function, where we write a for loop, and then based on the number of items that we get from the response, we execute the for loop and stuff like that. Instead of all sorts of things, we can simply leverage the parallel processing from step functions. What it does is, based on the response, how many other objects that I get, I will trigger so many Lambda functions in parallel, and for each of them, I will start executing individually. Now, what is happening is, I don't have that for loop in my application, and I don't really care about whether am I getting an array of 1 object or 3 objects or 15 objects, right? All of that logic is extracted to the from an infrastructure point of view. It is extracted to the step functions, and it is no more at the application level. So that is one of the advantages of what we have from parallel processing. And the next one, which I find is it's very useful, is the retry, time wait, and conditional execution. Like I said, based on the response of one, execute the other, and sorts of things. That's the conditional execution, right? And apart from that, we have retry and wait logics also built into step functions. Now let's take a simple example. We have one Lambda function that connects to, what happens is, let's take a simple example, where we have a simple application where people upload their visiting card, okay? And in the visiting card, we have the address as well, the business card, right? We have the address of the person as well. So what we want to do is, before we update to the database, I want to verify or store the geolocation of that particular address. So I would want to call the Google Maps API or something like that, a third-party API that gives me the lat long and stuff like that. So what will happen? I run some image. I run recognition, which is another AWS service, to understand what is the text that is available on my business card. I'll understand that this is the location. I will call the Google Maps API or any location API and get the lat long, latitude and longitude, and store it in my database for further processing. Now, let's say for some reason the Google Maps API is timing out, or you have crossed the rate limit for that particular minute or that second. There's some kind of limits, right, for any API. Now, what will happen is, in the application, what we generally do, we handle such kinds of errors. So after calling the Google Maps API, we would have a try-catch block to ensure that if at all there's any problem, I catch that. I wait for some time in my application to ensure that, because I'm pretty sure my third-party API that I'm consuming is actually very reliable. There should be some reason, some network issue or some rate limit, or for a split second, Google Maps API is down, right? We never know. So stuff like that. So what we'll do, we'll have a retry mechanism in place in our application logic. So after 1 second, just try it out again, so that you probably can connect to Google Maps and get me the latitude and longitude. Now, such kinds of retry logics, which really is not at the application level, I mean, it is not really dependent on a service that you are building, but from a third-party service or a service that is not probably very reliant or stuff like that, we try retry logic. We write retry logics. So what step functions offers us is, instead of we retrying that as a part of our application logic, we can retry for a specific state. So in step functions, we call states. So we have tasks, we have states. So where each state can be handled, we can have a retry logic for every individual state. And if at all the Lambda function fails for a specific reason, because we are already catching it, right? So we know why it is failing. So we can configure saying that if at all this Lambda function, which is responsible for connecting to Google Maps and getting the latitude and longitude, is failing for a reason for, like, let's say, a rate limit, then wait for a couple of seconds and retry again. So stuff like that is extracted out from the application logic and is written into the step function configuration. Therefore, we don't have to do anything. Everything is taken care. So that is one is retry. Then that is one simple example of retry. Then we also have another advantage, that is the time. A lot of times what happens is we have multiple Lambda functions running in parallel, and we want to wait until the previous Lambda has completed, right? For, let's say, for example, we are dependent on a file that is being uploaded into S3, and that processing is being performed by another Lambda function, right? So we really don't know how long that might take. It might take a few seconds extra. So what we can do is, either in our application logic itself, when I'm triggering two Lambda functions parallelly, one Lambda function to upload the file, processed file to S3, and the other function to probably read that from S3 and perform some kind of another operation, right? Instead of me handling that wait inside the Lambda function, instead of me saying time.sleep, like something like that in Python, right? Where you wait for a few seconds before you actually start your execution and stuff like that, what we can have is we can have a state in the step function itself, which waits for a few seconds. Before I execute my next Lambda function, I'll wait for a few seconds because I want to be 100% sure before I get into the next Lambda function, I want to be sure that the file is available for me, right? So all these kinds of stuff, which can be extracted out from the application logic, which we don't really have to code for, can be written into simple JSON in step functions. That is the power of step functions that gives us when we are building a stateful model. Again, one thing that I actually forgot, which I should have started with, is basically Lambda functions are stateless, right? So basically, one Lambda function does not really know the context or the state of another Lambda function, right? With step functions, it gives us the capability to pass the state from one Lambda function to another, because we are now building, it's a state machine where we are trying to build a state machine and try to orchestrate different Lambda functions to work for one single feature or one single user flow. So these are the various features of step functions that, and trust me, it is very, very simple because it is simple JSON that we have to configure for. And the retry logic, the wait logic, all the things I have told you is a simple JSON configuration that we write, and then it simply gets executed. I mean, AWS takes care of executing those Lambda functions for us. Now, this is just the pointers that I just talked about. It helps in orchestrating the various services for our Lambda functions. I mean, we have multiple Lambdas, we orchestrate it. And then, as I told you, it helps us build stateful services, whereas Lambdas by default or serverless applications by default are stateless, but step functions gives us that capability to build a state inside the application, I mean, for our user flow itself. Now, as I've already mentioned, it has the capability to do parallel processing as well, and easily integrates with various other AWS services. I've been talking about Lambda functions alone, but step function also integrates to various other AWS services as well, that you can trigger from your step function. Instead of using a Lambda function to trigger another service, you can probably use a step function. After the execution, a successful execution of my Lambda function triggered this. So sort of things that can be done with step functions. It's not just about Lambdas. A lot of the retry, time wait, conditional execution, etc., are provided out of the box, and we don't have to code for that. And as I said, it's a simple JSON configuration that we will be doing, nothing much. Now, this is a simple example of, let's say, when we are ordering on Swiggy, or when we are ordering on any food ordering application, right? What happens is a user places an order. The moment we place an order, the restaurant is actually notified saying that here is the here is the order for you. You have to start preparing this item. And once the item is prepared, the user is also notified saying that the item is prepared for us. And then what will happen is we will, the delivery guy is notified. There's a bunch of process or flow that happens, right? So to put it in a simple architecture diagram like this, what it happens. So here is, this is one kind of way of dealing with this application of food ordering. So this is what is called as choreography, right? So there are individual Lambda functions, and there is someone who's taking care of. I mean, they are choreographed to perform a dance, right? So they are choreographed. So each Lambda function has its own responsibility, and they have their own triggers and sort of things. And the moment there is a trigger, the Lambda function executes and goes down, right? So this is what is called as an event bus, where we can trigger various Lambda functions based on the inputs that is coming in, and the Lambda functions based on the events that is coming in, and the Lambda functions get triggered. So the moment there is an order that is placed, so the user is placing an order via an API that is integrated to a Lambda function, and that triggers an event bus, which is nothing but an event bridge, and a message is pushed to the event bridge. And based on the message that is being pushed, the dedicated Lambda functions picks up those messages and start executing whatever they need to do, right? And once the order is placed, and we have accept order, complete order, various very simple application, right? We have quite a few flows. So this is how it would work if it is an choreography. This is one way of doing things. Now, the problem of doing this, absolutely, this is a wonderful architecture, this is a wonderful way of doing it, right? But what is the issue, or what is the problem with doing like this? I mean, the advantages, what are the advantages? Let's start with that. The advantage is that each and every Lambda function is independent, and they can scale, and they can be configured, and they can be changed as such. It's not really tied. They are very much decoupled, right? So they can be changed. They can be. It's like a building block, right? Where you have Lego pieces. You have one Lego piece that you want to fit into the architecture. It can simply come in, and based on the events that is happening, it can come up, execute it, and go away, right? So that is what happens with this kind of architecture, where you have individual pieces that are very much decoupled, and there's a very much scope of a very good scope of reusability, where, let's say, for example, notify user is not just for when an order is placed, but let's say, for example, I have a promotional offer, something like that. So all those kinds of things also can be done by the same Lambda function, and can be triggered. So that is the advantage of this kind of an architecture, where we can reuse multiple things, and they are pretty much decoupled, because it's all event based in it, like in any application, right? Now, this is another way of doing it. That is the step function way, which is called as the orchestration, right? So what we do here is we have specified user flow that talks about after notifying the restaurant. Then I have defined saying that after the notifying, I have to wait for the restaurant to accept it. Then once the restaurant, as I told you, this is the conditional execution that I was talking about. If the restaurant has accepted it, then notify the user, wait for the restaurant to deliver, and then complete the order. If at all the restaurant is not accepting for whatever reason, let's say, for example, suddenly it started raining and all sorts of things, right? So we can directly cancel the order. And if at all there's some problem while delivering or while preparing the order, we can have a catch block. So as I told you, we can have retry mechanisms. And apart from that, I can have a constant try-catch block sort of a thing, where I can catch for any error in this flow, and I can call the cancel order and stuff like that. So all of these are also possible with step functions. So this is another example of how we can architect such kind of an applications. One is the choreography way, the other one is the orchestration way. Now, what is the cons of the previous approach? In this approach, it becomes it is sort of difficult to monitor it, because there are so many Lambda functions and they're sort of very much decoupled, right? So the monitoring and the flow of how the events are passed from one to another is sort of debugging, if you think about it, becomes a little trickier, because we don't know where exactly it is failing. So it becomes a little trickier when it comes to so much of decoupling. But whereas here in step functions, as I told you, I know exactly where it is failing, and I actually can have a catch block for a specific state, saying that if at all, for whatever reason, the complete order failed, I can have a catch state to do something else and stuff like that. So this is the advantage of writing with step functions. The other advantage is because we are configuring this as a JSON, it becomes as a part of our infrastructure as code, right? It goes to our source control and it starts being a part of our Git. So anybody who's trying to look at this application, look at this user flow, they can clearly understand what is happening where and what is failing where. So that is one of the really good advantages that I feel about step functions. So various use cases of step functions is batch processing, automated tasks, state management, as I told you, where you can maintain a state while for a one particular user flow, and we of course have application orchestration, which we talked about. So if you ask me, step functions are really wonderful, and they help us in serverless applications. As I told you, orchestration is one of the challenging things, and maintaining state, of course, is another challenging thing. And step functions actually help us solve that problem. So that is about step functions. The next one we have is AWS AppSync. As I told you, the topic for today is about not just Lambda functions, but then how we can build serverless applications itself, right? AWS AppSync is a managed GraphQL service from AWS, which helps us write GraphQL APIs. As simple as that. I don't know how many of you guys have built GraphQL APIs, but on AWS, it's AppSync, the service that will be used. For people who have not used or worked on GraphQL, here's a very, very basic introduction. I don't know how, I think most of you guys have already seen this image, right? So GraphQL helps us, I mean, it gives the power to the client to ask for what they want. In a REST API, it's as simple as your api.com/a burger. I want a burger, as simple as that, right? And the server, or in our application, the Lambda function will return a burger. Now, what if I want customization on top of that? I don't, like I showed, like in this example, where I want a burger, but I only want the bun, the patty, and then the bun, and then lettuce. So it has that, it gives the capability for the client to actually ask for what they want. And whereas in REST API, it's like, okay, you want this, that's all. We don't, the client doesn't really have the capability to ask, okay, I only want these parts of the response, right? So GraphQL is very much picking up, I mean, a lot of amazing applications and a lot of amazing services that we can build GraphQL APIs for, and AppSync is one among them. What are the advantages of using AppSync? Highly scalable GraphQL APIs. So AppSync is again a serverless service. So of course, like you all know, when it comes to serverless, what are the advantages, right? The basic advantage. So what can you term when can you term a service as serverless? One thing is you don't have to take care of or manage the infrastructure. The second one is you are charged only for how much you consume, pay as you go, the true pay as you go model. And then we have scalability. So we as the application developers don't really care about the scaling of the application, right? So these are the various characteristics or attributes, if you ask me, which can be classified for calling a service a serverless. So with AppSync, we can build highly scalable GraphQL APIs. We don't have to manage anything, just like API, right? We don't have to manage anything. Everything is taken care by AWS itself. And the other advantage of building GraphQL APIs, and especially with AppSync, is it gives us out-of-the-box capability for WebSockets called as subscriptions. So in GraphQL, we have three kinds of things. One is queries, mutations, and subscriptions. Queries are like the GET APIs of the REST world. Mutations are like the other operations, like update, delete, and stuff like that. Create, right? So with GraphQL, it is queries, mutations, and subscriptions. So subscriptions is like a real-time data push back from the server to the application, and we use subscriptions for doing the same. And with AppSync and GraphQL from AWS, it comes out of the box. We can simply write a subscription or define a subscription and integrate it with the Lambda function, and everything is taken care of. So that is with the subscriptions. The next very, very important feature or thing that is very underrated sometimes is the fine-grained access control. See, with REST APIs, what happens is we have an authenticated API, you have an access token, or you're logged into Cognito, then you can access the API. Simple and fine, right? That's wonderful, right? If I want to access the API, I have to be authenticated. Wonderful. But think of a scenario where I want the API to be open, but if you want to access some really sensitive information, then you either have to be authenticated or you probably have to be the owner of that particular record in the database and stuff like that, right? A simple example. You have a blogging website and you have a number of blogs that is being displayed, right? And you don't want and it's an open blog. So anybody can come to the blogging website and they can simply look at the blogs, read about it and stuff like that. But apart from that, let's say, for example, every blog author has an email ID. So the email ID we don't want to expose to our non-logged in users for whatever reason, right? What we can do is with AppSync, we can have fine-grained access control saying that not at the API level where based on the authentication, I will return the response. It's not going to be that. Rather, what I can do is I'll return the response. But if you're asking for something, as I told you, GraphQL is all about you asking me what you want. And if you're asking me for some really sensitive information, you better be authenticated. So stuff like that, we have single API, and AppSync gives us the flexibility to have authentication, not at the API level, but at every field level. So if I want to return the email ID, I should be authenticated. So stuff like that, this is a fine-grained access control, which I personally feel is really amazing. So that you don't have to build two sorts of APIs. One is the public API where we are not returning the email address, another authenticated API where we are returning the email address as well. Instead of doing it two times, we can leverage the fine-grained access control of AppSync itself and return only the necessary information for people who have the right access. So it's, as I've already mentioned, it's a managed GraphQL service that can scale to millions with ease. Easy integration with DynamoDB and RDS. Again, for people who have not used AppSync or GraphQL, so what happens in AppSync is, generally what happens with API gateway? We have an API gateway, we have a Lambda function, then we have a DynamoDB. So we trigger the Lambda function to get some data from the database. Let's say, for example, DynamoDB or an RDS instance and stuff like that, right? Most rather than not, what happens is we use the Lambda function just to transform the input or transform the output, correct? Most of the times, they say that, okay, get me this user details. What we will do, we'll go to the database for this user ID or username or email ID or whatever it is, get the data and return the response. Simple, right? We write a Lambda function for that. Instead, API Gateway also has this capability where we can directly connect to DynamoDB instead of having a Lambda function in the place for just transforming or transporting the request from one service to another. And with AppSync, it is even better because we can actually connect to an RDS instance as well, like an Aurora serverless instance, where we can write some simple SQL queries, and in AppSync using VTL as resolvers, we can write simple code in VTL to connect to different data sources and get the data without writing a Lambda function. If you ask me, the best serverless application is an application that does not have a Lambda function, right? We have to write as much less code as possible, correct? I mean, the whole point of serverless is to move away the infrastructure. I mean, we don't have to take care of infrastructure, just target the business logic. And I'm telling you, if we can achieve something that can be written without the Lambda function itself, that's an even wonderful application. Like I just mentioned, we can directly connect AppSync to a DynamoDB or an RDS instance. The same thing can actually happen with API Gateway as well. You guys should explore that. It's incredibly easy to build WebSockets, as I said, using subscriptions. Then we have fine-grained access control, and we also have Cognito-based group authentication and authorization mechanisms that is available for AppSync. The next service that I would like to touch upon is the Aurora serverless. I think there was a session in the morning as well about Aurora serverless. So what is Aurora serverless? So it is a SQL database, if you want. Like we have an RDS, right? We have the serverless mode in RDS, where instead of having a normal RDS where there's limitation on the size, limitation on the number of connections and stuff like that, AWS came up saying that, until a few years ago, one of the blocking points or for building serverless applications was Lambdas can scale beautifully. There's no problem. But my database, it is an RDS instance. There is a limit on the number of connections that can concurrently happen to my RDS instance, correct? Now, my Lambda functions can scale to infinite, but my database cannot. So it's sort of a bottleneck or sort of a limitation sometimes, because so now you have I generally use this terminology where you have a Ferrari body and a normal let's say a four-wheel vehicle engine, right? You have really good powerful body available for you, but you don't have the enough capability to run faster, right? So then came Aurora Serverless. So the database itself can scale automatically without we configuring for anything. I mean, of course, see, there's a star with everything that I talk about, right? You still have to make some configurations, but just to talk in the general terms, we don't have to really worry about the connection management that is happening or the storage capacity that the DP is having. All sorts of things are taken care by AWS, and we have an on-demand auto-scaling DB for us, and it is still a MySQL database, or we can have Postgres, all sorts of things. Right? We don't necessarily have to shift to DynamoDB. In a couple of years back, most of the people were really worried about saying that, I really love Lambdas, but the problem is my database cannot scale. And the scalable database that I know of is DynamoDB. But that's a NoSQL database. I cannot convert my relational data to NoSQL just because I want to leverage AWS Lambda, right? Now, that is when we have Aurora Serverless coming into picture, and that is, it automatically scales and we don't really have to worry about it. Now, use of data API, no problem of connection pool. This is another really wonderful advantage of Aurora Serverless, is that we don't need to have any connections. I mean, we have something called as data API, where we execute SQL queries via an API itself. We don't necessarily connect to the database and manage those connections. We don't do that. We use the data API, and AWS takes care of using the data API. AWS takes care of managing the connections, and based on the number of connections that is happening via the data API, the Aurora Serverless scales as and when it feels like, and it can scale down as well. Obviously, it's a serverless database after all, and then it's of course cost effective, because I don't have to necessarily touch upon this, right? Because your database is scaling as your requests are coming in, as the load is increasing, and then it automatically comes down. So you're charged based on how many ACUs, we call it as ACUs in Aurora Serverless, where based on a number of ACUs that is being consumed at a given point in time, we actually are charged. Instead of always having a really large instance, it is very much elastic. It constantly keeps up and down based on the request that is coming in. So we have the Amazon Aurora Serverless is an on-demand auto-scaling configuration, as I told, easy querying with data API. We don't necessarily have to connect to the database. We can use the data API to run SQL commands, and that connects to the database. Auto-scaling with no configuration, as I told you, no problem of connection, pooling, or management. It's very cost-effective because it's going to be per hour building, and that per hour also is based on the number of ACU units, Aurora capacity units that we are consuming. So it is going to be cost-effective based on the load that is happening, highly available storage, and this is best suited for variable workloads. Like any serverless application, you have very unpredictable or variable workload, then this is the best. And just to continue on the advantages, no CPU credits to monitor, no commitment to a particular availability zone. So Amazon Aurora takes care of that. And then the various things that I have talked about, no instances to manage. It's a serverless thing, of course. And encryption at rest is enabled by default, and no need to manually suspend, resume, or scale database. Everything is taken care by Amazon itself. So the various use cases for the Amazon serverless that I could think of is when we have periodic jobs or reports that we want to run daily, weekly, it's not something that I want to run 24/7, but something that comes up and comes down based on every daily or some kind of a schedule, right? Stuff like that. Then we have dev test environments. This is one of the really, okay. With Aurora Serverless, there's one more thing that I missed to talk about. Is there's something called as DB Autopause. What exactly is DB Autopause? So whenever there's no connection or any activity on the database goes to sleep. So the database actually sleeps, and as long as it is sleeping, we are not paying anything to AWS. The true serverless mode, right? Because we are not consuming anything, so we don't pay anything for consuming the database service. Now, where is this advantage? So one thing that you guys have to remember is this DB Autopause is wonderful, but the problem is the startup time is close to 30 seconds. So let's say, for example, there's no activity on the DB for, let's say, 10, 15 minutes or for half an hour is a configurable time. Let's say there's no activity for 30 minutes, the database goes to sleep, and there's a new request that comes in. It's not like a Lambda function that is just instantaneous, that comes up, executes, and goes. This is a database, right? So it takes a little bit of a time to come up, and based on my usage, it's close to 30 seconds it takes. And for production loads, it's not acceptable, right? You cannot ask your user to wait for 30 seconds for your application to be up and running. So that is why it's very much suited for dev test environments. But then we enable pause only for dev test environments. For prod, we don't enable any pause time. So either there is activity or not, the database keeps running. So there's no problem of cold starts, and there's no problem of 30-second limit. But the advantage is your dev and test environments are not being charged so much. We are not running it 24/7, right? It's dev test environment anyway. People, the developers or the testers can wait for 30 seconds for the database to come up and running. So it is very much suited for dev test environment to enable the DB Autopause, and whereas for the production, just leave it as is, and you have the advantage of the scaling, the pricing, and everything. So automatic adjusting to load capacity. So the last service that I want to touch upon is the RDS proxy. Now, for people who are traditional to RDS and they really love Lambdas, but they want to bring both together, right? Aurora serverless is one option, but what happens is a complete different variant of RDS. But you have an RDS instance already present. You want to have it, excuse me, have it as a part of your serverless application, right? What are the limitations? I just talked about the number of connections that can happen to my database instance is limited, but for my Lambda functions, no limit. They can constantly scale. So what happens is you have an RDS instance, and then we have the client applications. We have RDS proxy that sits between the client applications and the RDS database. So the RDS proxy so we don't connect to the database directly. We connect to RDS proxy, and proxy connects to RDS database. So the proxy takes care of managing the connections and reusing the connections that is already available. So what will happen is the bottleneck that we had down the stream, because of my APIs can scale, my Lambdas can scale, but my database cannot scale. So now what will happen is we are trying to move away from that bottleneck and use RDS proxy as a barrier, so that I'm not overwhelming my RDS instance, but my RDS proxy takes care of managing all the connections for me before it can connect to RDS instance. So that is about RDS proxy. It is the RDS proxy is fully managed, highly available database. The scale, as I talked about, right? Generally, RDS has a scaling limit based on the number of active connections for a given point in time. So that is now moved out of RDS, and RDS proxy takes care of that. We have improved database efficiency, application scalability, and security, because now from the application, we are not connecting to the database. Actually, we're connecting to RDS proxy. So we have one more layer of shield for us from the data itself. And then the best part is combining the best of both worlds. One is RDS and serverless itself. So now we have a proper application that can scale to what my serverless is, my Lambda functions are capable of, and everything downline can help me, or there are no bottlenecks or stuff like that that can slow down my application. So that is pretty much about the session today. Thank you so much for everybody who have attended. And once again, this is Rishit. You can connect with me on Twitter or LinkedIn. I'll be more than happy to discuss about serverless.
Thank you so much, Rishit. That was an amazing session, and it was really interesting. We actually do have a lot of questions from the YouTube comment box. Right, we can see you better now. So we
actually, I didn't know that I was in the dark.
All right, no. You were visible still, but then now you're more visible. So then we'll start with the questions. Right, so the first question from the comment box at the attendees is, will the step function fail then if one of my Lambda functions go beyond the 15-minute limit? Will I have to handle such error scenarios?
Yes. So any of the state that is not handled, or there's no catch block assigned to that. So if the Lambda function itself times out and we are not actually handling for it, the step function itself fails. So actually, if you think about it, that's a good thing, because there's a step function that is failing, and I don't want to execute anything further because there's some reason that it has failed, right? I don't want to go forward in my execution. So if at all it's something that is going to be very common for whatever reason, then we can have a catch block, and that catch block can handle this and can succeed the step function itself, and can probably send out an email or trigger some other notification so that someone can take a look at it.
Yeah, right. All right. So the next question for you is, what are your thoughts on Lambda extensions?
Oh, yes. I actually wanted to add this as a part of my presentation, but then it got launched like a week back, if I'm not wrong. So to be frank, I've not explored it myself yet, but I can see a lot of use cases where we can have much better, integration with observability and, security related integrations that can happen. Let's say, for example, a Lumigo or an Hexagon and stuff like that. It gives a lot of flexibility, but personally, I have not tried it myself. That's my weekend task, actually.
All right. Great. That's great. So there's another question. Can we do auto scaling of Aurora in different regions? And if so, how does the sync process work?
Can you repeat that? Auto scaling of?
Yes, sure. Auto scaling of Aurora in different regions. And if that happens, how does the sync process work?
Okay, so if I'm not wrong, so AWS takes care of that. All we have to do with Aurora serverless is we have to just configure what is the maximum ACU units that I want to configure for my application. So AWS automatically takes care of scaling. So we don't really write a auto scaling logic or auto scaling rule. AWS takes care of that for us. We don't have to worry about it.
All right, great. So the next question for you is, because of cost difference in step functions in Lambda, I tend to add more complexity to Lambda and drop step function. So is there a particular advantage of using step function that beats the cost?
Yes. So of course, see, as I told you, step functions is not about just the conditional execution or stuff like that, right? So it is a user flow itself where you're maintaining a state. Now, what happens is, let's say, for example, we want to execute one Lambda after another. You want to pass the state from one to another. Now, when we pass a state from one to another, there's a limit on the payload size as well, right? Let's say you want to pass a very big input or an event object itself from one to another. There are some limitations, and I personally feel you are moving away some unnecessary code that's not really helping you with your application. It's moved out of your application logic. It's not getting into the application, the retry logic and stuff like that. It's not really helping me with my business logic as such, right? So you move it out, keep the application very simple, let it not know anything about failures, you handle the failures outside. And the other advantage, as I talked about, is it becomes a part of the Git itself, right? The user flow and everything is now part of the source control, and you have a proper user flow to visualize and see where it fails.
Fair point. Right, that was a great answer, by the way. So we have a few questions from the community as well. So the first question is, as an AWS professional, what keeps you busy on a day-to-day basis, and how does your workday, like each workday, look like? That's something that all of us are very interested to know from all of the speakers.
Okay, so my day-to-day work is pretty much into serverless. I build serverless applications, and it's pretty much playing around with Lambdas and all the other services that I talk about, and a few more as well. It's pretty much it, actually, and that's how my professional work is about. Yeah.
Looks like great. But then that's pretty interesting in itself, right? So, all right. So, what is one of your favorite services of AWS, and has it ever helped you, solve a complex problem in your work or something like that?
Yes, I mean, without any doubt, I'll go with Lambdas. I mean, there's a biased decision if you ask me for why I like Lambdas. I actually started working directly with Lambdas. A few people who have already attended my previous sessions would know that I actually have never created a single EC2 instance until now. I directly jumped into serverless, and it's been amazing of how easy it is to build and how easy it is to get started with. So undoubtedly, it has to be Lambdas, and I keep talking about saying that Lambdas are going to be the supercomputers are talked about, right? Where there's some really interesting. I feel that Lambdas are one day going to be a supercomputer at every developer's hand.
That's a great answer. So the last question for today for you is, what was the first AWS service that you used? It was Lambda, I think.
No, actually, I started with Lex, which is the chatbot service. And then because of Lex, I started getting into Lambdas as well.
All right. Great.
Yes.
But then again, I'd like to tell you that this was a great session and the best ending we could have asked for today's technical sessions. Once again, we hope all of you had an exciting day today, and thank you thank you to come on the AWS Community Day and for letting us know all about Lambdas. And once again, I would like to thank you on behalf of the community of AWS. Thanks.
Thank you so much. Thank you so much.
All right. So that was the end of our technical session for today. We hope all of you had an exciting day today, meeting so many interesting people and attending all of these sessions. At the end of it all, I'd like to invite Partha to announce the winners of the quiz and to deliver the vote of thanks. Partha, your screen isn't visible. Can you hear us, Partha? Could you just switch on your camera and unmute?
Can you hear me now?
Yes, we can hear you now.
Okay. Thank you.
All right, the camera is not on, by the way, just to let you know.
No, I just powered on my camera.
Yes, I still not visible.
Now good?
Nope, I still can't see it. All right, just a second.
Rohit?
I think the problem with your bandwidth or something. All right, if
No,
it's a problem. Switch it off and switch it on again, maybe. Try it once again. All right.
Now okay?
Yes, I think Rohit is saying yes. I think I still can't see it, but I think Rohit can. Let me just check with him once more. Second Partha. I still think it's off. Have you put like a cover on your webcam or something? Can you just check that?
No, no. I can able to
Nothing, right?
see
All
myself
right.
and you.
It's still not visible here, though. Okay. No. Not on the screen, though.
Let me switch on. Let me try again.
All right. We can see you. Say that. We can see you.
Now?
Yes. You're perfectly visible. All right. So carry on with the session.
Okay. Let me share my screen.
All
One
right.
second.
Yeah.
Able to see my screen?
Yes. Great. We can see your screen. Perfect.
Okay. Thank you. Sorry for the inconvenience caused. So we hope all of you had an exciting day today hearing from the experts. So better, I'm just going to give you the small announcement here. Let's start with the announcement of the winners for both quiz and the best tweets. So I would like to invite Sridevi to announce the quiz winners for the morning as well as the afternoon quiz. Sridevi, over to you.
Oh. Thank you so much, Partha. Hope everybody had a great time with quiz. We understand we had few glitches with quiz 1, but still we had 1,000 plus participation in quiz 1 today morning. And for quiz 2, we had 800 plus participation. So considering the huge response we received for the quiz, we have increased the number of winners from 10 to 15 per quiz. So it's really great to see a lot of participants finishing the quiz within 20 to 30 seconds. Actually, we were unable to finish the quiz within the time. We are the ones who created the quiz, but still, we see a lot of people finishing it faster than us. So great going. The winners of quiz 1 is displayed on the board. So the fastest finger of quiz 1 is Prabhakar Singh. And we have the next set of 14 people who will be receiving Amazon vouchers. And congratulations to everybody who participated and who are on the leaderboard and winners today. Thank you for your participation. And the fastest finger of quiz 2 is Parinit Kaur. And we have displayed the next 14 people on the slide. Again, it is really interesting to see the toppers on both the quiz are students, and great going. And I'm really personally happy to see students on the leaderboard topping with 15, 16 seconds who are just starting their career. So congratulations to all the winners. Before I close my note, just a disclaimer. So all the winners will be contacted and the details will be verified. If there is any disparity, they'll be disqualified. Thank you. Hope you enjoyed the day. Have a great day and great weekend. Thank you. Over to you, Pata.
Yeah, thank you, Sridevi. And the next one is best tweets. We have validated couple of Twitter posts and we have consolidated the top 10 winners. The winners' names are listed here. So we will reach out to you over the email in couple of days. Again, all the winners will receive Amazon voucher for best tweets. And last, I would like to thank, first of all, I would like to thank Jeff Barr for accepting and delivering the keynote for the day, which gave us a great day. And special thanks to all the speakers who shared their experiences and knowledge and use cases with all of us today. And we would like to thank Hari, Ganesh from the CodaHub team, as well as our community partners for their support as well. So, and the event would not have been possible without the support from user group volunteers. So who came together from different part of India and organized this wonderful event. So and one more thing is event at this scale need more volunteers to support, and we had an amazing group of student ambassadors who played a key role in making this event grand success. And I would like to thank all the student ambassadors and volunteers who helped us for this grant event success. And the behind the screen, we are working with a couple of folks, and I would like to thank Reshmi, who is the driving force behind each and every one of us. And also she put a lot of effort to make this event grand success, and we definitely want to thank Reshmi also. And we would also like to thank Suman and Rohini for guidance and supporting us with all the community activities, community day and meetups and etc. And with that, all above, we thank all of you for attending this event with and we hope all of you had a lot of learning from this session. Please join the local user group and be part of us. And we look forward to seeing you all in the next offline community day very soon. Thank you.